data-driven world, everyone is trying to use their data. But how to use their data? What are the way we can actually use my totally unstructured or a messy data? If I can use them, I know I will get a good amount of insights. For that, we can predict our business. We can really make some growth in our business. How we do that? Yes, that's where data mining comes into the picture and the whole data science industry comes into the picture, right? So this is we will see in this particular video, and we have a full course on data mining, how we can use our data, right? How we can make use of those data and get insights from them, how we can predict our data. Before we get started, I want to introduce you to Great Learning Academy, a free initiative by Great Learning, where you can access over 200 plus courses with 1000 hours of free content on trending high demand domains such as data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps, management, and many more. That is also for absolutely free. Award-winning academicians and leading industry experts design these courses. You can also get a free certificate of completion when you enroll and complete these free courses. You also get access to the presentation, code, notebook, dataset, and quiz. You have courses in English and Hindi to give you the best learning experience in the language you are comfortable with. Check out the description of this video to access the relevant courses on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out any new update or video release from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video any queries or suggestion, and I will respond to your comments. First, we are going to talk about basics of Python. If you do not know Python, you don't need to worry about it. We will start with what are the Python things you need to know to start your journey with data mining. Then we will move towards the introduction to Python libraries. What are the libraries we have in Python that are mostly used for data mining as well as for data science? Then we will jump into the data visualization using Python. Like obviously we are going to use the libraries for that. We will talk about that. What are the libraries are going to use for data visualization? Then we will see what is anomaly or outlier detection. These all comes under data mining because they try to help you to solve your messy data in a proper structured format. Your data has no, particular limit when it's messy, but while you are actually trying to use those data, you try to understand there should not be any outlier. If you really want to know what is outlier and anomaly detection, for that you have to keep tuned for the full video, and you will get to know how this outlier detection is going to work on the data. Then we will do a regression analysis in data mining. Yes, what is regression? Again, we will talk about that, because for your heads up, regression is nothing but finding out the relationship between two particular variables. We will see what is regression. And then we will talk about the classification analysis in data mining. How you can do a classification analysis when you have a discrete type data set. What is discrete type data set? To know again what is discrete data set or what is continuous value data set, you have to continue watching this particular course. And please do let me know how you feel about this course. If you like it, do not forget to like and subscribe Great Learning. Last but not the least, we will do a cluster analysis in data mining. All these three concepts like regression, classification, and cluster analysis is going to help you to understand your data more and obviously to mine your data, right? To get a good insights from your data, right? So let's get to this course from basics of Python. How can we actually start with Python? So let's start with that.
In this particular module, the basic module, we are going to start with basics of Python. So we will know why should we learn Python and what are the basic things you need to know about Python to start your journey with data mining. So let's go and let's have a look at the agenda. So first, we are going to talk about the introduction to Python. Then we will jump into how can you install Anaconda and Jupyter Notebook, which is nothing but the IDE, which is integrated development environment, and we will also look at what are the other IDE we have for Python. Then we will jump into the variable and operators concepts in Python. Then we will see what are the data types we have in Python, and we will also look at the conditional statements. What are the conditional statements we have and why do we need conditional statement in our programming language? And this is what we are going to talk about today for the module objective for module 1 for to start your journey with data mining. So let's start with introduction to Python. So why do we actually, how do humans communicate, right? The first things comes into our mind, why do we need Python? Why do we need a language to communicate with our computer? Yes, the same way a human communicate with each other, we need to have a language to communicate with our machine, right? That's why we need Python. Python is nothing but a language by which you can give the instruction to your computer, by which you can make any kind of a, instruction to make your work done. Now, there is one thing comes into our mind. For each and every language has their grammar associated with that, right? But how we need to have a grammar in the language when we are talking about, the computer you are trying to communicate with. Yes, we do need to maintain a grammar for all the language. Suppose we are talking about in English. I am saying I am Sam. You can understand that there is a person who is known as who is Sam. Now, instead of I am Sam, if I just say it, am Sam I, will you understand what actually I want to say? You will find there are few words associated with each other, but there is no meaning associated with that, right? Yes. So grammar helps us to understand a particular sentence with a particular meaning. If you just put the words haphazardly or abruptly, it will not make any sense. Only you will have the words. The same goes with the Python, or you talk about any other language which help you to actually communicate with your computer. So the basic part you have to remember, you have to know the grammar. Now, suppose how do we speak with computers, right? The first things comes into our mind. So again, we have few language that we are talking about. We have Python, we have Java and C++. These are nothing but the language. They have few different syntaxes by which you can communicate with your computers. You can give instruction to your computer, right? Now, let's move further. Now, as we are talking about the grammar, so here it's the grammar for your computer language. Let me give you an example of how this grammar is going to work. Suppose you are going to write import pandas as PD. So you can understand, I just want to say, hey, import panda, there's a library in Python as PD. The name of the library I will call after that as PD, right? So there is nothing but you are giving an alias to your particular, library called pandas. Now, if I just do the same thing and I just don't maintain a proper grammar for that, if I just write pandas import PD as, you will get an error, right? Why? You will get an error because your computer will not understand what instruction you are giving as to perform, right? It will give you an error and it will say, hey, whatever you are saying, I am not able to understand. Can you please check what you are saying? Yes. So this is where grammar comes into the picture when we are talking about any computer language, right? Now let's jump further and let's have a look at, I do understand why do we need programming. Just to communicate with my computer, I need programming. Okay, let me give you the other example. Why do we need programming? Suppose someone said, hey, do the multiplication for 2 into 2. What will be your answer? Easily you will say it's equals to 4, right? But if someone is going to say, can you give me the multiplication for 209 into 2034? You will say, okay, let me give some time and let me take a while and I will get back to you. Because if you are not someone who has really good grip on maths, it will take time for you to do the multiplication. Whereas when we are going to use a programming language, if you just put your number, you will get an output within few seconds. Alright, I know this is a very basic, requirement I'm saying why do we need programming, but trust me, for these particular things also we need programming. Programming makes our life easy, and programming also said, hey, you don't need to worry about it, you just need to write the code, your program or your work will be done. Right? That is why we need programming. We have lots of application using these particular programmings. We will talk about that as well. How this programming making our life easy and how this programming are evolving around us. Right? Let's jump towards the applications of the programming language. Let me give you the example of the applications and let me explain you how these applications are going to help us to making our life easy. Suppose you are someone who loves to play games. Did you ever think where these games are coming? Where you are getting this, GUI, that, graphics user interface, how you will get that? How the, programmers are making it? Nothing but your answer will be programming language. Maybe they are using Python or Java or C++. And they are making these cool stuffs and these cool programming games, right? And these games are making your life easy. You love to play games. It will make you refresh and all these things, right? Yes, this is where gaming comes into the picture. Now comes banking. As we know, in the past days, we used to go to bank and we used to wait for the long queue and then your work will be done. But now these days we have online transaction. We have online banking. How it's going to happen? Again, not only the banking part, we do have hospitalized, if you go for hospitals and if you want to check is there any bed is there or not, you can go and check that out in their websites, right? Or maybe if we talk about ordering food, right? Or if we talk about ordering our cab, right? Or just for going for online shopping, how it's happening? One and only reason behind it, the programming language. Using programming language, we are making the web applications, and by using that, what's happening? It's making our life easy. We don't need to go out and everything will be, whatever you want, you will get that. Yes, this is what programming languages are doing right now. Now, last but not the least, if we talk about machine learning, we all quite used to with this term artificial intelligence, right? We are really doing some cool stuffs like object detection, or maybe we are doing facial recognition, emotion detection, gender detection. I mean, there are lots of application we do have. How we are going to do that? Again, the answer will be programming languages. So you can understand how programming languages are needed in our life every possible way. And you don't need to know a programming language to use these particular things. This is how it's making our life easy, right? So these are the applications we have for programming language. Now we will see what is Python. So now, as you can understand, Python is nothing but a programming language again. Now we will talk about few things about Python. Why Python is getting popular, why do we need Python, and how Python is making our life easy. Right, let me give you the example of that. Python is a popular high-level object-oriented and interpreted language. Now, if you ask me what is high-level, okay, for giving instruction to the computer, few of the time we have to look into the low-level language. In the case of Python, you just need to write a normal code, and that code to be in a, if you know English, you can start writing Python code, right? It's a high level language and it's already interpreted language, right? Now comes object oriented. It's a whole total concepts. It's a object oriented programming, and all the features we have under ops, we will get everything in Python. Now again, interpreted is nothing but your language is interpreted. You don't need to interpret by yourself, right? So your language is capable enough to understand what command you are giving in English, right? And one more thing about Python. Python has really no syntax. It's basically making your life easy. In Python, you just need to maintain one thing, that is nothing but the indentation. You have to maintain the indentation in Python. We will do a demo anyway, and that time you will understand how Python is going to work with, right? Let's go further and let's have a look at the benefits of Python. Why do you need to learn Python? Why I am pushing you towards Python, right? Let me give you enough reason for that. You will also can think, okay, Python is a good language anyway, and it's going to make our life easy, and I don't need to scratch my head to learn Python, right? So let's have a look at the first reason. Web development using Python. If you are someone, if you have idea, or if you want to make your own web application, the example we were giving, and if you want to use Python, then you have lots of frameworks to work with. Suppose Python has Django, and Python also has Flask to work with for web development. You heard me right. This frameworks helping you to make your web application in a proper way. Also, you don't need to do all the things by yourself. There are lots of predefined libraries you will get in Python. Now, if you ask me for the second reason, the length of the program is short. Let me give you one insight what its first things comes into our mind. When we think about a programmer, the first things comes into our mind, a programmer needs to work with thousands lines of code. Yes, the first things comes into our mind. Maybe as a programmer, I have to write lots of code. Trust me, with Python, maybe you just need to write codes, lots of codes, but the length of the program is really less. Let me give you a quick example of that. Suppose you want to print hello, right? You understand? Now, if you want to write this in Java or C++, at least you have to write 3 lines of code. Whereas in Python, you just need to write 1 line of code. Can you get the difference between them? Yes, that is why Python is one of the most popular language these days as well. Now, if we jump into the Python, the main thing you need to know, Python is simple. If you are someone who is not from a programming background, and if you just want to learn a programming language, Python is for you, because again, you don't need to write lots of syntaxes. You don't need to remind lots of syntaxes. What you need to do, you just need to maintain the indentation, right? So it's simple and beginner friendly. Now, mathematical computations can be done easily. Suppose you are someone who wants to go for data science or artificial intelligence, or someone from a maths background want to make your work automated with Python. That time, if you just need to write lots of mathematical expression by yourself, it's really hectic to do that. But trust me, like Python has its own library to work with, and this library has already implemented those mathematical functions. You just need to call them and your work is ready. That's all. You can understand how easy it is. Now, last but not the least, as we were talking about, suppose you are a gaming developer and you want to make your cool graphical user interface, then again, Python is for you. So you can totally understand what are the benefits we have in Python. Why Python is the one of the most go-to choice these days, and why it's getting popular these days as well. Yes, we do have lots of features in Python. Now I will show you how can you install Anaconda and Jupyter Notebook. But before that, let's have a look at what is an IDE. Why do we need an integrated development environment, right? The IDE full form is integrated development environment. Why do we need that? and why we are going towards this IDE only. Let's have a look at that. So IDE stands for, as I have already said, Integrated Development Environment, right? Now, if I just talk about proper coding environment, what actually I want to mean by proper coding environment, I will give the example for that as well. Okay, helps to develop a full-fledged application, right? Suppose you are writing a code in an IDE. What else you will get? Suppose you need to write the code, you need to run your code or execute your code, and you have to debug your code as well. So if you write a program in a notebook, right, we can do in a two-way. One, in an IDE. One, you can write a code in a notebook or notepad++, and then you have to go to Python console, right, using your command line and a Python environment basically, and over there you have to write Python, and then you have to give the path for your file where you have written this notebook, right? Now there are few problems you will get. Suppose you will get an error, it will show you error and with the line number. You have to count manually, and you have to go and you have to check what problem you have in your code. Alright, one problem is this. Suppose you are writing code somewhere, you are executing your code somewhere, and again when you need to debug it, you have to go back to notebook, right? This is hectic. Now if I just compare with an IDE, what you need to do? You just need to write your code. You can execute code in one place, and then if you get any error, you can directly go there and it will automatically make a red line on that line and you can change it, right? And debugging your code and testing your code is also very simple with IDE, right? So you can totally understand what is an IDE and why do we need an IDE. Anyway, we will talk about why do we need an IDE later as well, right? So it helps to develop a full-fledged application. If you want to develop a full-fledged application using any IDE, then you can go for any of them, and we will talk about what are the types of IDE we have anyway, right? Now again, our question is, why do we need an IDE? So as I have already said, you can write, test and debug your code in one place. That's why we need an IDE. Now if I go down the making the next reason that why do we need an IDE, it basically makes coding experience comfortable. Yes, if you are writing code somewhere, you are executing your code somewhere and getting an output and again go back to your notebook, it's really hectic. But if you just write your code somewhere and you have option to execute your code over there and also testing and debugging, it's easy, right? That's why it's making our coding experience easy and comfortable. And as we are talking about in the case of text editor, you need to have two proper parts. One is text, that is nothing but your notebook where you will write your program, and then editor you have, right? Then that is nothing but the command line. So you have to write your code in notebook and then go to command line, and you have to give the path in the Python environment, and then you have to execute, right? It's really hectic to work with. So yes, using IDE, everything can be done in an IDE in a very easy manner, and it's nothing but making your life easy, right? So you can totally understand what is an IDE, why do we need an IDE, right? And how IDE making our life easy. Now I will show you how can you install Python, and also I will show you what are the types of IDE we have. Now let's go to your favorite browser. Now I am going to write install Python, right? If I just write Python, right, now you will get the first link over here. Click on the first link. Then you will get an option to download, right? Okay, then you will get an option to download Python 3.9.1, the latest version of that, right? Just click on download, it will automatically start getting downloaded, right? Looking for Python with different OS, Python for Windows you will get over here. You will get for Linux and Unix for here, for Mac OS over here, and others for here. right? So depending upon your different types of operating system, you can download the feasible version for Python, right? So this is how you can install Python, right? Before again, one thing I have to include, before go for any IDE, make sure you have downloaded Python in your local system, right? Now I have shown you how to install Python. Now let's have a look at the popular IDE for Python we have. We do have PyCharm, right? We have PyCharm, like it's from JetBeans, right? And if you want to go for IDE as a PyCharm, you can go for that. Then comes Anaconda. Yes, we do have Anaconda, and that is known as Jupyter Notebook, right? If you want to check out the Jupyter Notebook installation, you can check that out. And yes, you have to go to this www.anaconda.com. Anaconda install. If you just write Anaconda install, you will get the first official site for them. You can go there and you can just check that out. Can you check your data science toolkit? Then go to download. Then your different operating system, maybe it's for Windows. Okay, so maybe it's for Windows, maybe it's for Mac OS or Linux, right? You have to go there and you can see 64-bit, 32-bit, right? And you can see this is how you can download this Python, like the Anaconda installer, and that is which is an IDE for Python, right? You can do this right away. And if we go back, we do have Google Colab. There is a plus point for Google Colab. You don't need to install anything. It's by Google for the AI researcher, and it gets lots of features. Basically, for our demo, I'm going to use Google Colab, and I will show you how Google Colab has the lots of features. And the best part is you don't need to install anything, right? Yes, so this is pretty much about the IDE we have in Python, and there are a lot other IDE also have, but these are the basic IDE you can go for, and you can start your journey with Python, right? So the Jupyter Notebook is an open source web application that allows to create and share documents that contain live code, equation, visualization, and explanatory text. Uses include data cleaning, transformation, numerical simulation, statistical modeling, machine learning, and much more. So basically, Jupyter Notebook is a package, you can say, where you can do anything that is required in data science, or the languages are actually supported by Jupyter, that is R and Python, right? So if you want to go for data cleaning, data processing, or if you have a huge amount of data, that is also can be solved using Jupyter Notebook. You can clean your data, you can transform your data, and if you want to do some of the numerical computation on your data, that is also can be done. And if you want to use some of the predefined machine learning techniques or algorithms, that also you can do using Jupyter Notebook. Now let's have a look at the popular IDE of Anaconda. So if you want to install Anaconda, you need to go to their official website. So what is Anaconda and how Anaconda is related to Jupyter Notebook? So let's have a look at what is Anaconda. So Anaconda is also a navigator, is a desktop graphical user interface, that is short we know GUI, that included Anaconda distribution that allows user to launch application and manage Conda packages, environments, and channel without using command line commands. So basically, what you can do, you can just, if you want to install some of the packages using pip, you can actually directly install those packages. I will show you how can you do that. Now let's have a look at what are the tools we have in Anaconda. We have PyCharm, that is also one of the most used Python IDE, that is integrated development environment. We have Jupyter Lab, we have Notebook, we have Spider, and many more. Now let's have a look at how can you install Python. Before start with Anaconda, be sure that your system has Python. If your system does not have Python, then it will not support any IDE. So before start with any IDE, be sure that you have Python installed in your system. And I will show you how can you install Python and how can you install Anaconda as well. Now let's have a look at
some Python libraries. But before start with Python libraries, how can you install Python libraries on Jupyter Notebook? Let's go to the website and let's check how can you install that. So just open a new tab and just write anaconda.com/download and you will directly go to their download page. Let me just do that. Yes, you can see I have entered the Anaconda web page, and here you will get some of the options like products, pricing, solution, resources, blog, and company. Right, so this pricing is basically for the commercial use if you want to use Anaconda for the commercial purpose. But if you don't want to use for the commercial purpose, then it is free of cost and it is open source. So you can see we have, this is a open source, this is a Conda packages we have, and manage environment. So these are the extra features we get when we go for Anaconda. Now I will show you how can you download that. You will get a sign over here that is known as download, right? Just click on that. You will directly go to what system you have. For my case, I have Windows, but if you have Mac OS or Linux, that is also possible. You can see there are the option we have for Anaconda. So my system is 64-bit. According to your system, maybe your system can be 32-bit or 62-bit, right? So in that case, according to your system configuration, please download that. You can see I got a pop-up. I'm just going to close it. You can see it's already start downloading. So I will wait for a few minutes to download these things, and then we will start installing the process. It's a quite big file. Maybe for that it's getting a lot time. So yeah, it's showing 4 to 5 minutes. So let's see how much time it will take. And after installing .exe file, we will start installing Anaconda in our system. Okay, so the .exe file is downloaded. Now what you need to do, just click on that and double click on that and you will get the pop-up. So now I will go to downloads, and from there you can see I have already downloaded the .exe file. Now what I need to do, I want to click on this and I will start the installing process. So yeah, it's showing. You can see I got the first pop-up where they are showing that welcome to Anaconda 2020.02. That is the version, and this is for 64 bits, and it is recommended that you close all the applications before starting setup. This is actually recommended before you start any installing process. Okay, and then let's go to next. Okay, so there is a agreement that you need to actually, the software agreement that you need to actually agree that. So I agree, and there you will get a two option. One is all user requires admin privilege and one is just me. So basically we are not going to use this for a commercial purpose, so I'm going to use just me option. There it's get the destination folder. So if you want to change the destination folder, you can do that. So anyway, you will go and make a new folder, that will be fine. But for my cases, it's going for that we go for user and then my name Sampriti, and then there will be a folder for Anaconda. Then next, fine. So this location is not empty because I have already installed previously. So if you want to make a new folder, I'm going to make a new folder and I'm going to write Anaconda, right? And then okay. Right, so this will go to under Sampriti, and there is a folder I have already created, that is Anaconda. Then next, now I am going to install the process. So there are two options. You can see that add Anaconda 3 to my path environment variable. I don't want that, and this is register Anaconda 3 as my default Python 3.7. So I want the Python 3.7 version. Now I need to click on install, and automatically it will start installing. And if you want to see all the details that what are the actually, you can see that scikit-learn, Seaborn, this is already pre-installed library we get when we go for Anaconda, right? So it will take a little bit of time to get install all the packages. So there are lots of package. For stats model we have a package, for SciPy we have a package, right? For DAS we have, so it will take a little time to get installed. So we will wait for that time. So you can see my installation process is complete, right? So all the PowerShell, Conda install, everything is already installed. Now what we need to do, we just need to click on the next. So yes, you can see this is the PyCharm is also there in Anaconda, right? Now what we need to do, we need to just go on finish. But one thing, be sure that you have ticked down to Anaconda individual edition trial and learn more about Anaconda, right? So you can see there already they have given that thank you for installing Anaconda individual edition, and there are some useful tips you can get after installing the process. Now I will click on the finish. Yes. So you can see they are going to give their product documentation, starter video, training, support and all. Now what we need to do, I just need to go to our taskbar and I need to check that my Anaconda is there or not. You can see I have Anaconda prompt. So you can see I got some of the Anaconda, that spider is there for Anaconda, and whatever I have, like you can see I have the Anaconda prompt as well. So now what we need to do, we need to just search for Jupyter Notebook. So you can see I have searched for Jupyter Notebook and it's already there. I need to click on that and the Jupyter Notebook will be opened in the browser. So let's see. Yes. So opening Jupyter Notebook. This is how actually you need to install your Jupyter Notebook through Anaconda. Now what I need to do, I need to go for new. Okay. New and Python 3. The version of Python is 3. So Python 3. Now your notebook will be created. So you can see my notebook is created. Now if you want to rename your notebook, so you need to click on that and you will get this part, this pop-up. So what I need to, maybe this is a demo notebook for me, demo 1, and this then rename, right? And if you want to install some of the libraries in your Jupyter Notebook, then what you need to do, pip install. Then suppose I want to install Numpy. So Numpy and Pandas are popular libraries of Python for data manipulation, right? So let's see. So this is one of the best part of the Jupyter Notebook, that if you want to install any library, that can be done using pip commands, right? So you can see this is already saying the requirement is already satisfied. I want to install Pandas. So Pandas is also requirement already satisfied. So this is how actually you can use Jupyter Notebook and you can do your coding using Jupyter Notebook. And basically Jupyter Notebook is for them who has just started their career in data science domain, or some of them who actually wants to learn about data science domain. So you will get all the thing in one place, right? So this is how Anaconda and Jupyter is one of the most used data science toolkit.
Now we are going to talk about variables and operators in Python. Why do we need variable? Why do we need operators? We will talk about everything. So let's start with what is data, right? You get me right. Why do we need data? What is data all about? As the name suggests, we all know data is nothing but information. Maybe data is in the proper numerical form or data is in the documentation form. You have to make a report out of it and you have to understand what information you have under this data. Maybe you have data like 13.4 or 287. You need to have a proper context about this number, what this number defines. Then you have a sentence that my name is Sam. What information you are getting from that? The particular person name is Sam. Then you have formula, maybe that a plus b whole square or 0, 1, that is nothing but binary mode. So you have to understand your data. And now in order to understanding our data, where can I store my data? If I don't store my data, it's not possible to work on it, right? That's why one concept comes into the picture. That's nothing but variable. So that is why we can say, why do we need variable? Variable is nothing but where you can store your data. Data or values can be stored in temporary storage spaces called variable. Alright, you get my point, right? Why do we need variable? In order to store our data. Suppose you have a variable of student where the variable has the particular address, but you don't need to take care of that. What else you need to, so you need to actually look into that. You have to look the value of the variable. So variable has a name and the value of the variable will be what? John, right? Suppose you have written student, equals to John. I will show you how to start with variable and how can you look into these things as well. Right? So we will do the demo on Google Colab, but before that, for your theoretical understanding, variable is nothing but where you can store your data. Variable has a name, and after that you have to assign the value to your variable, right? You can totally understand why do we need variable. Now if I move further and if I just want to show you the example of variables, suppose you have a equals to 10, right? Then you have b equals to 20. Now you just want to see a plus b, a minus b, a into b, or a divided by b. You can do everything, right? I will show you how to do that as well, but you can totally understand you have two variables where a equals to 10, the value of a equals to 10, and you have b equals to 20, the value of b equals to 20. After that you can do all these operations, right? Now you understood the reason of having a variable and what are the things you can do using variable. So the basic funda behind the variable where you can store your data. Now comes the operator concepts in Python, right? So what is operator? What are the concepts we need? What are the things we can do? We will do everything. For your reference, for the types of operators we have in Python, let's have a look at that. Suppose you want to do a and b, you have the two variables. Now you want to do a plus b. That will come under arithmetic operator, right? So you are operating your variables, right? Then you have assignment operator, you have comparison operator. You can totally understand by the name itself you want to compare something between two variables. Now you have logical operator, identity operator, and nothing but membership operators, right? These are the type of operators you have in Python, right? So we have talked about variable, we have talked about why do we need variable, and also we have talked about the operators we have in Python. Now we will do the demo for all of them, and let me show you how you are going to use them, right? In order to do the demo, we have to go to Google Colab. Now, if I want to show you how to go to Google Colab, just write Google Colab. As I have said earlier as well, for Google Colab, you don't need to install anything. Just hit enter, and then what you will get, the first link. Click on the first link. After you click on the first link, you will get a window like that. You have to have an option of new notebook. So what we are going to do, we are just going to click on new notebook, right? If you want to check out Google Colab full video, you can check that out in our Great Learning channel, and you will get a whole idea about how Google Colab is going to work on, right? And if you like the video, do not forget to like this particular video and do not forget to subscribe Great Learning. So as I have said that the new notebook, now if you want to change the demo of the name of the notebook, you can directly call over there and just remove the name and just write the what name you want to give, right? So this is how you can do this, okay? So you can see this is how you can make your notebook on Google Colab. Now, as I was saying, if you just write a equals to 10, right? Let me just execute that. So if you write a equals to 10, it's something you are writing the variable just to show you how to execute in Google Colab. Now, if you just print a, you can see you will get 10. Let me make it little big. Yes. Now, if I just want to show you what are the type of runtime we have in Google Colab, as I say, this is nothing for, it's for the AI researcher. You need to have a high computational power sometime to work with AI, right? To work with deep learning, to work with the huge data set, right? For that, we have different type of runtime in Google Colab. We have GPU and TPU, right? So if you want to change, you can change accordingly and you have to save it, right? and then your work is done. And there are a lot of options to upload your data. If you just click over this box sign, you will get this upload option. If you click over there, it will redirect to your local system. If you want to upload any new data set, we will do in this session in the later, but this is just for your information. If you just want to upload new data set to your session, you can do that. There is one warning I just want to give you. After everything you have done, it will recycle everything after 12 hours. But you do not forget to save your work or download your work, right? Yes, so this is pretty much about Google Colab, what we have taught about. Now, as what we want to do, we just want to show you the variable concepts and the operator concepts in Google Colab, right? So let me just do that as we have done. So that what we were talking about, a equals to 10. That's nothing but your variable. So this is how you can initialize a variable in Python. Yes, as you have written a equals to 10 and you write print a. I will show you that like if you just don't write print, then also it's getting printed. So what's the difference between print and where you can write only just the variable name? I will show you what's the difference between them, right? So let's move further and let's have a look at the variable. Now there is a variable called var. You have written var equals to 10. Now you have written that var equals to 10, and when you are writing only var, you will get var equals to 10, right? Now what I want to do, I want to make one more variable where I am going to store nothing but the name, right? So one thing in this particular Python, so if you need to initialize variable, you don't need to write the types of the data types. We will talk later, but data type of the variable, you don't need to write it here. So it will automatically take the data types of your variable. All right. So what are the things we are going to do? Now I am given a name, right? So now I given a name, that is John, right? So var2 equals to John, and when you have just write var2, you will get the output that is nothing but John, right? So your variable. Now if I just want to print both of them, the thing I was saying, if I just need to write var and var2, and if I just write var, right, what it will return me, that's 10. If I am going to write var underscore 2, right, what is going to return me? John. Now you said, hey, I want to see both of, both the print or both the value. How to get that? So in that case, you need to write print. Okay, I will get an error. Okay, now here also. Okay, now if you just write print for both of them, you will get both the output. So you get my point, right? What's the problem behind it? So if you just write print var and print var underscore 2, you will get both the data. Otherwise, you will get the last, the last variable you have written. Suppose you have written var underscore 2, you will get that value only. So this is what the reason or the difference between when to use print, when to you just write the variable name, you will get the data, right? Now if we talk about arithmetic operators, as we were saying, arithmetic is nothing but your arithmetical operations. If you just write print 6 plus 2, what you will get? 8. If you just write 6 minus 2, what you will get? You will get 4, the subtraction you have done. Now, if you just write 5 plus 2, 6 plus 9, and I want both the output, that's why I have written print 5 plus 2 is 7, and then print 6 plus 9 is 15. Now, we will go for print 6 minus 2 and 6 plus 2. 6 minus 2 will give you 4 and 6 plus 2 will give you 8. So you can totally understand how arithmetic operators are working. Now if you just write 6 into 2, that is nothing but 12. Let me show you the big number we have done, right, in the presentation. 209 into 2034. Okay. Can you see 425106? It takes few seconds. So you can again understand this programming is helping us to do this kind of a mathematical, calculation as well in a few seconds. Now, right. Now, as we have done 7 divided by 2, what I will get? I will get 3.5, right? So, these are the particular operations comes under arithmetic operator, right? Now, we will go further and let's see the multiplication you can see, division you can see, right? So, all the things you can do as I have said. Now, what we want to do? We want to talk about few things. If you write 7 into 7 into 7, right, that is nothing but 7 cube. You will get 343. Instead of writing 7 for 3 times, if you just write 7 in the multiplication twice and then 3, it will take 7 cube. If you just write 7 multiplication twice and then 2, it will give you 49. That is nothing but 7 square. So this is nothing but you can create the 7 to the power, the number you want to give in, right? So we have written 7 to the power 4 is 2401. Now I will show you in the division there is few things, right? If you just write 7 divided by divided 2, right? There is a basic difference we have under this. Now if you just write 7 like then //2, that will remove your what? That will remove the float part, right? And if you just write 7, if you just instead of this, if you write 7 divided by 2, it will give you what? 3.5. Now if I just want to print both of them, divided by 2 and 7 divided by 2, so you will get the difference between both of them. Can you see it? First one, it's removing the float part you have in the answer, and the second part will have the proper exact divided by 2, that's 3.5, right? Now if you just write 7% 2, you will get 1. Why? 2 divided by 7, like that is 6, and remaining you will get 1. So always it will remain the, like it will return the remaining part, right? So you can understand these are the operation you can do which comes under arithmetic operator, right? So for the exponent we have done, if you want to do 6 square, what you need to do? You need to write 6 multiply into 2, right? It will give you the exponential, exponent of 6 of like that is nothing but 6 square, right? Now the float division we have done, and this is nothing but known as modulus. That will give you the remaining part, right? So if you just want to check all of them at a time, for 6 square is 36, for 7 divided by 2, which is float division, which is going to just take out the float part from your output, that is again 3. And if you want to get the remaining part, if you just write 7 divided by 2, the modulus, you will get 1, right? Now the few things if you want to do, that is nothing but suppose you have in one variable called ram, and in one other variable you have sentence, hi, my name is, and you just want to concat. That also comes under this operators. And if you just want to concat, suppose you have written, hey, my name is, and then you can change the first name variable, but the sentence will remain same with a different name, right? Instead of writing, hi, my name is Ram, you have written, hi, my name is, and then you have added the variable of first name. So this is nothing but concatenation, right? If you just write print sentence, it will give you, hi, my name is Ram. If I just say change it to Sam, you will get the output here as, hey, my name is Sam, right? This is again a concatenation of variable, right? Now if I just do assignment operator, what type of assignment? If you just write a equals to 100, it is like you are assigning 100 value to the variable called a. You can see you will get output of 100. Now if you just write a equals to a plus 10, what you will get firstly? Okay, it's already there. If you just write print a first, you will have a equals to 100. Now you have written a equals to a plus 10. That is nothing but 100 plus 10. That 110. So if you print a after that, you will get 110. right? So again, you are assigning to the value to the variable. Now if you just write a equals to a minus 10, so you are subtracting 10 from 100. You will get, first one is 100, 10 as you have updated that, right? Here you have updated that a to 110, you will get 110, and as a print after the subtracting 10 from your a, you will get 100, right? So this is what assignment operators work, and you can assign the value to the variable like this way, right? Now we will talk about comparison operator. What type of comparison we are going to do? Suppose you have two variables, a equals to 4, b equals to 6. If you just write print a equals to b. No, this is not right. A and b is not same, not equal. In order to check the two variable is same, the variable value is same or not, we use double equals to sign, right? It's false. Now if you just write a not equals to b, so this is true. Your a is not equals to b. Now if you write a greater than b, before that let me print a and b, right? A print b, right? Let me see which one is big. A equals to 4, b equals to 6. So your a is not greater than b. That's why you get a false answer, right? Now if you just write print a less than b, obviously a is less than b, right? It's true, right? Now if I just write a greater than equals to b, it will say only a is maybe greater than or equals to b. Again you will get a false. And if you just write a is less than equals to b, you will get a true answer. So you can understand how comparison operator works. It's basically nothing but making a comparison between 2 or 3 variables. Now if I just write logical operator, right? What is logical operator? Okay, now if you just write true and true, okay, you will get true. Okay, now if you just write true and false, that's not possible. True and false, it will check both the condition is true or not. You will get false, right? What I have written will only return true if both operands, if the two boolean objects you are comparing are true. Now, or true whenever any one of more operand is true. If you write print true and true, that is true. If you write true and false, that will give you false, right? And this is how it's going to work. If you just write true or false, it's like you can understand it's nothing but your logical operator. Let me make a code file here, right? And let me write true or false. If I just write, you will get a true because it's going to check any one of the operator will true or false. And for and, if you just write true and true, then only you will get true. If you write true and false, you will get false, right? Now we will look into membership operator. What is membership operator? So in Python we have few type of data types. We will talk about that. We have few types of data structures as well, right? So we have list under that. Suppose we have written how to initialize a list. You have written x equals to third bracket, or you can say the square bracket. That is how we initialize list in Python. And then we have written apple, banana, lychee and pineapple, right? So now after you have initialized x where you have the fruit list, and if you just write print lychee in x, so you want to check, okay, do I have lychee in my list of fruit in x? So if you have that, you will get a true. If you don't have that, right, if you just write pineapple not in x, so pineapple already in x, you will get a false, right? Can you understand? This is how membership operators work. Now if I do the same thing over here, if I just write, let me make it a little small, okay. If I just write print orange in x, So your orange should be in X. No, it's false. Now if I do the same thing, here I am going to write not in X. So for 1 you will get false. Orange is in X. No, it's false. Then if you write orange not in X, you will get an true, because obviously your orange not in the list, right? So this is how your membership operators works. Next, we will see what are the data types we have in Python. So in this part, we have talked about what is variable, why do we need variable, and what are things you can store under variable. Then we have talked about so many operators we have in Python in the demo itself, and also we talked about Google Colab. Now in the next part we will see what are the types of data types we have, how can you initialize the data types, how can you check the data types for particular variable. We will look into everything. In this part we are going to talk about the data types concept in Python. What is data type? Why do we need data type, and how can you check the data type for your variable? We will look into all these things. So let's jump into what is and what are the types of data types we have in Python, right? Data types are used for classification or categorization of your data items. What data you have? You have variable, right? Now, if you want to check the type of your variable, what you need to do? You have to check the data types, right? So data types, that's why known as for classification or categorization for your data items. Then what is the type of the variable, right? As we have talked about, the variable is a container where you are going to store your data. These types are basically nothing but the types of data, which are data types. Now, most important part of the programming. Yes, if you don't know what type of variable it is, how can you do the further process? So you can totally understand it's the most important part of the programming. Now, why are data types needed? We will talk about that. It helps to check the type of the variable. Obviously, what is the type of your variable? It's an integer, it's a string, it's a boolean, it's float, what it is, right? And data types should be in a singular type. Right? What I want to say by that, you cannot say this variable is a mixture of integer and float. No, you cannot say that. A data type cannot be a mixture of two data types. It should be integer or float or string, right? A singular type it should be, right? And variable cannot be without type. You cannot say my variable is not come under any types of data types. Right? So these are the things you have to keep that in your mind, and why we need the data types. Now, if we talk about the different type of the data types, so every variable is associated with the data type. Now, a data type like if you give 10 and 500, it will be type of an integer. Now, if we give 3.14 or 15.97, you have pointer, then it will be type of a float. Now, if you have boolean, that true and false, then obviously it's type of boolean. Now, if you give name like Sam, Matt, or hey, my name is Sam, or hey, welcome to Great Learning, if you give this type of data to your variable, then it will be type of a string. We do have few other types of data types in Python as well. We will look into that, right? So these are the type of data types in Python. Now, I will give you how actually basic syntax for data types in Python. Okay, so data types are used to classify or categorize of items that we have talked before as well. Data types represents the value which determines what operators can be performed on the data. Suppose you have string. So can you make multiplication of two string? No, you can't, right? But it's an integer. You can make a addition of that. You can do a subtraction of that. You can do a multiplication of that, right? So your type of the data also defines that what kind of operation you can do on this particular variable. In Python, data type is assigned when you assign the value of the variable. Suppose you are going to write integer. You don't need to define integer then the variable name. You just need to assign the value to your variable. It will automatically take the type of your variable. That we will talk about how to do that in the demo, the most exciting part. And if you really like the video, do not forget to like it and do not forget to subscribe Great Learning for the new other content update, right? Then, or what we have said that we don't need to write the type of the variable, right? What you need to do, you just need to give the data or the value to your variable. It will automatically assign the data types. Now, if you want to check what type of a data type it's assigned by itself, that time we called or you use a function called type function. I will talk about that, how type function works. Yes, so this is pretty much about the data types in Python. Right? So now let's go to Google Colab and let's have a look at how we are going to use types of data types and also how we are going to work with types of data. Right? So let's get started with that. So right, we are going to again use the Google Colab for our, demo. So here what we have done, we have written data types in Python and variables can store in different types of data. Now, if you just write, before write that, if I just write a equals to 10, the variable like, example I gave before. So we know if I write equals to 10, it will be an integer. Now, if I just write type of a, right? Let's see what I will going to get. It's taking few time because it's getting connected, if I'm not wrong. Yeah. Let's see what is the type of a. Yes, you can see the type of a equals to integer, right? If you just write a over here, you will get a equals to 10, right? And the type of a will be integer as per our knowledge, right? So it's an integer. Now, if you just write hey welcome, right? You are giving a sentence or a string, right? So the type of the data will be string type. So suppose, and one more thing, we always pass a string in a quotation, right? So do not forget that. And if I just write data, then I will get the output, hey, welcome. If I just put type of data, according to my answer, it should come string. Let's see what it will come. Yeah, it's going to come string, right? Now, data 10, it's already done. You don't need to do that. Now, if I just write data underscore 2, right? I give the name of my variable data underscore 2. And if I just write 10.9, we know when it's a pointer, it should be float, right? So just after that, I will get an error for sure. Yep. So if I just write data underscore 2, then you will get 10.9. Now, if I just put the type of data 2, then it should return me float, right? Yes, it's returning me float. Now, there is one type of data types we have. This is complex type. So, what is complex data type? So, in this particular part, we have imaginary part and real value part, right? So, this is known as complex numbers, right? So, what we have here? We have written data underscore 3 equals to 4 plus 7j. So 7j is your imaginary part, right? If I just do that, and after that, if I just write data underscore 3, what I will get? I will get 4 plus 7j. Now, if I just want to try the type of the data types, then it will give me complex. This is nothing but complex number, as we know about in our mathematical part when we have done, right? So yes, this is also supported and this is the types of data types. Now, if I just write var 3, okay, if I just write var underscore 3 equals to type, equals to true. So what is it? It's nothing but it's Boolean, right? Now, if I just write again, if I just write again var underscore 3, you will get what type it is. It's a Boolean type, right? Yes. So this is what our all type of data type stands for. Now we will talk about few things. We will talk about list, set and tuple. This is nothing but the data structure in Python, and also it's a type of data types. It comes under, right? Now if I just write x is equals to, then if I just use a square bracket and then write apple, banana, cherry, orange, right? So you have lots of fruits and you want to make a list of that. How can you do that? In that case, you have to initialize a list. And initializing a list in Python, how can you do that? You have to use a square bracket and then with the comma separated value, you can put your values. Maybe I have written a string list. You can make a number list as well. We will do that, right? Now I have written x equals to apple, banana, cherry and orange. Now if I just execute that, then my x will contain what? Apple, banana, cherry and orange. Now if I want to check the type of x, what I will do? I again need to call the type function and I have to pass x. So what I will get as an output? The type of the data type is list, right? So list is one of the data structure in Python as well, right? Now if I after I initialize my list, if I want to do few more things on my list, how to do that? So I have my list over here. Now you said I want to add, right? I want to add one more fruit to my list as I have initialized it before as well. So in order to do that, what I need to do? I have to use a function called .append. Now, when you go for Python interview, the most asked question about from the interviewer, they are going to ask you and try to understand, is your basic clear for Python? If your basic is clear for Python, then trust me, you can do data mining, you can do any sort of new technology, but the one thing you have to be clear that your basic is really clear, right? Now, what do we need to do? Now, if I said I want to add mango to my fruit list, how to do that? I am going to use a function called .append function. So do not get confused with .append function. The most asked question by the interviewer, what is .append function? X.append, and if you just write mango, so what it will do? It will append the mango to your list. Now, if you just print your list, then you will get apple, banana, cherry, orange and mango, right? So this is how we can do this list wala part, right? We can append a new thing, we can initialize a list. Now, if you just write x of 0, so basically it's known as index wise data fetching from list. If you just x of 0, what you will get? You will get apple, right? The first element you have in your list. Now, one more thing. If you want to see the length of your list, the total length you have for your list, you can write length function and you can pass your x list, right? What it will get? You will get 5. Can you see? Apple, banana, cherry, orange, mango. The 5 fruit you have, the length of your list will be 5. Right? And always the indexing start for any list is 0, right? Now, if I just do one thing, okay, I have done later as well. So, okay, so suppose you can see, I want to see x of 0. Now, if I want to see all of them at a time, you have to use print, right? Do not forget where we use print and why do we need to write print. When you have 2-3 things to print at a time, you have to use print function, right? Now I have written print x of 2, x of 4. Let's have a look at what I have. So for x of 0, you can see it's apple. For x of 2, it's cherry, right? And for x of 4, it will be mango. So this is how you can fetch the data by using the index in list, right? Okay, so length of list I have already explained. Now, if I want to change something in my list, how to do that? Suppose for my x of 0, I have apple. Now, for x of 0, I want to change it apple from lychee. Can I do that? If I just execute this one and then if I just execute this one, you will get x of 0 is updated with lychee. So you can update index wise fruit as well. Now if I just write X, you can see lychee, banana, cherry, orange and mango, but we do not have apple. So these are the things you have to remind when you are working with list. One, how you can initialize list using square bracket, how you can check the length of the list using length function, how can you add new things to your list, you have to use x.append or using .append function. Now if you want to change or update any index value in a list, what to do, you have to use the index value in the square bracket and you have to write the new value you want to update. Now from where your index starting in the list, your index starts with 0, not with 1. So do not get confused with your index start with 1. No, our index start with 0, right? So this is pretty much about the list. Now if I am going to use a new list, suppose I am going to use a numbered list, okay, then we have to write equals to, and then we are going to write 1, 2, 3, 4, 5, 6, right? If I do the same thing again with the number list, if I just write number underscore list, I am just trying to print it. You can see 1, 2, 3, 4, 5, 6 I have, right? Now what I want to do, okay, it's going there, right? So let me make it a little big again. Okay, so I have done the number list. Now if I want to add new thing to my number list, but before that, what I want to do, I want to check the length of my number list. So I need to write length function, okay, length, and here I have to pass the list. So what is the length of the list? That will be 6. Now if you want to see, if you want to add new things to your list, maybe I just want to add number list equals to not equals to dot append, and I am going to write 7, right? Now if I just see the number list again, can you see it's there, 1, 2, 3, 4, 5, 6, 7, right? And now if I just try to update one particular, suppose I want to update my second index. So my second index will be 0 is 1, 1 is 2, 3 will be my second index. So I am going to write number list of 2 equals to 10, right? And then if I just write number list, right, what I will get, I will not have 1 if I'm not wrong. Yes, so sorry, I will not have 3, right, because I have updated my second index. So 1, 2, 10, 4, 5, 6, 7, right? Can you see? This is how we have used list data structure in Python, and also the type of data types. Now we will talk about set and tuples and dictionary, right? Now we will talk about set. But what is set? Set is also one type of a data structure. Now there is one thing you have to keep in mind, and the difference between list and set, right? Set is also going to take a list of fruit, but there is a small thin line you have to remember to make sure that you are not getting confused between list and set. Now, how can you initialize a set? So in that case, you have to use a curly bracket. If you write x is equals to, I don't want to confuse with the list, so y, right? I have written y equals to, then curly bracket, I have written apple, banana and cherry. Now if I just write y, okay, and also we will try to check the type of y. As I have said, it said, why do you believe me? If I just write y, you can see I get apple, banana and cherry. Now if I just want to check the type of the data types, what I need to do? I need to use a type function, right? Do not forget these basic things, because these are the things most asked by the interviewer, right? If I just write type of y, it's set. Now I will give you enough reason to understand the difference between list and set. Now, if you want to add new thing, right? And after you initialize list, if you want to add a new like element to your set, how can you do that? You need to use dot add function. In the case of list, you have to use dot append function. Again, do not forget that. These are the basic difference between list and set. The most basic difference between list and set, do you know what? You will get shocked, because the list can contain duplicate elements. Suppose you have 10 twice in your list, it can be stored in list. But if you have 10 in set for twice, it will automatically delete it. I will show you. So basically, set used for all the distinct number. If you have a long list and if you want to get all the distinct or unique number from the list, you can convert the list to set, and set will only have the unique element. The duplicate element from the list will be eliminated automatically. So set basically maintains the normal set theory we have in maths. Right now, if you just want to add x.add lychee, it will add lychee to your, okay, I get an error because my set is y and my x is list, right? If I just write y.add, I get obviously what I want. And now if I just print y, I will get lychee, apple, banana and cherry, right? And then if I just write a y.add apple again, okay, let's see. Already I have apple in my set. Can you see? After that again I'm adding apple. Do I get apple twice? No. Why? Because it can contain only the unique or distinct element, right? Not any duplicate elements, right? So always remember how to use set. What is the difference between list and set? Now, if I want to show you one thing, right? Can you see? Okay, can you see that we have used dot add to add new thing? Right, the same thing. Okay, now what I want to add. Now, if I just want to show you something related to the indexing, if I just write y of 0, what you will get? Can you see? Set object does not support indexing. Again, the difference between list and set. It does not support any indexing, right? What I want to do. Suppose I want to make one more set, and that will be number 1. So demo set, I have given the name and I am going to use the curly bracket. Then I have given 1, 1, 2, 3, 4, 5, 6, 7, 8. I have used 1 and 8 twice. Let's see how it's going to react on that. Okay, I don't need it. If I just write demo set, right? If I just write demo set, what I will get? Can you see? I get 1 for ones, 2 for 1, 3, 4, 5, 6, 7, 8. 8 is also for ones, right? So you can understand how our set works with the unique element. It does not support any any duplicate element in the set, right? Now, if I want to add demo and then set and just write dot add, if I just write 10, right? And after that, if I just want to print my set, what I get? I get 1, 2, 3, 4, 5, 6, 7, 8, 10, right? Yes, this is how we use set function. And if you want to do one more thing, let me show you on that. Just for your clarification, right? If I just do that, can you see? I will get an error. Again, the difference between list and set. The set object does not support item assignment, right? So it does not support any kind of item assignment, right? So this is how we can work with set. Now we will talk about tuple and dictionary, and we will complete these data types part in Python. Now, if I talk about tuple, right? So what is tuple? Tuple is also one type of a data types and one type of a data structure in Python. Now we have to understand where to use tuple, where to use list, and where to use set, and where to use dictionary. We will talk about that. So what I have written a tuple x1 equals to, and to initialize tuple you have to use a what? It's a first bracket we said, and it's a round bracket, right? It's basically a round bracket. So we have written x1 round bracket apple, banana, cherry, and orange. Now, after you initialize it, again, if you want to check the type of x1, it's tuple. Now, you will ask me, why tuple? Why do we need tuple? We need tuple because a tuple is an immutable object. Hence, any operation then try to modify like append is not allowed. After you initialize tuple, you cannot change it. The main rule when you talk about tuple, right? After you initialize tuple, you cannot add any new thing to your tuple. It's an immutable object, right? If you just write x1 dot append, and then if you write mango, what will happen? It will give you an error. What type of error it's going to give you? Tuple object has no attribute append, right? So always remember, if you want to use tuple, you cannot change it after you initialize it, right? Now, if you just write x1 0 equals to lychee, what is the problem? Again, this thing I have seen, if you want to use append or if you want to update anything to your tuple, you cannot do that. Why? As we were talking about tuple, tuple does not support any item assignments. So after you have done anything on tuple, so after you initialize tuple, you cannot change it, right? Now we have talked about set. Now if I come down, we will talk about dictionary. So this is also one type of what? One type of data structure in Python. Now if you just use dictionary, you have to use curly bracket, but there is a new concept we have in dictionary. Dictionary will have key value pair. According to your key, you will have value, and always you should have unique key. Not any duplicate key is allowed in dictionary. If you just write name as the key and then colon, you will give the value for this name, that's John. Then you have age key, you will have 36 as the value, right? Now, if you just write X, okay, let me just do that. It's not. Okay, if you just write X, you will get age is 36, name is John. Now, if I just write the type of X, again to check the data types, it's dict. So basically dictionary. Now, if you want to check all the keys in your dictionary, how can you do that? You have to write x.keys. Then you will get all the keys like name and age you given, right? Now, if you just write x.values, you will get all the values from the dictionary, that is John and 36. Now, if you just want to check one more type of dictionary, maybe you write number, right? And if you just write demo is equals to, if you have to use the curly bracket, and then you can write first number, okay, then you have to write this particular colon, and then you can pass 1, 2, 3, 4, 5, right? You can pass list as a value as well. Now, if I just write second number, right? If I just write second number, and then if I just give one more list, right? If I just do that, can you see? Now, if I just write number demo, what you will get? You will get first number, your keys. Under that, you will get a list, that is 1, 2, 3, 4, 5. Second number will be your, again, the second key. You will get the values 2, 3, 4, 5. Now, if I just write number underscore dot keys, right? Okay, I will get an done. Okay. Right. So your key is first number and second number. Now if I just write number demo dot values, right, it will return me all the value that is list we have. That is list of list 1, 2, 3, 4, 5, 2, 3, 4, 5, right? And again there is this is what we can do using dictionary, and this is what we actually go for using dictionary for key value pair. So we have talked about so many things. We have talked about the types of data types we have. Why do we need data types? What are the functions we use basically to understand our types of data from a variable? Then this data structure we have in Python, the list, set, tuple and dictionary. Why we use them, what is the difference between them, and also we have talked about this type of data types as well. What are the questions you can expect from the interviewer while you are actually learning the basic of Python? We have talked about everything. Now we will see the conditional statement in the next part. Now we are going to talk about conditional and looping statement in Python. Why do we need a conditional statement and how to use looping statement? We will do all the demo in Google Colab. How can you implement them in Python? So now let's start with what is a conditional statement. You can understand it's something you are going to give a condition from the name itself. Suppose, let me give you an example of that. You are saying if it's raining, then I will sit inside, else go out and play football. So this is your condition. According to the weather, if it's raining, then you will sit inside. Otherwise, you will go out and play football. Now, let's have a look at the next one. Suppose you said, as our parents used to say, right, if you get marks greater than 70, they will give you an ice cream. Otherwise, you have to give a practice test, right? The same way it's here also. If you said, if the marks is greater than 70, then I will get an ice cream. Otherwise, I will give a practice test. Right? This is what conditional statement stands for. Now, we will jump into Google Colab and we will look into how you can actually implement this type of conditional statement in Python. So, what is the code for if-else code? So, to do that, we use if-else code, right? So, we need to write if, and then in the parentheses, we have to write the condition, right? Then, or if you don't want to use parentheses, it's totally fine. You have to give the condition, then the semicolon, you will get the statements to be executed. Then at the else part as well, you have to write the statement to be executed. Let's go to Google Colab and let's have a look at how can you do this particular part, right? So I have made my conditional statement notebook and I am going to use that. So here you have a variable called var and you are going to take an input. So again, why do we use input function? We will talk about what is function, but for the now time being, you can understand function is something where you have written a code and whenever you need it, you can call them, right? You have to write input. So input is basically used for taking a user input from the user. So again, it's something when you go for interview, they will ask you how can you take a user input from the user. So that time you have to say your answer will be input function. So if you write var equals to input and then in the parentheses you are given what what the word it's going to show while you are giving the input. Suppose I have said enter your name, right? If I just execute this. Okay, it's going to take a little bit of time because the kernel is getting connected. That's why. Yes. Okay, can you see what the command you are getting over here? Enter your name, which is you have given in the parentheses. Now I have given my name is Sampriti, right? After I did that, if I just want to print var, so with the sentence, hey, welcome to Great Learning and then Sampriti, right? Now, the same way we were talking about the weather, right? According to the weather, I want to go out or I want to stay inside, I will decide. So, to take the user input for weather, you have to again use input function. I have written input, enter today's weather, right? if I'm going to write sunny, okay? Now, if I just write weather, what is going to give me? It's sunny, and the type of the weather again, it will be string, right? Now, I want to do one thing. I want to make my weather, the value I have under weather variable, I want to make it in the lowercase, because I don't want any mismatch in my data or in my output because of the capital letter or the small letter issues. So that's why I have made all my weather, like whatever the, maybe I got sunny, in the case written S is in a capital letter, U is in a small letter, again N is in a capital letter. So I don't want to make any confusion for that. That's why I have made all of them into dot lower, right? So if you just look at it, the sunny I get in a lower version, like SUNNY, all in the lower part, right? Now, if I just write if weather equals to rainy, then print will not have ice cream or will not go out, okay? The same thing we have talked about. Okay, otherwise, let's play football, right? Okay, right. If I just write, hey, my weather equals to rainy? No, so let's play football. Now, if I go back to again, and if I just give, okay, here I am going to give rainy, okay? Now, if I do all the things, whatever I have done, and here what else I will get out? I will get the output as will not go out, will sit inside, right? So you can understand when you give the if part and when you are writing, you are going to write weather equals to rainy, its rainy value is equals to like the weather value, right? That time it will go inside the loop, not the loop, inside the statement, and you will print it. Then again, else part, it's not going to like matching with the condition you have given. It is come to else part and it's going to print whatever the instruction you have given. Now, what I want to do, the same thing I have done over here as well. Now, I want to check few things. I want to have elif part, right? There is 3 part we have in if-else conditional statement. One is if, one is elif, one is else part. Now, let's have a look at how this if, elif and else part works. Now, if I write if b greater than a. So, here I have mentioned 2 particular variable, a equals to 23, b equals to 23. Now, if I said if b greater than a, print b greater than a. Then I have written in the elif part a greater than b, print a greater than b. Otherwise, else a and b are equal. Let me tell you how this conditional statements is going to work. It's not a big deal to understand if else. Suppose if my b is greater than a, it will first check no, my b is greater than b is not greater than a, then it will not print anything. Then it will go and check elif part. Then if time is saying a greater than b, no, it's not, then it will not go inside that condition. So it will go to else part and it's going to print a or b are equals, right? So you can understand this is how we can actually do our if, elif and else part. Alright, now I have changed my a equals to 45 and b equals to 33. So what I have done the same thing, if b greater than a, then print b is greater than a, and then we have written elif. So my a is greater than b. So it will not go to if part, it will not go to elif part, it will again go to else part, right? Yes, a is greater than b. This is how we are going to use if else part. Now there is a new concept called shorthand if else, right? So now I just want to make this particular condition in one line. How to do that? If you have only one statement to execute, one for if and one for else, you can put it all in same line, right? How it's going to do that? You cannot use elif part in that case, in for shorthand if, right? If you just write if a greater than b, else print b, right? So what I have, print a, I want to print a if my a greater than b. No, else part, print b. it will print B, right? So if you want to change it to here like this, A, and I want to print the number, not the name, right? So 30. I get 30, that is B, right? So this is how we can do shorthand if else. Now we will go and check what is loop. So guys, do not get confused about loop and conditional statement. Conditional statement, it will only execute if your condition is going to meet. Otherwise, it will not work as a loop. Now we will talk about loop. The most common difference between loop and conditional statement, like everyone get confused. So do not get confused on conditional statement and loop. And if you like the video, do not forget to like it. And also, if you want to get updated with the new content from Great Learning, please do hit like the subscribe button. You will get notified with the all new content we are going to release, right? So let's go back to presentation and let's have a look at the loop concept. Right. Now we will talk about what is looping statement. Looping statements are used to repeat a task or multiple times. Suppose you want to repeat a particular task for 10 number of time, right? How can you do that? You have to go for using looping statement. Keep filling this bucket with a mug of water while it is not full, right? So yes, this is what looping statement stands for, right? We will talk about what the types of loops we have in Python now, and one more looping statement to repeat your multiple time task that keep repeating the song until you close the app, right? These are the things you can understand this by in a loop it's going to happen. Now if we talk about the types of loop statement in Python, we have for loop and while loop. Now we will do the demo on this two type of looping statement. But before that, let's have a look at why do we need loops in Python. Keep repeating the same work using loop. Obviously, reduce the effort. It's obviously going to reduce your effort. You don't need to write the something, one particular thing for 1,000 times, because if you want to continue this for 1,000 times, then loops are traditionally used when you have a block of code that needs to be repeated for a fixed number of times. Now, a for loop is basically used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, a string that we have talked about before as well. So let's go and let's have a look at how to do the demo in the Google Colab. Now we are going to talk about loop. First, have a look at for loop, right? Now I want to print my I, that is for 10 times. I want to see 10 times how it's going to work, right? So in this case, let me just delete this part. Will make you understand after this, right? Okay, so now what's happening? I have written for I in range. So your range is basically started from 0. Suppose you want to check from 1 to 10, right? You can do that. Okay, so here what's happening? You have to understand that if you give a range of 1 to 10, it will go to 1 to 9. If you give 1 to 11, it will go 1 to 10. The one number before you have given. Now I have written print I, right? So your loop will go till 1 to 10 and you will get the number printed for 1 to 10. Now if I just write I comma this, so what's happening? First it will go and it will take 1. In range it will print I1. Right? Then your I will change to 2, 3, 4, 5, 6, 7, 8, 9, 10. Keep on going. The number you will give. Right? So this is how our for loop works. Now, this is, I have already said, there is a 2 upper limit and the lower limit in range function. 1 is your lower limit. 11 is your upper limit. If you give 11, it will go till 10. Right? Now, if I just want to see, I don't want a sequence between 1, 2. I want 1 and then I want 3. Right? So the gap will be between 2, right? How to do that? So I have written 2, 41, 2, right? If I just print X, what I will get? First I will get 2, right? As my lower limit is going for 2, then 4, 6, 8, multiple of 2 we will get, right? So this is how you can generate the multiple of 2 or multiple of 3, right? Okay. So this is how our range function works, right? Now, if I want to check this 10 to 20, it's already talked about. Now if I want to check how this loop works with list, so we have list of fruits like apple, banana, cherry, lychee, and I want to iterate through a list using for loop. If you just write for I in fruits, and if you just print I, then first you will get apple, then banana, then cherry, and then lychee. Alright, then if you just write for I in bananas, so right, how can you do that? So iterating over a string using for loop. So it will go one by one alphabet you have, then B, A, N, A, N, A, right? So this is how it's going to work. The for loop on string, a for loop on like list, right? Now if I want to give, like if I want to merge two things that we have learned for loop, and we also want to include conditional statement, how to do that? Suppose I have a fruit list of apple, banana, cherry, and lychee. Now I will iterate over the fruit list, but here I am going to make a condition that if I equals to banana, then break. What is break? To break the loop, right? So if you have banana in your fruit list, then please break, otherwise don't. So it will first check for I in fruits, that's print will apple. Then it will check I equals to banana. No, it's I equals to apple. So it's not going to break it. For the second case, yes, I equals to banana. It's going to break the loop, right? So it's how you can make the combination of both of them and you can make your work done. Now, if I just want to make here the same thing for x in fruits, if x equals to banana, break, then print x. Then it will go till apple. Can you see there is a small difference between here and the before one? So here I am printing x after the break, right? So first it's going to for loop. It will check it's the x equals to banana. No, it's apple. Then it will print x. Otherwise, if I check for the second one, it's x equals to banana, and it will break before it prints, right? So it's not going to like print the banana. Right? So you have to understand the position of your conditional statement and also your looping statement, right? And here if you want to put continue, it will again continue, but it will not print banana, right? So these are the few like keywords we have in Python, right? Now, if you want to check a nested loop, so you can use 2-3 loops at a time. But before using it, you have to make sure you will not go to any infinite loop, and you can make sure the loop is going for particular number. Suppose you have 2 lists for color and fruits, and you want to print for red for apple, banana, cherry, for yellow for apple, banana, cherry, and green for again apple, banana, cherry. So what I have done, I have written for x in colors and for y in fruits, print x and y. So for red, the fruits list will iterate a full time, that red, apple, banana, cherry. Then for yellow, it will iterate the next list for the full time. For then, for green, it will again iterate the fruit list for the whole time, right? So this is how nested loops works. For loops cannot be empty, but if you, for some reason, have a for loop with no comment, put in the pass statement to avoid getting an error. So if you have a for loop and you have nothing to work with and nothing to add it, so you can just write pass, right? So this is again a statement to use for. So we have learned continue, break, and pass, right? Now we will talk about while loop. What is while loop, right? It's also a type of a loop. Suppose you have written I equals to 1 while I less than 6. So your while loop will work till your I equals to less than 6. Now I have printed I, and then I have incremented my I equals to I plus 1. Then print incremented I. Can you see what I have done over here? You can see the print I. So first time your I is 1, then it's going to increment I plus 1. It becomes 2. Then your 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, and 5 plus 1, 6, and keep on going. After it's incremented to 6, it will not come inside the loop because it's going to say, hey, you are not less than 6. So your while loop will break. So this is how our while loop works, and that is like I have shown you how our for loop works as well, and how our if else conditional statement works, right? So yeah, this was pretty much about the loop, for loop, while loop, and how can you make your conditional loop. I hope you like it, and if you have any suggestion, please do let us know in the comment section below. And if you like the video, do not forget to like it and also do subscribe. Great learning.
So in this particular part, we are going to talk about the introduction to Python library. But wait, what is library? Why do we need library? And how it's going to make our life easy. We will look into everything. And one more thing we will have a look at. What are the library we need to know in Python to start our journey with data mining? How it's going to make our life easy. So let's go and let's have a look at the objective we are going to cover for this particular part. So first we are going to talk about what is Python library. Then we will jump into introduction to Numpy. What is Numpy? Numpy is nothing but Python library. We will have a good we will look into a good introduction to Numpy, and then we will have a look at what is Numpy. What are the things we can do using Numpy? Then we will have a look at why do we use Numpy. Then we will jump into Numpy arrays, Numpy function, right? After we complete all these things, we will have a demo on Numpy. Then we will jump into introduction to Pandas. Then again, what is Pandas? Again, you can understand Pandas is nothing but Python library. We will look into what is Pandas, then why do we need to use Pandas, then basic function in data frame, and then we will jump into how to use Pandas in a data set. Now you will ask me what is data frame? Wait for that. Please hold on to till the last. We are going to talk about each and everything you need to know about Numpy and Pandas to start your journey with data mining. So let's get started with what is Python library. Now we will have a look at what is Python library. So library is a collection of modules, and when those libraries are written in the Python, they are known as Python library. So it's an easy example, right? But why do we need library? Let me give you an example of why do we need library. Suppose you need to use a mathematical function. Do you really think you have to write this mathematical function from the scratch? Can you even think of how painful it is if you need to write for Fourier transform or some more confused or more complicated mathematical explanation? Yes, if we don't have library, we have to write those functions. But when we have library, what it can actually help, it can have all the implemented function for this all complex mathematical function. I am just giving the example for maths, right? There are lots of other things we have. Suppose you want to go for sorting, right? You want to sort your array. If you have a function, you just need to write sort and your work is done. Right? And there are a lot more things you can do. Suppose maybe you can do something called merging, and there are lots of things you can do that when it comes to library, it's already implemented all the algorithms. You don't need to write it from the scratch. Yes, this is how this library are going to help us to make our life easy. Or maybe if I can give you some example of Pandas. So I'm not going to talk about what are the things we can do and what is for Pandas. We will talk about that later. But just a quick understanding of how this library is going to work. Suppose you want to load a big data set. You have lots of data. How can you load it? Can you even think of if you just need to write a function first to load your data and then doing the manipulation? It's really tough, right? It's really make your life, messed up, right? Yes. So this is what library comes into the picture and makes our life easy. So library is a collection of modules, and when those libraries are written in Python, you can totally understand it's nothing but Python library. Now have a quick look at what are the good thing we have about library. First, reusable of code blocks. How it's going to work? Suppose you need to load data multiple times. You can use the same function multiple times. You don't need to go for writing the code again and again, right? So you can totally understand if you want to reuse your code blocks, you can do that. Now, complicated programs or the data structure are already implemented that we have just talked about. Suppose you are someone who doesn't like to go for data structure. You don't need to go for sorting your part, or you just don't need to, go for some, complicated list, set, the thing we have, right? If you don't want to go for doing that, if you don't want to write this function, yes, again the library comes into the picture and make your life easy. So already complicated programs and data structure are already implemented in this library, and you just can import this library, install the library. I will show you how to do that, and you can start your coding journey, right? So this is what we need: library. If you don't know about library, these are the best way I think you can get to know what is library. And if you have any doubt, please do let us know in the comment section. We would love to solve your doubts. And if you like the video, do not forget to like it, and do not forget to subscribe Great Learning. And also, please do let us know your thoughts about it, right? Let's move further. Now we are going to talk about the important libraries you need to know in Python, and these are going to make your life easy again. First thing, nothing but Numpy. The full form is Numerical Python. We will do a detailed explanation of Numpy. What are the functions we have in Numpy? We will look into everything. Then we will go for Pandas. Again, this is a data manipulation library. As we are going to do a data mining, you have to know how to use the numerical part, how to manipulate your data using library again. Now, you need to have few more libraries to have a good understanding about. So that is Matplotlib and Seaborn. Now you will ask me, why do we need to know Matplotlib and Seaborn? Matplotlib and Seaborn is nothing but a data visualization library. Now, you have a good understanding of your data. You know what are the things you need to do, manipulating your data. You did everything. Now you said, hey, I want to see my data, how it looks like. What is the range I have in my data? We will talk about that. That time you need to have a library which can help you to visualize your data. So to solve your problem, Matplotlib and Seaborn comes into the picture. We will talk about what is the difference between Matplotlib and Seaborn as well. For that, you have to keep tuned for the full tutorial we have done for data mining. Now, we are going to talk about scikit-learn. What is scikit-learn? Scikit-learn is nothing but a machine learning repeat. Now comes scikit-learn. What is scikit-learn? Scikit-learn is nothing but machine learning library, and with this library you can actually implement all the machine learning algorithms we have. We will look into that as well. It's really interesting to work with these libraries, and also it makes your life easy again. So let's start with Numpy. So now we are going to talk about introduction to Numpy. As I already said, Numpy is nothing but numerical Python. So the num suggests you can totally understand this is going to use for your numerical part. And what are the numerical part we need to do in our data set? We will look into that as well. So let's see what is Numpy, or the introduction to Numpy. Numpy stands for Numerical Python, that we already know about. Now it is used to perform mathematical and logical operation on arrays. Suppose you have maybe I can give you a example of face detection. So how actually face detection works, right? And how your computer is going to recognize you. We all know we have face recognition in our phone, we have face recognition in Facebook, but how does it going to work? We will look into everything. So to start with, if you want to check out that how face recognition work, you can check out our video on real-time face detection. But before, if you don't know how it's going to work, then let me tell you, the computer doesn't have eye. Then how computer is going to see you and recognize you? Did you ever think about that? Yes, they will take your image, and those image will be converted to array, and you have to work with an array. you can totally understand when you need to work with array, you need to use Numpy. So yes, this is why Numpy useful. And this is why, and this is how basically Numpy is making our life easy. So let's have a quick point of how Numpy is going to work and what are the quick points you need to know about Numpy. Numpy is a Python library that I think you have already understood. Now, if we talk about installing Numpy, how can you install Numpy to start working with Numpy? So you have to use pip install Numpy. Anyway, I will show you in the demo how can you install Numpy. Then to import the library. After you install any library, you have to import that library in your notebook. How to do that? Again, we are going to use import Numpy as NP. Why you use as an NP? We will talk about that as well. Right, so this is the introduction about Numpy and we will do a demo on Numpy as well. But before start with the demo, let me tell you why do we need Numpy. I have given enough example of how Numpy is going to work. Maybe it's a face recognition or object detection. As we all know, these are the things are currently the hot topic that any company wants to make it, right? Now, if we want to talk about why do we need Numpy, let's have a look at the quick bullet points we have. Right? We have a list in Python that serve the purpose of arrays, but they are slow to process. If you do not know what is list, do not forget to check out our courses on Python where we have talked about what is list. List is nothing but where you can store your list of items, right? Suppose you have list of fruit and if you want to store them, how can you store them? In order to store them, you have to use list function, right? So again, list is a part of data structure, right? Suppose we have list in Python that serve the purpose of array. In the array also, we actually store the number of items we have. But when it comes to the processing, when it comes to the which one is the first and which one is slow, obviously list is slow. That's why we have to work with array and we have to know Numpy. Now, Numpy provides an array object that is 50x faster than traditional Python list. So you can totally understand when you have a huge data and you have to process it as soon as possible, you have to go for Numpy. Then the array object in Numpy is called NdArray. It provides a lot of supporting functions to work with. Yes, we will talk about that. What are the supporting functions we have in Numpy? I hope you will love it when we'll start working with the demo of Numpy. You can really see what are the things actually we have, and that's making our life easy and we do not need to write those codes as well. Right? So again, to know all thing about Numpy, you have to keep tuned for the full tutorial. If you really like it, do not forget to like it and do not forget to subscribe. Great learning. Now, last but not the least, we have the last pointer, that is array are very frequently used in data science where speed and resources are very important. Yes, as we all know, where we are talking about data mining or we are working with artificial intelligence or data science, the first thing comes into our mind, the main ingredients for all of them is data. If you know how to process this data first, quick, you are the winner, right? Yes, so in the keep that in our mind, we have to know Numpy and we have to start working with Numpy. So yes, these are the listed reasons we have why do we need Numpy. Now, let's move further and let's have a look at the demo of Numpy arrays. Now, we are going to talk about Numpy array and all the demo we are going to do for this particular course, we are going to use Google Colab. We have already talked about Google Colab. If you do not know how to start with Google Colab, please do check out our courses on YouTube, where we have talked about a tutorial on Google Colab. How can you start your journey with Google Colab? What are the features we have in Google Colab which is provided by Google? And this is for AI researcher, right? So yeah, please do let us know if you feel like this is one of the best resources to work with, right? So let's go to Google Colab and let's have a look at how to start with Numpy arrays. So this is what we have done. This particular, you can see the notebook we have made for Numpy. Now, as we said, how to install Numpy. If you do not have installed Numpy like previously, then you have to write pip install numpy, right? Let me just execute it. So as it is going to say, it's already satisfied, right? So you can see installing numpy is done. I have done it before as well, but where you are going to talk about this installing numpy and pandas in Google Colab, it's already pre-installed, right? Now what we need to do, we have to import numpy. How we are going to import numpy? So we have to write import numpy as np. Now you will ask me, why do we need as np? Right, let me explain you why do we need as np. You can directly import numpy only. You can just write import and numpy. But why do we use as np? So as is nothing but the alias, giving a short name to your library. It's really like interesting, right? Yes. Suppose I don't want to write numpy so many times, right? Maybe I don't like it. So in this case, I just given a short name to my library. Yes, how to do that? You just need to write as, just to give a alias as np. So next time, if you want to call any function or any implemented, facility from numpy, you can just call your numpy as np, right? So this is why we can write import numpy as name np. Again, you can give any name. I have given np, you have given nn, anything, right? In like most of the cases, we use numpy as np. So there is no hard and fast rule. You have to write np, right? Yes. So yeah, this is pretty much about how can you import numpy and how can you install numpy. Now, if I just want to give you a quick example of why numpy. Let us understand why numpy. As I have said, numpy is good. Numpy has this like features. Numpy is, you will get faster arrays. Let me show you how it's going to help us. Right? I hope you are going to enjoy this full tutorial, and please do let us know in the comment section what you feel about it. Right? So let's start with how to start with numpy and why numpy. For your instances, if you do not know how to initialize a list in Python, then what we need to do? We just need to write, but we have already talked about list right before. But just for a recap, you just need to write square bracket, right? After writing square bracket, you have to give your list of items you have. So distance is my list. Suppose I have written distance equals to 10, 15, 17, 26. And one more list I have declared. Which one is this? Time. Time equals to, I have written 0 0.3, 0 0.47, 0.55 and 1.2. Let me write it to 0.5, right? And 1.2. Oh my god. Okay. Now, if I just, execute it, and then if I just write type distance, when I'm going to write type distance, we have talked about it again for your recap, just to check the data type for your variable. So here, my type of data type for distance will be list, for time will be again list. Now, if I just want to, it's already done, right? Now, if I want to check the speed, we all know about the formula speed equals to distance by time, right? If I just write speed equals to distance by time, I'm going to get an error for sure. But why? Can you see? There is a problem, the list you have for distance and time. Now there is a problem to do this particular operation. What problem we have? We have unsupported operand types is list and list. So you cannot, make a division from a list to list, right? So in that case, you have to do few other steps. Now, when it comes to array, okay? Now we are going to solve this problem with array. As we already said, array is one of the most, quick, right? When it's come to a list and array, you should go for array because it's 50x faster than list, right? if I am going to write my distance array, right? Let me make it this. My distance array, okay? Then if I just write np dot array, so what we are doing? We are just calling dot array function. We will talk about function anyway. After this, maybe we will talk about function, and then again we will come back to the demo, right? So I just want to give you a quick understanding of what is function, right? So what we are going to do over here, we are just going to write np dot array, and we are passing our distance list. What it will do? It will convert your distance list to array, right? Now I have my time array equals to np dot array time. Now, as you can see, I have converted my distance to an array and time list to an array again. Now, if I just write print type of my distance array and type of my time array, which I have just converted from list, you can see it's array. Now, if I just want to do one thing. So one more thing, if you want to check when it was an array, when it was an like list. So distance is the array, you can see 10, 15, 17, 26. And my array, my distance array when we have done. So this is your array. You can see this part is your array, right? Now, if I just do the same procedure what we have done for speed equals to my distance array divided by my time array, right? So how it's going to work and how it's going to, do this particular part when it was in list, it gave me an error because we cannot do something like this using list. Now, let me do that. It's again a magic. Can you see I didn't get any, I did not get any error. How it's even possible? Yes, it is possible when you convert it to array. So you can totally understand using array is really flexible to work with, and when it's faster and we have library, why shouldn't you go for array? Why should you go for list, right? So you can see over here we have written speed, and this is 33.33, then 31.9, 34, 21, right? So you can see the calculation we have done, distance divided by time, it's perfectly executed, right? Yes, and we get our speed, okay? Yes, so this is how we have done this particular operation using Numpy array very easily. When it comes to list, you have to work a lot to do that, right? We will talk about few Numpy functions as well. But before that, I will suggest you please do check out and please just wait for what is function. First, we will talk about what is function, how it's going to make our life easy, doing a little demo on function. And then again, we will come back to Numpy and we will do the few more features we have in Numpy, right? So let's go and let's check out what is function in Python. Now we are going to talk about function. We have talked about library. We were doing a demo on Numpy. We will do it again always, right? But before that, I thought of explaining one concept which is known as function. You will ask me, why do we need to know function in between this? You will understand why we are talking about function while we are going to do the demo again. Before that, let me tell you what is function. And if you really liked the video, do not forget to like it and do not forget to subscribe it, right? So let's start with what is function. So what is a function? Function is a block of codes which performs a specific task. Okay, what type of a task you are talking about? What type of block of code you are talking about? Let me tell you. Suppose you are eating, or you are running, or you are cycling. Yes, we can do some of the commands or some of the work which can maybe we can make it as a function. So we will talk about how to do this particular function. So you can say, you can give an example of function like eating, running, or cycling, right? Now, types of function we have. So give a good attention over here. What are the types of function we have in Python? These functions are basically built-in function. Yes, first we are talking about built-in function. Then we will talk about user-defined function. Then we will talk about Anomalous function, right? So let's start with built-in function.
Now, as we were saying, we will talk about built-in function. Let's have a look at what are built-in function we have in Python. But before start with built-in function, let's have a look at what is built-in function stands for. These functions are basically predefined function whose functionality is already defined in Python. As the name suggests, you can totally understand this function is already there in Python. You don't need any library for that, right? So this is known as built-in function in Python, which are already defined in Python itself. Python interpreter has so many functions which are already available for use. Those functions are known as built-in function. Obviously, we will do a detailed demo on built-in function. Then, what is user-defined function? In short, it is known as UDFS. So, these functions are basically defined by the user according to the need. User, who is the user? You. You are the user who is writing the code. So, there is an option in Python where you can define your own function as well, right? This is known as user-defined function. Now we have anonymous function. What is anonymous function? As the name suggests, you can understand this is something, anonymous, right? So anonymous function are also known as lambda function, one of the most used concepts for Python. We will talk about that as well. And because we use lambda keyword instead of def, so this is known as lambda function. And one more thing, just writing a function or creating a function, we use a keyword called def. Do not get confused for that. Anyway, we are going to do a demo and you will have a clear vision how to do this function, how to implement function, and how can you by yourself make your life easy by using this function, right? And a lambda function can have any number of arguments but can only have one expression. I totally understand. Maybe you don't know what is arguments. We will talk about that. And what is one expression? We will talk about that as well. Right? So we have talked about what is function, what are the types of function. Now we will do a demo on Numpy function as well as the three types of function we have talked about. So let's go to Google Colab and let's have a look at how we can do this function demo. Right. So as we came to Google Colab, and I said before as well, right? So what we need to do. So Google Colab, I hope you are now quite familiar with Google Colab and what are the features we have in Google Colab, right? Now I will give you a lots of example of built-in function. Maybe you are someone who has already started working with Python. They maybe have used it because the basic thing we have, which is come part of the function in Python, which is print, right? So if you want to print anything in your program, you have to use print function, right? So you can totally understand what is built-in function. So yes, we have print, we have ibs, all, bin, bool. But you will think about what you are talking about ibs, all, bin, bool. Let me give you a demo and let me show you how it's gonna work, right? So you can see this is the whole list we have for the built-in function in Python. Like we have sorted, input, int, range, reverse, round, etc. Now let's start with print function. I know you have quite good idea about print function, but still as a recap, let's have a look at what is print function. So print, and then you have given your data or what you want to print. So let's start the new topic function, right? Let me just do that. Okay. Let me just execute it. Okay. It will take a few seconds because the kernel is going to get connected. Okay, And then we will talk about apes function. What is apes function? So function is used to return the absolute value of a number, right? Maybe you will give minus 30 or plus 30. It does not care about which one you have given. It will give you only 30. So that's, if you want to do something like that in your, program, then what you need to do, you have to use apes function. So here you can see I get the output that let's start the new topic function, right? Now if I go down and if I just want to use the particularly minus 30 and want to see, do I get 30 or maybe I can make it 50, right? So which one I am going to get, right? So here what I have done, I have written absolute value of minus 50, right? Let me do it 50 is apes, and in the parenthesis I have passed my variable called integer. Can you see what I have get? I get 50, not minus 50. Instead of minus 50, you can write 1000 in fact, which is minus. But as absolute value, what you will get? You will get only 10,000, right? So yeah, this is how apes function works. Now we will talk about a few built-in function in Python. Then we will jump into user-defined function, and lastly we will see the lambda function. And then again we will go back to NumPy and we'll look at the function in NumPy and the other features we have in NumPy, right? So I hope you all are excited to learn this. Please do let us know in the comment section what you feel about this particular course and what else you want to learn from us. And one more thing guys, do not forget to like this video and do not forget to share this video with your friends, which maybe you can think they will get benefited by watching this particular course. And do not forget to subscribe Great Learning. Right? Yeah, so let's get back to the next function we have again float. We have actually done one more thing, right? If you give a minus floating number, right, what you will get? Again, if irrespective of plus or minus, it will only give you the absolute value, which is you will get 10.83, right? Where you have given minus 10.83. Now we are going to talk about all function. But why do we need all function? All returns true if all the item in past iterable are true. Okay, so let me tell you what it basically stands for. We use all function to check each and every element you have in the list is iterable or not. If it's iterable, then you will get a true value. Right, so I have a list of 1, 2, 3, 6, the number list, and now what I have done, I have just passed this list to all function. So what I get a output which is true, and it's saying all the element you have in list, they are iterable. Now let's comes to 0 and false I have in my list, right? So false is not iterable, that's why I get false. Can you get it? Yes. So this all function is used to check all the elements you have in your list is iterable or not. Now let's move forward to the next particular function we have bin function. So bin function is used to return the binary representation of the integer. Yes, you get me right. So if you want to check the binary representation of 10 or 100, you can do one thing, you just need to write the 100 in an integer, or you can directly write that. Suppose I am going to write 100 and I want to check, okay, I get my the binary value of 100. Now instead of x, if I just write over here 50, you will get that as well. Can you see? Yes, so basically it's not mandatory for any of the function you have to pass an integer, you have to pass a variable itself. You can pass the value itself as well, right? But it is recommended to store this value to an integer and then pass it to this particular built-in functions, right? So yeah, this is what bean function stands for. Then we have one more function called Boolean function. So it converts a value to Boolean, that is true or false, using the standard truth testing procedure. Okay, so let's have a look at how it's going to convert the Boolean value to true or false, right? So you have given one particular list, that is demo of 0. So your integer name or your list name is demo1. You have written print demo1 is Boolean demo1. So what it's Boolean, it's going to convert this particular value to true or false, right? So can you see what you get? You get the actual value you had for demo1 is true. Now if I just write 1 over here, then you can see 1 is true, right? It's converting the Boolean, it's converting the value to Boolean value, that is true or false. Now if I just write false over here, right? Let's see. Can you see what I get? If you give false, again I get true, right? Now yeah, this is how and this is why we use Boolean. Now we have bytes. What is bytes? As the name suggests, we all know what is byte. It used to returning a bytes object. You can understand what is going to return. It's going to return the byte object, right? Now what we have hello, welcome to Great Learning, right? In the integer called string, I have written equals to hello, welcome to Great Learning. Now I have written bytes string comma UTF-8 and then I want to print array. So basically you can see this is nothing but going to give you the object, byte object. So as a result, you can see I get the byte object of hello, welcome to Great Learning. So this is the pretty much use of this built-in function we have in Python. But yes, we do have lots of good functions as well. So we have exe function. What is exe function? So this function is used for the dynamic execution of Python program that can either be a string or object code. It accepts large blocks of codes as well. Now if I just write x equals to 20. Now I want to check is my x equals to 10 under exe function. Yes, as you can see, function is used for dynamic execution of Python. Yes, it helps to do the dynamic execution. So what I have written x equals to 10. So if you want to check any value, like any value of variable, we use equals to in Python. So we have written x equals to 10, that is obviously false, and I have written print x plus 10, that is obviously 20 plus 10, 30. So now maybe I can do one more thing, exec, exec, and I have written print x equals to 30 to check that is it right or wrong. Okay, I get an error. Okay. Okay, I'm so sorry, I did not complete this particular parenthesis, that's why I get an error. Okay, right? Can you see what I get? It's false. Now if I just write instead of 30, it's 20, I should get true. Yes. Can you see? In under exec function, you are actually can check the x value with the value you want to check, or you can add some value as well. So it's nothing but giving you a dynamic execution of Python, right? Now we have most wanted functions like sum, sorting, and all kind of a function which actually making our life easy. Now what I have done, I have one list 1 2 3 4 5 6 7 8, right? In this particular list, what I want to do, I want to sum all the number. So in that case, if I need to do it by myself, you can think of what I need to do. I need to write a for loop, and then I have to go for, going through each and every element, and then only I can, sum it. But instead of that, if I have a sum function, why can't we use it, right? So we have demo equals to some function, and we have just passed the list we have, that is num list, right? And then we have print demo, right? And we get 33, right? So this is how we can use some function in Python. So it's making our life easy. So if you just do 1 plus 2 plus 3, that is 6 plus 4, 10 and 20, then 26 plus 7, 33, right? So this is how we can use sum function. So we have talked about sum function, right? And we have talked about, we have talked about exec function, we have talked about print function, but we do have more functions to go with. So which are nothing but our not user defined function, which are nothing but our built-in function in Python. Now we have any function. What is any function? So this function returns the true if any item is an iterable, is true or false. Right? Okay, we have done this any as well. Right. Did we? Okay, let me just explain this again, and then we will talk about eval function, and then we will talk about float function. So in any function, that's one thing we have to keep in mind, that it's going to give like return again true if all the item we have, it's going to be iterable, right? So what we have done, we have given a list of 41, 31, 20 and 20, right? So as we have done this 41, 31, 20 and 20 we have in our list, now I am going to print if any one. So not one, this L. So maybe I can write it as list. And here also I can list D. So if I just write list of D. Alright, so you can see what I get. It's all the number I have, or all the elements I have in the list underscore D, everything is iterable. That's why. Okay, maybe I can make it false again. Let's see what I will get. I will get true, because all the all the elements I have in my particular list, they are iterable, right? Yes, that's why we use any function. Now we have eval function. All right, what is eval function? Function passes the expression passed to it and executes Python expression. So again, if you just write eval and if you write x into 10, so what I have in x equals to, I had x equals to 20. Now in the under eval function, I have written x into 10. That means it will multiply 20 with 10. So as a result, you have to get 200. Let's see what we will get here. Yes, we get 200 instead of 20. If I just write 10, so we will get 100 over here, right? So yeah, this is how eval function works. And again guys, if you feel like noting down something, please do that, because it's going to help you out in any way whenever you go for Python interview. So yes, so for any interview, if you go, what are the things they will look into? They will look into, do you have really good basic idea about the particular language? If you do have, then they will you are the good choice for them, because who has the basic clear, they can do anything with the language, right? Yes, so please do I have keep that in mind. If you feel like noting down anything, you can do that. And one more thing guys, if you really like the video, do not forget to like it and do not forget to subscribe. Great learning. Now what we are going to do, we are going to use a float function. So as the name suggests, you will have a function which will basically help you to return your value to a float value. Right, suppose you write x equals to 9 and you will write print type x, right? So why we have used this type word particularly, but not word, the function particularly. Again, if you look into type, that is a function which is a built-in function in Python. So if you just write type of x, so you will get nothing but its integer. Now if you just write y equals to float 9, what you will get? You will get it's a floating value. So you have converted integer to float, right? So if you just write x over here instead of yes, so you can see you have just changed your integer or convert your integer to float, right? So this is how, yep, so this is how, or this is what we use float function. Now we are going to check that can I change my string to a float? Yes, you do, right? I am not going to write this one. So what I have a equals to, in the in the comma we have 0.9. Now I have written what is the type of a? Obviously it's string. Now if I just pass a out on float, function, it will give me the type of b equals to float, right? So what is that? It actually changed the string value to float value. If I just write print and then b, so it will do what? It will just write 0.9 and your b is nothing but type of float, right? Now we have one more function called format function. Yes, this is the most used function we have to remind. So what is format function? You have written data equals to the bag, then you have written in the curly bracket price colon, then 2f. 2f means nothing but your float, and then dollars. Right. In the type of printing, you have written data.format price equals to 149. So you can see the key was price and value was .2f, right? So you have written price equals to 149. So you have given that price is 149. As a result, you will get the bag $149, right? I can write the bag price. Yes, can you see what I have gotten? Yes, I get right. The bag price is $149, right? Yes, this is how we use format function. Then we have iter function. We have a little bit of length and min. These are really interesting to go with. Now let's have a look at what is iter function. So you have a list 1, 2, 3, 4, 5 and you just need to want to iterate, right? Now if I just write that I want to iter the list using for loop, yes, you can do that. You can just write print I in list iter underscore iter and then print I. You can easily print all the element you have in your list. Now comes the length function. Why do we need length function? So as we have already talked about, for a list, if you have a list, now if you want to check how many elements do I have in the list, again, the simple solution for you, you can directly go and check this particular function length and you can just pass the list. It will give you the length of the list. Right? Can you see? It's 5. Now there is a minimum function. So now I have a list and I want to check what is the minimum value I have in my list. So I have 1, 2, 3, 4 and then I have given 0.9, 0.8. Let's see what I will get. Can you see? As a minimum value, I have 0.8. That's why it's given minimum 0.8. Right? Yes, so this particular function help you to get the minimum value from your maybe list, set or tuple, anywhere you want to go for, right? Now we have set function that we have already talked about, which gives us the distinct value. Now we have sorted. Okay, what is sorted? Now, as we are really, don't want to do the sorting, this comes with data structure and you are someone who doesn't want to do this particular thing. So this is the solution for you. So Python do have built-in function for sorting your list, right? So, or maybe set or tuple, again you can do. So I have a list of AB where I have 9, 1, 2, 3, 5, 7, 9. Maybe I can add 56, I can add 0.1, I can add 0.2, comma, minus 9, comma, minus 10, right? Now I want to see if I want to get sorted, can I get this in ascending order? So what I have done, I have written up integer again b equals to, then I have called the function sorted, and I have just passed my list ab. Now if I just print it, here is your result. I have -10 first, then -9, 0.1, 0.2, 1, 2, 3, 4, 1, 2, 3, 5, 7, 9, and 56. So I can say my list is properly sorted without doing a much thing. So you don't need to put a lot of effort to just sort your list, right? Yes, so this is how you can use the sort built-in function in Python. Now we have input, one of the most used function again. So what is input? If you want to take an input from a user, right? If you want to take some input from user, how can you do that? Here is the solution for you. I have written a particular integer called name equals to input, and then any message if you want to show, please enter your name. Now if you just print name variable you have written, then you can see it's already given an option for user input. Now I have given Sampriti, right? So I get my name is Sampriti, right? So yes, this is how we use input function to get the user input. So there is a quick question from all of you. I want this answer in the comment section, that what function do we use to sort our list and what function do we use to take a user input? Please do let us know in the comment section. We would love to know from you, and maybe we will get to know as well you are actually learning from us properly. If you do have any doubt, please do not forget to let us know in the comment section as well. I hope this tutorial is going to help you to start your journey with data mining, with Python and the basic libraries as well. Now, what we are going to do, we have integer function. Again, this function is nothing but like a converting to integer that we have done for float. I don't think you need to learn these things again, but again, integer is nothing but like if you just call integer and if you just pass any kind of a string, float, or minus value, float values, so it will convert all of them to integer. Now if you give a float value of 11.52, how will it will convert it to integer? So it will just cut the decimal part and you will get only the absolute part, that's 11. Right? Yes. So these are the things you have to keep in mind. Then we have pow. Pow is nothing but if you want to do to the power, right? So if you just write 6 cube. So if you just write 6 and comma 3, it will give you the cube of 6. Now if I just to give 2 comma 3, it should be 8, right? Yes, you got the 8. So pow function is used for giving like to the power part. So maybe you want to do the 2 to the power 234, right? So that time, can you see the big number is? Yes, so that's why, and that's that time we use pow, right? Now we have range function. What is range function? So range function is nothing but if you want to iterate a loop with a range, right? Maybe you have written 0 to 4, it will go 0, 1, 2, 3. Right? So range is basically, the name suggests, it will give you the range. Now, if I just want to show you a few more things about range. So you have given 0 to 4. Now I don't want to change, or like when you are trying to print a pattern, you have to make sure that it will start from 1 or it will go till this, right? I don't want the, I just only want the even numbers and all these things. How can we do that? So for that, I will show you, you have to write for I in range. So we can do few things on range. And then I am going to write what? I am going to write 0, or maybe I want to start it from 1, or I want to start it from 2. So maybe I want to start it from 1, comma 10. So it will go till 1, 2, 9. So always remember, if you give 10, it will go till 9. Let me show you this first, and then I will show you few more things about range. Okay. Can you see? It goes till 9. Now, let me just create few more code blocks. Okay. Now, if I said I want to do few things. Okay, let me do this again. Okay, now you said I only want the multiple of 2. How will you get that? You just to write for I in range 2, 20, 2. Right? And then if I just print I will show you how it's going to work. So you give that the range will start from 2. I want 2, 2, and then I don't want 3, I want 4. The interval of the output I want, that is 2 until 20. Right? Can you see? You get 2, 4, 6, 3. Sorry, 2, 4, 6, 8, 10, 12, 14, 16, 18. So this is how the different way you can use range. Right? And it's again going to make your life easy. Now we have round function to get a round value. If you have 12.6, you will get 12. Or you will get 13. Or you have 20, it will give the round value 20. Right? These are the basic things we have done about, like built-in function. We have Python. Now we will jump into the user-defined function. So I hope you have understood all the the built-in function we have talked about in Python. Please do let us know if you feel difficult to understand any of the function. Right? Now in this particular demo, we are going to do the user-defined function. So as the name suggests, and already we have explained, this function are used for defining your own task. Suppose you want to add some new task which is not you have in the predefined or built-in function we have in Python or in the library, you can make your own function. How to do that? So this function are basically defined by the user according to the needs. Suppose I am going to create a first function and then I will call the function. Right? So let's see how we can create the function to make the first user-defined function in Python. So what we are going to do? We have written def. So anyhow, if you need to write a function, you have to use a keyword called def. Then I have given the function name, that is first function. Right? Then I have written print my first function. Right? So I have created the function. Now, how I'm going to use this particular function? In order to use the function, you have to call the function. How can I call the function? Then, if you just write first function and then parenthesis, right? The bracket. Then what it will do? It will just print my first function. Now, maybe you can ask, just to print my first function, do I just need to write a function? No, there are a lot more things we can do using function. I will show you anyway. But before that, just to make you understand the concepts of function, how can you declare a function and then how can you call it? That's why we have done the simplest version of the function. Right? I hope you understand about what is predefined function or built-in function we have in Python. Now we have started with user-defined function. Now, suppose you have arguments in the function. Now you will ask me, what is argument? Let me tell you what is argument. Right? Arguments are the way to pass information to the function. If you want to pass to some information to your function, we use arguments. They are specified after the function name and inside the parenthesis. I will show you how to do that. We can add so many arguments by separating them with a comma. Suppose you want to send information like tens information in a particular function. How can you do that? In order to do that, you have to use comma, which will separate your all the information. Now, suppose I am going to write a function for sum, right? So, what we have done over here, yes, we do have predefined function for sum, but let me show you if you want to pass some arguments in order to do the summation, how can we do that? So we have written def, that is the keyword we anyhow need to write to, write to start the function. So we have written def. Then we have written sum. The name of the function we have given sum. Then we have, like in the parenthesis, we have given x and y. What will be your x and y? Your number. So you want to do the summation for 2 number, or if you want to do the summation for 7, not 7, sorry, for u, comma, w. Right. So if you want to do the summation for total 4, total 4 number, that time you will give 4 parameters. That is nothing but 4 arguments to the function, right? Now, if I just write x equals to 10 and y equals to 20. So these are my information I want to pass to my function. Now, if I just write 90 and 10, I will get an error, right? So now I am going to write maybe u equals to 9 and g is equals to 8. Okay. Now I have given maybe x, comma, y, comma, u, comma, g. Right? Okay. Okay. I get an... Okay, I did not execute this part. That's why I'm getting the error. Okay, now you can see what I have done, right? I have shown you how to call the function, right? So what I have done, I have written x equals to 10, y equals to 20, u equals to 9, g equals to 8. Now you will say there you have written w, if you can look here, and you have written g over here. But trust me, it does not matter. What matters, this value you have under this particular variables, right? Maybe you can write I, j, k, l until it will take the argument. So it matters that you are giving the value or not. All right. So I have given sum 10 plus 20 plus 9 plus 8, that is equals to 47. Instead of x, y, u, g, if I just write over here, right? Let me just write sum 10, 20, 30, 25 and then 30. Will it give me the sum? Yes, it's giving me the sum of 85. So if you just want to print both of them, what do you need to do? You have to write the print function. You have to call sum. You have to call the function under print function. Right? Let me do that. If you have any doubt, please again do let me know in the comment section. I would love to solve your doubts anyway. Right? And let's see. Yes, I got 47 and 85. So it hardly matters you are giving all the numbers using variable or directly. Anyhow, it's going to give you the summation of the 4 integer or the arguments you have passed. Alright, so this is the pretty much basic schema of user-defined function. Now, if I just want to do the arbitrary arguments, which are args, they are little complicated, but let me tell you how it's going to work. So, if the number of arguments are not decided, suppose I said I will do it for 4 variable, but I don't know how many variable I'm going to have. In that case, you have to put the arguments. How can you do that? So, there is a concept called arbitrary arguments. If the number of the arguments are not decided, then this concept is used. So, add a star before the parameter name in the function definition. This function will receive a tuple of arguments. Let me tell you how to do that. Now, I have written def, the keyword, then the function name is second function, and I have written that star and names. So, n number of name can come and it will print. Right? So you can totally understand for the case of sum, if we just convert that, we will do that. Before that, just do the simplest version of arbitrary arguments and then we will do that. So I have written second function, then Sam, Toby, Lisa, Kate, Sham. So there is no particular, okay, I did not execute this. So there is no particular number I have given. I have just said that the name is going to come and you have to print it. So how to do that? Again, this is known as arbitrary argument. So keep that in mind as well. Now let me tell you how to convert this sum function with the arbitrary argument. So before I do that, why don't you do that in the comment section and let me know how to do that? Because anyhow, this type of doing this will be same, right? So this is a time for you guys to just write it in the comment section before you check this video, right? Before I am going to show, why don't you guys write that in the comment section that how can we convert this particular sum function with the arbitrary arguments, right? So let's see how can you guys were going to do, and let me do that as well. Sum def, so we have written def function, then sum, and then we have written d. Maybe I don't want to confuse it. Then I am going to write maybe numbers. Okay, then I have written how to do that. Okay, so what I'm thinking, please do let me know how to convert it, because I want to see. Let me do something else, because I don't want to show the answer right away, right? So maybe I am going to write okay, I am going to write, okay, addition. I'm not going to do the particularly sum one, because I want all of you guys to do that, right? And please do let us know in the comment section how you have done that, right? Okay. So after that, what I'm going to do, I am going to do the numbers. Let me print the numbers first, right? And then I have written addition, and then I have given 10, 20, right? I will get an error again because I have not initialized it. Okay, right, I get 10, 20. Now, so what we were doing, let me remove this particular part, what I have done, right? So what I have done, I have written def addition. I said sum will be done by you guys, right? So I'm going to check that whatever the number is going to come, it will basically get incremented by 10, right? How to do that? So what I have done, I have written print, then I am going to write numbers that we have done anyway, right? What it's going to give, it's going to 10, 20. Now what my output will be, I want that's 10 plus 10, 20, and 20 plus 10, 30, right? So any number I'm going to give, it will be incremented by 10. Now, first you have to look into what is numbers. Number is a list, number is a tuple, because anyhow we are going to give numbers. So if I just want to write print, and if I'm just going to write type, and then if I'm just going to write numbers, right? So I will give the type of numbers, like the numbers I'm going to give, what is the type? You can see this is tuple, right? As this is tuple, so I can easily use a for loop. So let me just do that. Okay, I have written for I in range, and it will go till the length. And what I have done, numbers of I is basically what? The value. I am going to get the value of numbers, that 10 and 20. Then I have just want to increment it by 10. Let me do that. Can you see? I got the output. That's 20 and 30, right? Yes. So this is how you can actually use these particular numbers when it comes to arbitrary number. So I have shown you how to increment it all the number with 10. Now you need to do how to do the summation, convert the summation function using this particular arbitrary arguments. So please do not forget to do that in the comment section. And if you like the video, do not forget to like it, and do not forget to subscribe. Great learning. Now what I'm going to do, I am going to do a keyword argument. What is keyword argument? Argument with key value syntax. That way we have done about dictionary. Right. The same way, argument with key value syntax. How to do that? Now I am going to write def new function. My function name will be new function. I have written name 3214. Now I have just written name 1 equals to Emil, name 2 equals to Tobias, 3 equals to Linus, and 4 equals to Sam. Right? Yes, now if I just write name 2, it will automatically, this is the key, and the value will be your names. So if you want to have a key value pair function, and if you want to send arguments like a key value pair, then you have to go for keyword arguments, right? Now we have default parameter value. What is default parameter value? Now if you just write something will be default, if you do not put any particular argument for a particular function, you have just going to write, that time it will be default parameter value. Let me tell you how to do that. If the function is called without argument, then automatically it uses the default value. You can totally understand. Now I have called a function of my country, and there I have written country equals to India. So I am going to print my country name plus country. So why plus? This is concatenating to string. So I have written my country name plus the value I am going to get. Now I have called my function my country and I have given America. Then I have given England. Then I have given Russia. But for once I have not given the country name. Here it will take the default value. Can you see? This is here. It takes India. So I did not provide anything and it takes the default value India. Alright. So this is how this particular default parameter value works. Yes. So this is pretty much about the user defined function we have learned so far. And one more thing we will talk about, and that is returning value, and then we will talk about this particular lambda function, right? The most used function in Python. Now what I'm going to write, I am going to so I'm going to passing a list to a function as an argument. Yes, you can totally do that. There is no such cases that you have to pass a variable only, not a list, not a set. So you can pass list, you can pass set, dictionary, anything. Now I have written def my fruit list, and my fruits is equals to will be the list. So obviously I got this apple, banana, cherry. So again, as an argument you can give anything, list, set or dictionary. Now there is a return value in the values from the function. What is return? So get a value or output from the function, we use return statement. So return statement is nothing but if you want to return anything from your function, we use return statement. So I have written def multiple of a. Right, I have given one particular parameter, that is a, and I want anything I have given that will be the multiple of 20. So I have written 20 into a. So if I just need to do that, can you see what I get? I get 60, 100 and 180. Right. So yes, this is pretty much about the return statement we have in function. Now if we move forward and let's have a look at local versus global variable. This is nothing but the scope of the variable. Suppose you have declared some variable out of the function, that will be your global variable, and if you want something if you have written something under the function, it will be your local variable. Now what's the difference between both of them? Global variable can be used anywhere in the program, whereas local variable can only be accessed under the function. Right, you can see this a is the global and w is the 10. Right, this is your local variable. Now if you want to print w after your function, you can see w is not defined. So your program doesn't know there is a variable called w you have, only your function know. Right, so this is how this global and local variable works. Right, if you have any doubt, please do not forget to let us know that. Right, and yes, now we will talk about anemonas function in Python. Right, so what is anemonas function? Anemonas function are always known as lambda function in Python because we use lambda keyword instead of def. So yes, this is the basic difference between def and lambda. So in the case of lambda, we use lambda function and we do not use def keyword. Right, a lambda function can have any number of arguments but can only have one expression. Now I hope you understand what is actually I want to mean by arguments, but expression by, you can say, this one particular task can be done using lambda. Now the syntax for lambda is lambda arguments then expression. Alright, so you have written date equals to lambda x sorry, I have written data equals to lambda x colon x into 3. So when I'm going to call data, this is your lambda function, I have provided 20. So it will give me 20 into 3, 60. Right, maybe we have written a colon a plus 20 for lambda. So I have written, I will get 25. So you can see the expression will be 1, the arguments can be n number of. Alright, now if I want to give multiple arguments on lambda, how to do that? Now I have written lambda x comma y colon x minus y. So I am going to do a subtraction and I have given 50 and 6. Yes, you will get 44. You can do a lambda function of multiplication. Again, you can do that. Right? So this is how our lambda function works. So please, I want to know from all of you, do you guys understood about lambda function and user defined function, and we have talked about built-in function. Do you have any doubt on these things? Please do let us know in the comment section. Right, now we will jump into the Numpy part, what we have left off. Now we will talk about Numpy. We already talked about Numpy. We will talk about the function we have in Numpy and how Numpy is going to make our life easy. So we all can say function or Numpy function or Numpy concepts of array. Anyhow, each and every one of them are making our life easy to do the coding. Right? If you agree with me, please do let me know that as well in the comment section. Now we are going to talk about Numpy that we have already started talking about, right? Now, after we know what is function, what are the type of function we have, and also how we can actually use this predefined or built-in function, maybe it is in Python or maybe it is in library, how we are going to use them. Right? So we have learned about that. So now we are going to do the most exciting part of Numpy function. What are the function we have in this particular library and how they are going to help us to actually make our life easy in order to do any type of numerical or mathematical operation if you want to do in your data. Right? So let's start with what are the function we have in Numpy. So we were talking about this particular part, right? So making a distance, and from there, just let me do that. Okay. So here what we have done last. So we make an array, and after that we did this particular operation that speed equals to distance by time. So yes, we can do that when we make it as an array. But if we make it as a list, that time we cannot do an operation like this directly. Right? So we have done that. Now, let me do one more thing. Right? Now I am going to create an array from a Python list. How can I do that? Now I have a list, right? Where my list name is my_list equals to I have written 1, 2, 3. Now I just want to print my list. Okay. So we have done this earlier as well, but just as a recap. So here we are going to write the type. Why do we need the type function? We need to if we need to look into what type of variable we have, it's basically going to give you what. I'm going to give the answer, but I want this answer from all of you. Again, please do let me know in the comment that why we use type function. Right? If you keep on using doing these practices and this exercises, it will basically help you to make your base for Python is more clear. Right? So I will expect from all of you that in the comment section you guys are going to give me that what will be why we use type. Right? So I have talked about this so many times. So yeah, again. So now what we are going to do, we are going to write type then my list. So it will give you what type of variable I have, that is my list. So my list will be obviously list type. The data type will be list. Now what I'm going to do, I am going to change it to array. How to do that? So I have said earlier as well, why do we need import? Why we write import numpy as np, right? So basically, why do we do that? So again, this is a question from all of you that why we have written as np, right? So Again, as NP is basically giving an alias to your library NumPy. Now I am going to write NP that as already I've given a short name to my library NumPy to NP. So I just called an array called dot array. Sorry, I just called a function called dot array. So I have written np dot array and then I have passed my list. Can you see? I have given the list in the parenthesis. So basically it means I want to change my list to array. Right? After I did that, you can see if I just do the type of my array, it will be type of numpy.nd array. Right? So we just saw that how can we change a list to array. Right? As we all know, array is really faster than list. Now I am going to create a single dimensional array with NumPy. How we are going to do that? We are going to write the variable name single underscore array equals to np.array. Then I want to pass a list that is 7, 8, 9, 10, 11. Right? So this is something we are going to make a single dimensional array. Right? So 1D array, this is known as. Okay. So you can see we have created a first single array with NumPy that is 7, 8, 9, 10, 11. Right? Now what I want to do, I want to create a multi-dimensional array. Okay. How we can do that? So in order to create a multi-dimensional array, I am going to give a list of tuples. Can you see? This is the list of tuples I have given. So here again, I am going to call the same function np.array. Right? Now, as I said, right? So this is something, and if you want to check the dimension of your array, how can you do that? Okay. Now I am going to write it's already coming, dot ending, right? So this is basically going to give you what is the dimension of your array, right? So what is the dimension for my array for this particular array? This is 2D array, right? As I have said, the tuple of list, right? Now, if I am going to write a list of list, if I'm going to give that, okay, that time what will be the dimension for my array? If I just write a dot ending, okay, let me do that. Yes, so that time it will be what? It will be 3D array. So you can see I have given list, right? You can see 1, 2 is a list, 2, 3 is a list, again its whole is a list, and again is a list, right? So this is how you can give the dimension for your array. Now if I just write, you can see lots of lists I have given, and then 1, 2, 3, 4, 5, 6, right? And now if I just write ending, so again it's what? It's nothing but your 3D array, right? Can you see over here what I have given? Right? So this is how you can actually give the dimension of your array. Now let's move further and let's have a look at, already we have given that ending is basically going to help you to check the dimension of the array. Right? I hope you understand how to create a single array, how to create a multi-dimensional array, what is list of tuples, what is list of list. Right? Now we have talked about how can you check the dimension for your particular array. So as we were talking about face recognition, or you were just giving a normal image. In order to give that, what's happening, these images are converted to an array, as we already said. It's because that if you are going to do face recognition, or you are going to do an object detection, how an object can be detected by a computer, because computer doesn't have eye. So again, there is image comes into the picture, which is a part of image processing. We don't want to talk about that. But one thing you have to remind in your mind that always these images are nothing but the array. It will give you a list of array, right? And the number has lots of things. It's fine. It's lots of things we have under image processing, but yes. So you have to know how can you handle arrays, a long array, different multi-dimensional array with NumPy, right? So yes, we have done this. Now we are going to check the memory size. For now being, maybe you don't need to know how to handle a memory size of an array. But when you are going to work with a huge amount of, data, an array will be a big amount. That time, if you want to check the item size for your data, How to do that? There is a function called dot item size, right? Okay, I get an error. Okay, let me just do that. Why? I don't want to see this. I want to see them. Okay, right. Let it get executed. Okay, and before that, I also want to print the arrays for just to show you what was the array and what is the item size we get, right? So give you a proper idea about that. Right, so our single array was 7, 8, 9, 10, 11, right? This memory size of the array is 8, okay? But when we are going to do a multi-dimensional array, then also the memory size will be 8, right? So yes, again, with time, the more you are going to work with array, you will understand this memory size concepts more, right? Now, if I want to check the type of the array, what is my type of array, right? So that time, I don't want this. So that time, maybe the D type means data type, right? What is the type of your array, right? From the function itself, you can understand D type. So this is nothing but data type that we have integer, float, string, right? What type of array it is. So for both of the cases, it is integer array, right? Next, go down. Now we are going to check the size of the array. Now, if I want to check the size of the array, so this is my array. Now, if I want to check the total size, the total elements I have in my array, for this case, maybe you can see, okay, these are the, like maybe it's 8 or 9 or 12, right? This many elements I have. Again, when we are going to use a huge number of array, that time if you want to check the total elements or total number or total data point you have in the array, we need to use dot size function. So I have written single underscore array dot size and multi underscore dimensional dot size. So for the first case, for the first array, we have the elements of 5, and for the multi-dimensional array, we have the element of 9, right? So this is how we are going to check the total elements present in the array. Now, if I want to know more about like the shape of the array and if I want to reshape my array, how can we do that? So basically, we are trying to understand more about arrays, and you can see there are lots of functions as well we have in Numpy who are actually helping us to manipulate these arrays, right? So if you have any doubt, please do let me know in the comment. I will happy to help you. And if you like this video, do not forget to like it and do not forget to share this with your friends who will get benefited as well. And do not forget to subscribe Great Learning, right? So now what we are going to do, we are going to check the shape of the array. So we are going to use dot shape function. Can you see? This is so simple to work with. Like you don't need to remind with a different name itself. If you want to check the shape, you can just write dot shape. If you want to check the, dimension of the array, you just need to write dot ending. If you just need to check the data type of the array, you just need to write dot d type, right? This is really easy to work with Python and these libraries as well, right? What do you feel about like working with Python is easy or not? Please do let me know in the comment. I think that is going to give me an idea that what I'm thinking, it's also same for you guys or not. Alright, so we are going to write single array dot shape and multidimensional dot shape. This is the most, truth is going to come. So this is something is going to give you, what is it? What shape it's going to give? The first total element you have and then the dimension of your array. So the first case we have 5 elements, right? As we can remember, and we have, it's a single dimensional array. Obviously that's why it didn't give anything. Then we have multidimensional array. And the dimension of the array is 3, right? And each and every dimension, how many elements we have? For each and every dimension, we have 3 elements. So don't get confused again. I am going to show you how this going to like give you the shape, right? Now, if I'm going to write multi-dimensional, right? Can you see for each and every shape, what you have? You have 3. each list consists of 3 elements. That's why it's given it's a 3-dimensional array with 3 elements, right? So for each and every element, for each and every dimension, you have 3 elements. So total you have 9 elements. I hope you understood this particular calculation. If you don't, again, do not, hesitate to let me know in the comment, right? So yeah, we are going to talk about how can you reshape your Numpy array. Right? So in this case, what's going to happen? It's just like we are going to use, first we are going to write an array, that np.array 8, 9, 10, 11, 12, 13. Right? Now what we are going to do, we just want to check what is the array, what is the dimension of the array, what is the shape of the array. Right? So what we have get over here, we get that this is a 2D array and each and every element have three the elements we have, right? This is a 2-dimensional array. Now what we are going to do, we are going to write, just to reshape it, we are going to write multi-dimensional array dot reshape 3, 2, right? Now what we will get, you can see the dimension will be 2 anyway, right? But you will have 2 elements, right? So basically you are trying to reshape your array. You had 3 elements per list. Now you will have 2 elements per list, right? If you can check it out, yes. And if I just write, yeah, you can see this is the ending after we did. It's again the 2D array, but the reshape, you have reshaped your array, right? So this is how we have done the reshaping. Now, again, if you want to go for reshaping 4, 2, and for that we have a array of multidimensional equals to np.array 8, 9, 10, 11, 12, 13, 14, right? And after you reshape it, can you see 8, 9, 10? Okay, before reshaping it, let me just print it. Right? Before reshaping it, you had like 4 elements per list. Now, if you check it out, you will have 2 elements in each list, right? This is how you can reshape your array in Numpy, right? Now, what we are going to do, we have done this particular part. Now, we want to concat 2 array. How can you concat 2 array, and what is concatenation again? Concatenation to array means if you want to merge 2 array, and if you want to make a addition of the 2 array, and if you just want to see what it's going to come. So you have a first array that will have 19, 12 and 13. Right? Then you have a second array that is 14, 15 and 16. Now if you just write np.concatenate, this is a function called name concatenate. You can see how easy it is. Like if you want to concat, you just need to have a function called concatenate. Concatenate first array, comma second array. And if you just want to print the new array, you can see all the elements you have for the both of the array, you get it in one array. You have 90, 12, 13, 14, 15, 16. Right? So this is how concatenation works. Now we are going to do the most amazing part, that is sorting an array. How can you sort an array? So here you just need to call np.sort, right? What you have before, you had 19, 12, 13. It's haphazard, right? Now after you sort your array, you get 12, 13, 14, 15, 16 and 19. Your array is sorted in an ascending order, right? Now let's move a little further and let's have a look at one more array where we have a really big numbers like 100, 1012, 112, like this. Now if I just want to sort my array, yes, 7 to 1012. So the first number will be 7, the last number will be 1012, and this is the ascending order. You have sorted your array. So you can see how it's making your life easy and how you are just going to do the sorting using just a function called .sort, right? Now we are going to talk about array indexing with Numpy, but I can see there are lots of demo we are doing with Numpy, and I should suggest you to use all the function we have learned to actually implement them in one array to have a better understanding about them. Right? So please do let me know what you feel after you actually used all the function in one array. Right? So please do let me know in the comments, and if you like it, do not forget to like it and do not forget to subscribe. Great learning. Now we are going to do our array indexing. Okay, so we can see there is a new array we have, right? Now what we are going to do, we want to try to understand how can you fetch the data or the element from an array using index. Index is nothing but for each and every array, or not for the array, for each and every element of the array we have this indexing. So this indexing starts from 0 if you want to fetch first value, that is 90. Right? So in this case, if you just write new underscore array and the square bracket, if I just put 0, this is first element starts with 0 in an array, that is 90. Now if I just randomly put 4, right? So in this case, I will get 15. You can see why. And guys, there is a quick question from all of you, how to check the length of an array, right? Let me know in the comment section for that. Again, I can understand you are understanding what are the function we have talked about so far, right? Yes. So yeah, this is pretty much about it. And now we will quickly look at the slicing of Numpy, and then we will do few of, how to find max minimum value from the array. And yeah, this is 2D array, and this is a basic part of array and Numpy we are going to do, right? So in this case, again, we have just talked about the new array, how can you do that, and how can you fetch the value from the array as well, right? So yes, we have talked about how can you fetch a value. I mean, if you just write 0 or the index 4, you will get the direct value from it, right? So the same way I have done for 1, I have done for 5 as well. So for 5 I get 16, and for 1 I get 12. Now if I just want to do the array slicing, yes, this is the most interesting part again, to start with slicing. Yes, you can literally slice your array. Can you even think of? Yes, using Numpy you can really do some magical stuffs like slicing your array. How to do that? So you have an array, new array, right? So be clear now, because you start with the slicing, because the most important concepts you need to know. Now I want to start from index 1 to go till 4. So again, the way we have done the range function, that if you want to go till 10, you have to give 11, because it goes before 1. Like if you give 4, it will go till 4, like it will go till 3, right? So here as well, I have given 0 to 5, it will go till 4, right? So here what I'm going to get, let me share. Okay, here it should be the comment. Let's see. Okay, so as your array is 9, 12, 13, 14, 15, according to this, you will get 9 to 14. No, you will get 0, 1, 2, 3, 4. So 0 says it starts from 0. So 90, 12, 13, 14 and 15, right? If you put 6, it will cover the whole array, right? Now, if I want to go for multidimensional array, so here I am going to write multidimensional. Okay, I have already put the paint. Okay, so here what I have done. So here you can see we have a multidimensional array 8, 9, 10, 11, 11, 12, 13, 14. Right? Now I want the second dimension starts from 1 index to go till 2. So your indexing for dimension also 0 to 1, right? It starts from 0. That's why I have given 1 for the second dimension, and I have given 0 to 4. So it will not touch 8, 9, 0. 8, 9, 10, 11. It will come to the next dimension and it will take from 0 to 4. So 0 to 3 it will go. So 0, 1, 2, 3, 11, 12, 13, 14. Right? So again, I can understand this is a little bit confusing, but if you feel it is confusing, you are not getting it, please do let me know in the comment. Right? So this is how we can do the slicing for the single dimensional array and multidimensional array. Now, if I just write 2 and after that colon, we did not give anything. So it will do what? It will go till 1, 0, 1, 2, that is till 13. And from there it will take rest. So 13, 14, 15, 16. So whatever you have after colon, if you do not put any limit, it will go the rest. Right? Now, if I just write -1, new array, what I will get? Okay, there is a negative indexing is also there. So if you just write -1, you will get the first value, right? So 16 is your last range and you will get 16 over here if you write -1, right? So this is how the negative indexing works as well. Now if I just write -3 to -1, it will give me what? It will, okay, for that let me just again print the new array, right? It will give me what? It will give me -3 to -1, right? So 14, 15. If I write -4 to -1, what I will get? I will get 13, 14, 15. So as I have given to -1, right? So what's going to happen? It's not going to take 16. As I have said, whatever you are going to give, it will go before that, right? Yes, so this is how this negative indexing works, right? Now we will look into little steps and then we will do the max and min value. How can you do that? Now you have an array. So these are all the part of slicing. I know this is little confusing, but trust me, if you know how to slice your array, the best thing you have learned so far. Trust me. So in this case, we have written 9, 12, 13, 14, 15, 16, the array. Now we have written 0 to 6 and :3, right? How it's going to work? So first it will take 90. So just try to understand one by one. We have 0 to 6. It will go till 0, 1, 2, 3, 4, 5, right? So as you have given 6, it will cover the whole, you can say the whole array. Okay, then I have given 3. So after 3 interval, I want my data. So first it's give 9. Then 10, 12, 90, 12, 13, 3 complete, then it will give 14, then 15, 16, right? After that, it's not able to complete because after that, I don't have any value. That's why I did not get anything, right? So this is how this particular things works. Now, one more thing I am going to show you. As I have said, after colon, if you just don't write anything, it will cover the rest. So it will start from 0 and it will take rest till 16. And for every 3 interval, it's going to give you the data. That is 90 and 14. If I write 2, every 2 interval, you will get the data. That 90, 13 and 15. Right? I hope you understand how the steps works and how we have done this. Right? Now we will talk about maximum and minimum value from the array. What do you think? What are the function name can be happen that like when we are going to do the max and min? Obviously, for max we are going to use .max function. For min we are going to use .min function. So as I have the array of multidimensional where we have the minimum value is 8 and maximum value is 14. So for max I have used .max function. For minimum I have used .min function, right? So this is how we are going to do this particular maximum and minimum, right? Now let's move further. We are doing a lots of demo, right? I hope you are liking it because I know theoretical portion is really boring to start with, but trust me, there are a lot of demo we have, right? Then we will talk about pandas as well, and then what? Then pandas demo we will do. And whatever the things we are going to do, we will do a whole demo on dataset, right? And I hope you will like it, right? Please do let me know your suggestions as well. What are the new things you want to learn from us? Okay, now we are going to talk about line place. What is line place? Line place is basically one more function in Numpy. Suppose you want, like it will give you a random value, right? So if you want just a random value will lie between 0, 4 to 7, right? And this random value, I mean, you can see you have 4, 4.5, 5, 5.5. So we have 1, 2, 3, 4, 5, 6, 7. So total 7 value we want. So I want a random value from maybe 5 value from 0.7 to, I mean 0.5 to 0.7, right? If I just write 0.4 to 0.7. So can you see what are the random 5 variable you get? Let me do this. Okay. It's giving me this. Okay. Let me write. Okay. So now what I get 0.4, 0.475, 0.55. So this is something you don't have control on it. If you want to generate a random array, you can generate a random array using line place. And what you can do, you can just say between this two number, I want this particular random variables, right? Yes. So yes, this is pretty much about, we have learned about line paste. Now 2D NumPy array. So we have talked a lot about NumPy array, 2D. Now we will talk about few things that you have to remember. Now you have a tuple, and how can you change that tuple to a NumPy array? So again, this is a question for all of you. As we have already converted a list to array, how can I convert a tuple to NumPy array? A quick answer from all of you in the comment section. Do not forget to do that. Now let me give the answer for that. Again, we are going to use np.array and we are going to give my tuple, right? Here, can you see I have given 1, 2, 3, 4, 5, 6, that tuple of tuples, and I get, when I have changed it to NumPy array, I get 1, 2, 3, 4, 5, 6, right? And this is converted to an array, right? And create an array from list. We have already done it, right? And yes, this is pretty much about the NumPy array we have done so far. But there is one more thing I want to show you, that's copy array using NumPy. How can you copy an array using NumPy? Okay, this is really interesting, right? If you just write np.array and if you provide list of list, you can actually create an array. Now I want to copy it. How can you do that? You are just copying in one array. Yes, I'm copying it. I'm not going to write it anyway. So we are going to use .copy function, right? If I just use .copy function, can you see my y is copied x? So this is how we can do more amazing stuff using NumPy. So these are the basics we have done. We have talked about the function. We have talked about the how can you create a basic NumPy array? How can you create a multidimensional array using NumPy? And we have also talked about, how can you find the minimum value, maximum value from the array? Then we have talked about how can you sort the array, right? I hope this actually help you to start your journey with data mining. Please do let me know in the comment section. In the next part, we are going to cover the pandas. What is pandas and how can we use them? The demo part as well. In this part, we are going to talk about pandas, which is one of the most used library in Python again. We have talked about NumPy, but in this part, we are going to talk about pandas, right? And it's known as the data manipulation tool. I will show you how can you manipulate your data using pandas. It's really interesting to learn these libraries from Python. So let's see what is pandas. So first, let's have a look at that is introduction to Panda, or you can say what is Panda. So Panda is a popular data manipulation and analysis library in Python, which is based on NumPy. Yes, Pandas is built top of NumPy, you can say. Now Pandas is a Python library that we already know, and the same thing, it's built on NumPy. Then how can you install Pandas? I will show you how to do that. Then we need to import the library. The two things you have to remind all the time whenever you are going to use any library. So that time you have to know how to install it and how to import that particular library, right? So yeah, this was basically pretty much introduction to pandas. Now we will see the most interesting part. Why do we need Panda? Before learning everything about Panda, you have to know the need of pandas. So we know that pandas is fast and efficient. I will show you how it's actually going to manage lots of huge amount of data, right? It's going to help you to manipulate them. Then we have, it provides necessary tools for loading data into memory data objects from different file formats. Maybe it's something you just want to load CSV file that is nothing but comma separated value, or you want to upload Excel file, right? Or if you want to upload text file, any kind of file you can easily upload using pandas to the Python, right? So this is why pandas is one of the most used. So when we talk to data science or anything related to data. So yeah, pandas is one of the most go-to choice when it comes to data manipulation. Then level-based slicing, indexing, and subsetting of large data set available. I will show you what is basically I want to mean by that. For the time being, you can understand data set. When you have a large data set, you can easily manipulate them using pandas. Then we have group by data for aggregation and transformation. So all the points we are talking about, right? The data alignment and integrated handling of missing data. Everything you need to know when you are going to work with a large data set. You need to handle these particular things. How can you do that? Yes. Again, the name comes into our mind, which is Panda. So we will start from the scratch of pandas. How can you start with Panda? What are the things you need to know in Panda? We will talk about that. So I hope you understand the need of Panda. Why do we need it? And how it's making our life easy. Now we are going to do a demo on Panda. And let's see how it's going to make us happy and our life easy.
Now we are going to talk about Pandas demo, right? Now we will talk about that Panda deals with 3 types of data types, right? And lastly, we will do that how can you upload different types of data using Pandas. We will do as well. But here we are going to talk about Pandas deals with 3 types of data structure. What are they? Pandas deals with series, data frame, and panel. But what is series? We will talk about that. So Pandas series is basically one-dimensional labeled array capable of holding data of any type. Like it can be integer, it can be string, it can be float, Python object, etc. Right? So what is series? Series is nothing but basically a one-dimensional labeled array capable of holding any sort of data. Right? Now, if you need to install Pandas, how can you do that? The same process. You have to write pip install pandas, right? And guys, there is a small question from all of you that how can we install Numpy? Please do let me know in the comment section. It's just a recap, just to understand how much you are learning. After you have downloaded or installed one library, what will be the next step? How can you use that particular install library in your code? What we do? That also I want to know from all of you. Please do let me know in the comment section. Right? Now we are going to talk about importing that particular library. So how can you import pandas? You just need to write import pandas. Again, I have used as PD. We have talked about a lot of time why we use as. Again, a small quick size for all of you. Why do we use as PD? Not PD. Why do we use as while we are writing import pandas? Right? A quick exercise for all of you. Right? After that, please move forward with this video. Okay. So for your quick recap, that why do we use as? We use as an alias, as a nickname you can say. So I just don't want to write pandas a big name for a lot of time. Right? So that's why I just give a name that is alias or a nickname to your library. You can say that is PD. Right? So I have written PD. So anytime I need to call pandas, I can directly call PD. So I have written import pandas as PD. Now we are going to talk about pandas series object. So how can you write it? You can write pandas.series, then your data, then index number, then type of the series like int64 or string, anything. Right? Now one by one I have written as well. Data, the data taken various forms like empty array, list, or constants. Right? And index is basically index values must be unique and hashable. And some length as data. Default NP arrange in N if no index is passed. So there will be default np.arrange. right? There, if there is no index, then there will be default np.arrange, right? Now comes dtype. That is will be your data type, right? If none, data type will be refer, right? If none, data type will be inferred, right? So basically there will be always a default way out for series if you do not specify it. Okay, then copy if you want to copy it, otherwise it will be default false, right? Now we are going to create an empty series. And now we are going to create an empty series. How can we do that? Now we are going to write demo equals to pd dot series. So we have called the function dot series. So here you can see, as we have talked about the function concepts. So yes, we are going to use the same concepts wherever we are going to use any sort of library. So we have written demo equals to pd dot series. So you have called the series function to create an empty series, right? So now I have written demo equals to pd dot series. Okay. I did not import pandas. Right. So I have created the demo, and demo that is nothing but an empty series. Now, as I said, if I don't give any data, what it will take automatically, there will be something it will take. You can see this is series and data type will be float 64. That will be default if you do not give any kind of a any kind of information about your data and you have just created an empty series. Now creating a series from an array. How can you create a series from an array? So, in order to create a series from an array, import a Numpy module and we'll use array function. So first what we will do, we will create an array and from there we will convert it to series. So in order to create an array, which library we need to use? A quick answer from all of you again in the comment section, right? So to create an array in Python, to do that, we need to import Numpy, right? The numerical Python. Now I have imported Numpy as NP. Now I am going to write a particular list, okay? And from there, I will write an array, and from the array, I will convert it to series, right? So there will be a full recap for all of you. How can you create an array? How can you convert an array to how can you create a list? From a list, how can you create an array? And from there, how can you create a series? So here I have written import numpy as np. From there, I have written demo2, my list name will be equals to great. So I have written GREAT. Lots of alphabet I have as an elements in my list, right? Now, after I did that, I have print my demo2, right? Let me just cut it. I will do it one by one, right? So I have done this. Now, okay. Now, if I just want to print my demo2, can you see I have created a list? Just for your confirmation again, I am going to print the type of my list, right? Okay. Okay. So I just want to add print as well. Okay. So it printed my list. That is great. And the type of the list is, and the type of the variable is list. Now what I want to do, I want to change it to an array. From there, I am going to change it to series. How can I change it to array? So I have written, or I have called np.array, and I have passed my list. After I pass my list, what will happen? It will change my list to an array, right? And my array name will be data. Now, if I want to print data, right? So it will give me same thing, again the grade. But now whenever I am going to print the type of the data, it will give the type of my variable. That time, first time it is list, and now it's numpy.nd array, right? Now if I just want to change it to series, as it's a part of pandas, so I have written series underscore d equals to pd.series. So I have called the series function from pandas. Do not get confused about numpy and panda, right? So for any type of kind of array, we have used numpy, and which will be the object of nd array. For the case of pandas, we have called series. After we call series, we have like what? We have passed the data that our nd array. Now I want to just print my series underscore d, right? Yes, can you see what I get? GREAT, but with that I have an index with it. Now, if I want to check the type of the series underscore d, pandas.code.series.series, right? Yes. So this is how you can change a nd array to series. But here we have done a lot of step, right? We have done first creating a list. From the list, we have changed it to array. From array, we have changed it to series, right? So you can understand the difference between list in the array and series. Now what we are going to do? We are going to create a series from text. What is text? That is nothing but your dictionary in Python, which comes under data structures, right? Now, how can you initialize basically, how can you initialize a dictionary? In that case, you have to use a curly bracket, and there will be a concept of key value pair. So we have talked about dictionary before as well in the initial part. Just for your recap, dict is nothing but there will be a key value pair you will have, right? And your key will be unique, right? So again, if you can remember this, please do let me know some other features about dictionary in the comment section. For that, I can understand you are actually getting the part of dictionary and the different data structure we have in Python, right? So we will do this, but before that, if you like the video, do not forget to like it. And if you do want to get a good notification about the new videos we are going to release, do not forget to subscribe Great Learning, right? And if you feel like this particular video is going to help you and your friends as well, please do share this with your friends as well, right? So yes, let's see how can you create a series from text. Now we are going to do creating a series from dictionary. How can we do that? Now I have written a variable name that data underscore 1, right? Now I have called this particular dictionary, and I have used a curly bracket. Now in this particular case, my key will be A, B and C, and I have 0, 1 to my value, right? Now let me just remove this part. Okay, now I am going to print data underscore 1. So this will print my dictionary. Okay, I have written a wrong name over here. Okay, now if I just write type of data underscore 1, okay, so I want to check the type of my variable called data underscore 1. Now you will say, why are you using this type for so many times? Because this will give you a good idea and the basic theory knowledge. Okay, now this is already done. Okay, now you can see the type of the data underscore 1 is dictionary. Now, if I just write is equals to pd.series, you are going to call series function again, and you are going to pass this data underscore 1. Now, if you just print is and the type of the is, it will be nothing but series, right? Can you see there is A0, B1, C2, and this is in64 Pandas series. So this is how you can change a dictionary to a series, and also you can convert anything to into series, right? Yes, so I have shown you how to do that. Now, now what we are going to do? Now we are going to do, suppose we have data underscore 1. Now we are going to give an index. How this index is going to work? Here you can see it's already taken the index, right? But how can we do with the name of the index over here, right? And I have added one more index that is not there in my dictionary. So you can see in my dictionary as a key I have A, B, C, but while I'm giving the index, I have given D as well. So what is going to take? There will be some default value as we have talked about before, right? Let me just do that. Yes, can you see for the case of value of B, it takes NaN value. So NaN is nothing but your missing value. So you have the key, but you don't have values. So this is how it's going to react when you are going to give an index, but it does not contain in your data, right? Yes, so this is pretty much about the how can you create a series from dictionary. Now creating series from list. So we have done earlier before as well, like using great. I'm not gonna show that. This is normal, right? We have done it. Now accessing element of series. How can it like access element of a series? Two ways to do that. One is accessing element from series with position, and second is accessing element using level or index. So you can see there is a two option we have. One is with position, one is with level or index. It's really interesting, right? How to do that. Let's have a look at how can we do that. Now, accessing element from series with position, in order to access the series element refers to the index number, right? Use the index operator, that is nothing but your square bracket, to access an element in a series. The index must then for the case of for the case of index must be an integer. In order to access multiple elements from a series, we use slice operation. So guys, what is slice operation? Give me a quick confirmation on that, because we have talked about slicing in Numpy array. So again, there is a quick exercise for all of you. What is slicing? Why do we need it? And how slicing is going to help us? Give me a quick answer in one line that what is slicing. Rest, if you write it, I can understand that. Okay, you have understood it, right? So again, a quick response from all of you. Okay, so let me tell you what is slicing. Slicing is nothing but it will help to slice your array, or it will help to slice your series, as the name suggests, right? So I have done this particular series underscore D. Now what I'm going to do, I am going to access this through the index, right? Can you see index number? Let me print my series T for your convenience to understand. So I have GREAT. If I write 4, I will get T. If I write, suppose, okay, if I write 0, what I will get? I will get G, right? And same way, if you have a long list and if you want to access any element through the index, you can directly do that. It's really working like with pandas are really easy and helps your life make it easy as well. So yeah, this is why we love pandas. We love different libraries in Python, right? Now we are going to talk about how can you make something like series, and how can you slice it, right? So in this case, we have created a pd.series, right? You have given a list 1, 2, 3, 4, 5, 6. Now you have given an index A, B, C, D, E, F, right? So according to all the number, it will take the indexing, right? Now let me just print it, demo underscore 2, 1, 2, 3, 4, 5, 6, and with that key you have A, B, C, D, E, F, right? Now if I just write colon 4, a quick response from all of you. If we don't write before anything on the colon and after anything on the colon, what it indicates, right? Quick information from all of you. Right. So let me know in the comment section. But as I'm going to give the answer, if you don't write anything, it will take the rest till 4. So not like, not till 4 basically. It will take till 3 because it starts from 0. So you can see 1, 2, 3. Okay. If you just write 3 over here, it will take till 2, but you cannot see till like taking till 2 or taking till 3, right? Because as I have given this as ABC. So you can understood that if you just write nothing in the front, it will, and if you just give the ending point, it will give everything till that point, right? The way slicing works. Okay. Now what we are going to do, like you can see Z0 R1, I have already written over there. So this indexing starts from 0 anyway. Now if you just write print series underscore D 2:4, what it will do, it will start from 2 and it will take till 3, right? So you can see 2, 3, 4. So it will take till 3. Okay. So the basic rules for like Python, the indexing start with 0, it will go till 1, like till the, like if you just give 4, it will go till 3, if you give 6, it will go till 5, right? So all the basic concepts will be same, slicing will be same, but you can do this particular features in these particular libraries functions as well. That is the main thing you have to keep in mind. Now if you just write series underscore D1 colon nothing, that means it will take everything from 1 to 4, right? So 1 to till whatever you have. If you do not specify anything after your colon, right? Now we are going to talk about minus indexing, right? How can you do that? If you write pt.series and the index you have given ABCDE, and if you're just going to print A's in the a square bracket, -2 and colon, how it's going to work. We have talked about minus indexing, right? How you are going to do that. So you can see it's going to take the last 2, right? So let me print A's as well. If you just write here, let's see what's going to give. So what is going to take if you just don't give anything over here and -1, it will take all the thing until minus E, but the E, that will be your -1, right? Now if I just change it over here, can you see it's only takes E? Yes, this is how the minus indexing works with Pandas series. And these are the things you can do using Pandas series, right? I hope you like it, and please do let me know if you have any doubt regarding Pandas series, because in the next part we are going to talk about the most used concepts of Pandas, that is nothing but data frame. So this is pretty much about the series we have done, and there is a quick response I will expect from all of you in the comment section, that if you have any doubt, if you like it, please do let me know. I would love to hear from all of you. In this particular part, we are going to talk about Pandas data frame. What is data frame? Why do we need data frame? We will talk about everything and what are the features we have in data frame. So yes, this is also a part of Pandas. As we already know, Panda is nothing but the Python libraries are mostly used for data mining, or you can see the data manipulation tool. Now you will ask me, if I don't load the data, how can I make the manipulation on my data? Yes, this is where data frame comes into the picture. You can load your data using like Pandas, and you can store them in data frame. Now the concepts comes into the picture. Then if I can store my data in data frame, then what is data frame? Right. Let me tell you what is data frame. Data frame is a two-dimensional data structure
which is the part of DS. You can totally understand. Data is aligned in a tabular fashion in rows and columns. Yeah. So your data will be aligned to a tabular fashion, we know, that is rows and column in data frame. So you can understand how can you load your data using data frame. Now, if we talk about the features of data frame, what are the features we have in data frame? So it's like potentially columns are different size, mutable, level axis, rows and columns, and also can perform arithmetic operation on rows and columns. So in the, like you can say, in a summary, we can say data frame is very easily accessible. You can load your data, you can make a manipulation on your data by using data frame with the help of few functions. That's why we love to use data frame, and it's one of the most, you can say, the vital and most used concepts in Pandas, right? Now we will talk about the syntax for Pandas data frame. You have to write pandas dot data frame just to call the function to make your program knows you are going to make a data frame. Then you have to pass your data, right? After you pass your data, you can have an index, you can give the name of the columns and the data type of your data, and if you want to copy it, then you can copy it again, right? So these are the parameters you have under this data frame function. Now a pandas data frame can be created using various inputs, right? You can make a data frame using list, using dictionary, series, numpy nd arrays, or another data frame, right? So these are the ways you can make a various inputs, take a various input and make the data frame. Now we are going to first create an empty array, then we will create a data frame, not an empty array, I'm so sorry. We are going to create an empty data frame, and then we are going to create a data frame from list, right? So let's have a look at how can you do that. So we have written import pandas as PD. So I don't think I have to again talk about why we use as PD, right? If you know that, please do let me know in the comment section. Repeat. So if you know that why we are going to use as PD, let me know in the comment section, and also let me know why we are going to use as PD, right? Yes, so we have given the alias to our library pandas. Now we have called pd.dataframe. So pd.dataframe is basically calling the data frame function. Now I have print my df. So you can see this is my empty data frame and I have no columns, no index, right? So this is how you can make empty data frame. It's really easy, right? Yes, when you will start working with data frame, you will feel like it's super easy and super cool to work with, right? And also I want to know your thoughts about it. What do you feel like? Like, we have learned so many things about Python and a lot more to know as well. What do you think? Whatever you have learned so far, Python is easy or not for you? If you are someone who had no idea before this course, course is basically again a design for someone who has no idea, who can start from the scratch and again learn about Python, and then also with time they can learn about data mining, right? So yes, please do let me know in the comment section what you feel about it. If you feel like it's really going to help you, please do let me know on the comment section, and please do like the video and do not forget to subscribe. Great learning, right? So let's create the data frame from the list. How can we do that? Okay, now again, I am not going to import the library again, as I have already import my pandas. Now I am going to have a list. How to write a list? You have to have a, to initialize the list, you have to have a square bracket. So I have written data equals to 1, 2, 3, 4, 5, right? As I have written data equals to 1, 2, 3, 4, 5, I have initialized the list. Now I want to print the type of the list, that I want to make sure what I have initialized is nothing but the list, right? After I do that, then I have to call pd.dataframe, and from the data frame we have to pass the list name data,
right? And then we will print the data frame as well, right? So this is what we are going to do. So you can see what we have done. We have created the data, that is 1 2 3 4 5. Yes. Okay, it's not printing or what? Okay, cool. Let me just do that one by one. Okay, so I have create the list. After I create the list, what I want to do, I want to say print type of data, right? After I do that, it will print the, okay, oh my god, I just misspelled the name, print name. Okay, right, now it will print the type of the data. Now if I want to print my data as well, so I want to see how my list looks like. So yep, you can see this was my input. Now what I'm going to do, I am going to write a list, right? Now we are going to write pd.dataframe, right? Can you see it's already came? Now I need to pass the list. Suppose I'm going to write data, right? After I do that, what it's going to do, it will actually change it to like the list to data frame. Let me write it D, right? After that, if I want to print it, so I am going to print list underscore D, right? So you can see the difference between list and data frame. You have index over here, right? Now you have index, can you see you have rows, you have columns, everything you have. Now if I want to print the type of this, I'm going to write print type list underscore D, right? Let me check. Yes, can you see it's showing pandas.code.data frame. Yes, so this is how you can create an empty data frame. You can create a data frame from the list. Now we are going to use a list of lists to create a data frame. So we have talked about what is list of list, a whole list you have. Under that list, you will have lots of small lists, right? So here we have Alexa 10, Ria 12, Sham 13. Okay. As we have this is my data, and the type of the data is nothing but list, right? Now if I want to convert it to data frame, I am going to write pd.dataframe. Then I have passed my list, that is data, and then I have given the column name, right? You can see this is nothing but your column name. Your column name is name and age, right? So you can give the column name as well while it's talking about the data frame. So your column name and age, name is Alex, age is 10, Ria 12, Sham is 13. So this is how also you can make a data set using tabular format. You can give a list of list as a data, and you can just specify the column you want to give. As I did not give any column name that time, it was 0, right? Yes, this is how our data frame works. Now I am going to create a data frame from dictionary. So before start with dictionary, please do let me know in the comment section how we can actually initialize a dictionary. What is the concepts behind dictionary we have, right? A very common word when the dictionary comes into our mind, the way we put the value. Please do let me know in the comment section. I want you guys to do this small exercise to get quite familiar with this particular topic, right? So please do let me know in the comment section how can you initialize the dictionary, and also what are the things comes into our mind first when we talk about dictionary, right? So it will always inspiring to see you guys are actually getting benefited from us, right? So please do that and do let me know. Now we are going to talk about how can you make the dictionary. So the first things comes into my mind when I talk about dictionary, it's key value pair, right? So you will have key, the unique key you will have, and you will have value according to that. How can you do that? We use curly bracket to initialize a dictionary. We have the dictionary key called name, and we have a list of name. Then we have age, and then we will have a list of age. Let me make it little big.
And we have standard. Which standard they are in right now, we have a list of that. Now if I just write pd.dataframe and if I just pass my dictionary, it will automatically take that. Don't you think it's really super cool to work with? Yes, they will take your key as column and a value as rows, right? So they will take key as like name is your key, and under name you have lots of names that will be your value. So they will take like the values as rows, and they will take the columns as your key, right? So yeah, I just said the opposite. So your key will be your columns and your values will be your rows, right? So this is how we create a data frame from dict of empty arrays and list, right? Now we will just talk about little more about it. So here we have list of dictionary. Can you see? I mean, I try to make it really complicated for you to understand, like for you, because to like give you the all the perspective and the way of doing it, right? So we make a lots of dictionary that makes a list, right? So you can see this A1, B2 is one dictionary. A5, B10, C20, it will be one dictionary, and the whole will be is a list. Now, if I just change it to data frame, can you see what I get? For A, it will anyway take the key will be your what? Key will be your column. So A, B, C will be your column. According to that, it will put the value. And when you don't have C value, it will make it nan. You can see this is how it is basically more intelligent, right, to work with. Okay, now we are going to do the selecting particular column or columns from the data frame. How can we do that? Now what we are going to do, how can you do the selecting particular columns or column from the data frame? So I have written df_1 and then I have written name, age and standard, right? So this is something we had the df_1, this data frame we have created. Now if you just want to have a name or just want to have the name, age and all, or you just want to have the age, right? How can you get a particular column from that? So what we are going to do, we have just written the data frame name, that is df_1, and then we have written name, your column name. What will happen? Plus B, make sure you have these particular square bracket, right? So you have Tommy, Jack, Sam, Ria, right? Only the name. Now if you said I only want to have name and age, not the standard. So in this case, you have to provide list of list, right? I have written name, comma, age, comma, separated value, that name, comma, age, and it will be list of list. Can you see we got the result? It is list of list and we get only the two columns, that name and age. Now we will talk about Pandas log function, the most used concepts in Pandas. What is log function? So Pandas provide a unique method to retrieve rows from data frame. As we have already said, working with data frame, it's really going to make your life easy. So keep that in mind. How they are going to do that? There are lots of functions you will get which will actually help you to do that. I have written dataframe.log and it will be a method to it helps to retrieve rows from Pandas data frame. Now I have the data frame of df_1. Let's do this function on this particular data frame. Now if you just write df_1.log and then in the square bracket if you just provide 0, what it will give? It will give you all the information you have in the row 0, right? So in row 0, what is my information? Tommy 28.5. I'm just highlighting it. Can you see? You get Tommy 28.5. Start. So you can see we got this Tommy 28.5. Now if we talk about just to get 3. So in 3 what we have? Ria 42.9. Can you see we got Ria 42.9.
if I want to put something else as well, if I just write df_1 dot log, right, and I'm going to say 2, right? So what you will get? You will get 2, all the information about 2. So how can you do that? If you just write 2 is to 2:5, right? If you just write it, so what will happen? You will get 2 till 4, right? I don't have till 4, that's why I will get till the last value. Now if I just write 2 colon then nothing, if I just write nothing, right, so it will take all the rest the value, right? So this is how our df1.log and slicing, right, all the concepts you can easily work with, right? Then we will talk about Python pandas ilog. Now, in this particular part, we are going to talk about pandas.ilog function. What is .ilog function? We have talked about log function, shown you how can you start with log function. Now, in this part, we are going to talk about ilog. So, basically, this is also one of the process to be fetch your data from pandas data frame. We have talked about data frame. A quick question for all of you guys. What is data frame? Please do let me know in the comment section and we can understand you are actually understanding what we are talking about. If you have any doubt, do not forget to put that in the comment box. And if you like the video, do not forget to like it and also subscribe Great Learning. Now, in this particular part, let me show you we are working with df_1. What was that? This is basically a data frame where you have 3 columns. One is name, age, and standard. Now, in this part, I will show you how to work with ilog function. So, you can understand this is nothing but again kind of a slicing. Here, we are again going to give the index position. So, before jump into the demo, so there is the parameters we have, that index position we have, and index position of rows in integer or list of integer, right? And the return type for ilog is data frame or series depending on parameters, right? So let's see how it's going to work. Let's have a look at the demo. Here we are going to do what? We have written a variable called row1. That's equals to df_1 dot ilog. That's like in the list we have given 1, 3. What is going to take? In this particular thing, it's going to take 1 and 3. Can you see that? So you have given 1 and 3. It will only give you 1 and 3. In the case of log function, it will give you 1, 2, 3, right? So in the case of ilog, it will specifically will give you 1 and 3, right? So this is how our ilog function works. Now, if you want to look at the few other demo, let me show you that as well. Here, maybe I am going to write, demo 2, I have given this particular variable name. That's equals to, I am going to write df_1 dot ilog. If you write ilog, yes, it's came. Now I am going to print 2, 4, right? Let's see how it's going to give us. So yes, I have given list that 2, 4. Let's see. Okay, out of bounds. Why? Okay, I have index till 3. Okay. So maybe I will give 2, 0. Okay, so it's get executed properly. Now what I need to do, let me just print demo_2. So demo_2. If I print it, can you see what I get? I get 2 first, then I get 0. So how the way you have given that what index you want and what are the way you want, right? The sequence I want first 2, then 0. You will get it. So I get basically 2, the 2 row first, and then I get the 0, 1. Okay. So yes, this is how our pandas.ilog function works. I hope this is quite clear to all of you guys how log function works and how ilog function works, right? So now let's see how we can do few more functions in Pandas to actually manipulate your data in a very easiest way, right? I hope you will get these things, like what is log function, what is ilog function, how can you use them. You get these things, right? Now suddenly I have this data frame, and from this particular data frame I want to have a look at. Suppose I have the age column. Now I want to look at the maximum age I have in my data set. How can I do that? In order to do that, I can use df underscore 1. Then in the list, I have given the column name, that is age. And from there, I have written dot max, right? While you are going to write dot max, it will give you the maximum value you have in your data set. Now, in the same way, if I want to see the minimum value, right? If I want to see the minimum value in my data set, that time you have to use dot mean function, right? So this dot min, that is a short form of minimum, right? So if you write dot mean, it will give you the minimum value you have for this particular column called age. All right, it's again 28. Now again, if I want to do the same thing for standard, let me okay, here I need to add the cell. So again, I hope you guys have quite familiar with how to add the cell. Okay, now what I want to do, I want to see for df1, okay, for df1 and then standards, right? For okay, for standard, okay, standard dot mean. So what is the minimum standard I have in my data set? That's nothing but again 5. If you can look at, we have 5, 6, 7, 9. So here it's showing 5. Now if I want to do the maximum, so what we are going to use, we are going to use the same function, that's max, right? Yes. So this is how you can easily see your data, and also you will get your data as well, right? Yes. So if you have any doubt, again, do not forget to add that in the comment section. It will always help us and all you as well. So we had done the maximum and minimum part. Now if you want to see what is the average age I have in my data frame, right? So in order to do that, what do you need to do? So maybe you want to see the mean, right? How can you do that? So in order to check the mean for your age column, I am going to write df underscore 1. Then I'm going to write age and then dot mean. Okay, so it's going to give you the mean value for your age, right? So the mean value is 33.25. So in about you can take 33, right? So this is how we can do the basic manipulation of your data. Now we are going to talk about null value. What is null value? So null value is nothing but, again, if you have any missing value or a blank place basically in your data set. Now I have written one dictionary where I have first, second and third as my key, and I have a list of value which will be my data, or nothing but you can say the values in terms of dictionary. So under first we have 190, then we have np.nan. So again, if you want to create any nan value for your data set, we use numpy, and in numpy we have a function called .nan. Right, so I want to put a blank value for that. I have written np.nan. Now I have 95. Then in the second key called second, where we have again a list where we have 30, 45, 56, np.nan again. We have the third key where we have the third key, the name of the key again third, and we have a list of values, right? Now after I made it dictionary, I want to change this dictionary to data frame. How to do that? In order to do that, we need to write pd.dataframe, and you have passed the date, right? You have passed your data to change your type of a data to data frame. Now if you want to check that is it going to be data frame, so For your convenience, we can write print, okay? Then we can write, okay, then we can write type, right? And from there we can write dict. So it will show the type of the dict. So it's anyway, it's dictionary. Now if I write print, again, if I write type, then complete the parenthesis, then I'm going to print df, okay? Let's see what's going to give. So first time, it's the type of the dictionary. It's obviously dictionary. Then the type of this, it's nothing but Pandas code data frame. And this is your whole data frame, what you have made. Now, if I want to check the first 5 data from my data frame that we have talked, we use .head function or we use .tail function. Now, if I want to check, is there any null value is there any null value we have in our data? How to check that? In order to check that, what we do, we use a function called df.isNull function. So df.isNull function is basically going to give you an idea, do I have any null value? So if I just write df.isNull, so in the case you can see we get false, false, then true. Alright, why? Because this boolean value they are actually sending, returning us, because the true is basically yes, you do have null value. For each and every row and columns, if you do not want to see, you can simply put .any. So it will give you column wise. So for the first column, for first, do you have any null value? True. For the second column, do you have any null value? Again, true. For the third column, do you have any null value? Again, true. Alright, so this is how we can do is null. Now, if you want to check the total summation of the null value you have, how to do that? In order to do that, you need to write .sum. Okay, so in this case, okay, let me just do this. I have written df_1. Yes, in this case, you can see the sum is showing for each and every column. So you can see that they are doing the column operation. For the column first, you have one null value. For the second column, you have one null value. For the third column, you have one null value. Right? So this is how we can do the null value checking for your data set. Now, if I move further and if I want to say, hey, I have null value, I can see this is after running the df, it's showing after null value we have. But I want to fill this null value with few things. What are the things you want to do? So the first things comes into the picture, you have to fill the null value. How can you do that? There is a function called .fillNA. In that particular function, you can actually see or you can actually change your null value, right? How to do that? In that case, you can just write, let me change the df to df1 because I want to show few things as well. So df_, maybe you can write 2, right? So if you write df_2 equals to df.fillNA, then what you want to fill with the nan value? Like 0. I want to fill all the nan values with 0. Right? So if you just do that, yes, it's going to work. Now, if you just print it, df_2, it will show you that the null value we had for third column in the first row, it's 0. For all the null values, you can see it's 0. Now, I want to fill this null value with few other things as well. So while we do outlier analysis, we have talked about that. So, no, we didn't repeat. So basically, if we want to actually fill these null values with 0, or we can fill this null value with the mean value. So while we are going to do the outlier analysis, you can see in the outlier analysis what we do in basically we try to fit this null value with the mean values, or median as well we can do. Now, how to do that? If I just write df_3 is equals to df dot fillNA, okay, then if I just want to show one more thing to you. code. So before doing that, if I just write df dot mean, okay, as I said, not specifically for any particular column, so it will give you for all the column. Now if I just write df dot mean, right, can I do that? Yes, you can do that. So I have replaced all the value with the mean value. Now as I have done this, I want to see what mean value they have done. So you can see they have done for third column, we have the mean value 72.6. So here you can see this is 72.6. This is replaced with 72.6. Now in this case, it's 43.6667 in the case of second column. So what it does, it basically replace all the nan values with that respective column, column mean value. Right? If you want to do it with median, so maybe if I can going to change it to median. All right. Here also I want to see. Okay, print. Just writing print because I want to see the mean and the median both. I'm going to write print df dot median. Okay. So median value is 95, 45 and 80. So if I just do the same thing with df underscore 3, can you see? Yes, this is replaced with the median value for respective columns. So this is how our null value works, and this is how you can replace your null value with 0 or mean or median as per your understanding or as per your requirements. Now if I just go a little further, here what I want to do, here I want to just drop the missing value. How can I do that? In order to do that, again I have written this particular dict. Okay, now after doing that, I am going to use a drop any function. So we use dot drop any. So this dot drop any is going to help you to drop your all the null values. Right? So how can I do that? Now, if I just write a is equals to df dot drop any, and now if I just, if I just write that a will be what? A will be your data. Okay. Now, let me show you. If I just write df. Okay, these are the thing I am going to get. Dot drop any. Okay, can you see what you get? You get 90, 45 and 40. Why? Because this drop any, for this part you have a nan value, for this you have, and this. So they will actually drop all the rows you have which has the null value. Not every time it's recommended to do that, but yes, if you want, you can drop the null value rows. Right? I hope you have understood about ilog function, and we have talked about few like functions in data frame that you can directly use. Please do let me know in the comment section if you have any doubt. We will happily help you out to solve your doubts. And if you like the video, do not forget to like it and do subscribe. Great learning. Now we are going to do a very interesting part with pandas. That is nothing but we are going to load a data set in order to show how can you do all these things, whatever we have learned about pandas in a data set. Because in the real world, you have to work with the data set and you have to understand the data set and you have to manipulate them as well. So here is the most important part we are going to do. I think you all are excited like I am. So how can I actually teach you how to use this driver, Uber driver dataset? So I have taken this dataset from Kaggle itself. It's a free dataset and you can also use them from Kaggle. Now what I'm going to do, I am going to upload this particular dataset to my session storage. What is the session storage? If you want to look into that, then again, you have to check out our video on Google Colab tutorial, right? But as a heads up, I can give you a quick hints about what is storage, session storage I want to mean by. If you click over here, you will get the option. So my runtime is going to get connected. Yes, after it gets connected, I will show you how to upload it. The option will pop up here. Can you see the option came? Now you can see this is already there. Now if you can click over here, it will redirect you to your local system, the way it's showing for my case, right? After you did that, you can directly select your dataset, and from there you can upload your dataset. Now what I'm going to do, I'm going to use pd.readcsv. So PD is for pandas. Read underscore CSV is the function used for reading the CSV file. Now you have to give the path for your dataset. But where will I get the path for my dataset? I will show you every possible things, and every doubt you have, we are here to clear that, right? So how to do that? You have to click over here, and from there, if you just hover over this particular data set, you will get these 3 dots. Just click over these 3 dots, you will get an option for copy path. What you need to do next? You just need to copy and paste it. Okay? Yes, this is what you need to do. This is the path we have. Now, if I just execute this, what will happen? It will nothing but store my data. How to check that? I will show you how to check that. So we know how to use data.head. Yes, so I want to see the first 10 column from my data set. Yes, it's going to give me that my data is already uploaded and stored in my variable called data or not. Yes, it is. So you can see the first 10 rows of my data. Right? So this is the first 10 rows from my data set. Now, if I want to see the last few or last 5 rows from my data set, then again, I'm going to use data.tail. Right? So, shift enter. Again, it's giving me the last data set. With that, I can see the total number of data we have. That's 1155. The last one, right? Yes. Now, if you want to see what is the total columns we have under this. So, in this case, we have data.columns. So, it will, actually return you all the columns you have in your data set. I hope you have we have talked about this particular before as well. So it's just a recap, as well as do not get confused while we are going to use a lot of data set and we are going to use an actually huge amount of data. So in the real world, you have to work with a huge amount of data, as that's why we use this particular data science, or you can talk about the data mining things works, right? So if I just write data.columns, it will give you all the columns you have for this. Alright, I hope it's clear. If you have any doubt again, please do let me know in the comment section. I will obviously come back to that and will help you to solve your doubts. Now we are going to use sample. What is sample? So now these are the things we have that's new. But before going to sample, I want to show you few things. So if I just put some code file here, right? What I want to do, I just want to check the shape of the data, right? I have written data.shape. So it's saying that all total data we have, that the columns we have 7 and the rows we have 1156. Now, if you want to say, I want to say do I have any null value? So now for that, I am going to write data.isNull. I hope you all can remember what to use is null, what to use .any and where to use .sum. So I just want to check for column wise, do I have any null value? If I have, please show me that. So for start date, no, I don't have, but for end date, category, start, stop, we do have null values. For purpose as well, we do have null value. right? So this is how we checked our null value. Now if I want to do the summation, the total number of null value we have, for that what we do, we just write data dot is null. Okay, we just write data dot is null and then we use dot sum, right? So it's going to give you total summation of the null value you have. For all of them, we just have one null value. That hardly matters while we are having a large data set. Now, if you want to change them, yes, again, you can fill that with 0 or you can just, fill that with the mean according to your requirement. Now, I just want to take a sample, right? Few sample from my data set, not all. That time I need to use a function called dot sample, right? And here you can see this is the sample, not the whole data set I have. So total I have 10,000 rows as I have mentioned. Now if I just write 500. So the total row I will have 500, but as a random manner. You can see we have 727 index, then 95, then 8911, then 2. And if I again do that, yes, can you see? This is what's going to happen. The reshuffling is happening. So the sample is basically taking the sample from anywhere from your data set, not you cannot say it's taking it from the first portion or the last portion. It can take it from anywhere. So for checking the columns, again, data dot columns, for data dot rename. Now if you want to rename your columns, how can you do that? I have column name start date, then star, end date, then star. I don't want all these things, right? I want a clean, a clean data set with a clean column. So in this case, you can just write data dot rename, and in the parentheses, you can write columns and the curly bracket, then the previous name, colon, the name you want to give, right? The start date star was the previous name you want to give start date. Right? So you can actually rename your dataset like that. Now, if you just write data.columns, you can see the updated column name you have. Now we have data.info. Why do we use info? We use info basically to get what is the data type for all of our columns. Do we have any null value? So basically, it's going to give you the information about your data set. Now you can see the start date has no null value, right? End date has no null value, and start date has null value, that's 5, and the data type is object, right? And again, the way you can see, these are the way you can actually check that do we have null value and what is the data type of the null value, right? So these are the basic function we have done. Now we will talk about describe method. What is a describe method? So it is used to view some basic statistical details like percentile, mean, standard deviation, etc. of a data frame or a series, right? Or a series of numeric values. When this method is applied to a series of string, it returns a different output. Mean is the average and its expected value of distribution. On average, you would expect to get this number. Now, standard deviation tells you how big of swings that the data takes relative to the mean. Specifically, it's the mean squared deviation from the mean. So this is nothing but your statistical understanding. Now, 50% is also the median and marks the midpoint of data in a column that we all know. This means half the scores are greater than or equal to this value of median and half are less, right? Now we will talk about interquartile range. In the next part anyway, we are going to cover all these things about the basics of statistics part. So 25% is a lower quartile, that 25% of score fall above the lower quartile. 75% is the upper quartile and 75% of scores fall below the upper quartile value. now mean value, maximum value, and count. So these are the things it's going to return when you write data.describe. So for count you have this, for minimum you have this, for max and all these things, right? That we have talked about just now. Now we have done this data.shape part, right? Because it's have nothing but, yes, 5, 7, right? So you have, okay. So here, what we have done, we have done the type, size, data type. We have done is any again, it's for checking null values. Then we have head. Then we will do something data manipulation. What type of data manipulation we are going to do? We talked about lambda function, if you remember, right? So before talking with the lambda function, let me know quickly in the comment. Do you remember lambda function, what we have talked about before? I want a quick understanding and information from all of you. Do you know what is lambda function? If you know, please do let me know in the comment section what is lambda function, right? And I would love to see all these comments. And if you are not right, I will help you to have a good understanding on that as well. I think this is interesting, right, for all of you? Yes, please do like this video if you like it, and do not do not forget to subscribe Great Learning as well. So data dot rename, and we have given class lambda x, and then in place equals to false and dot head, right? So rename columns with the first 3 characters of each column, right? So this is something I can show you what is data manipulation. What I have done, I am going to replace all the first 3 elements, or I can make it 4, right? All the first 4 elements as the column name. Can you see? The star, end, underscore, cat, star, stop, mile. So these are the things you can do using this particular lambda function and using pandas as well. I hope you have actually learned about what is panda, what are things we can do with panda, right? The data, starting from data manipulation to load your data, to actually make your have a good understanding about your data. So please do let me know if you have any other things that I have skipped about panda. I will happily make to understand that what are the things we have talked about. I hope you have a good understanding right now about the panda, right? So we will see in the next part that how can you actually visualize your data. After this, we will go back to the presentation and we will see how can you do the data visualization using Matplotlib and Seaborn. It's going to be more interesting, guys. Let's see how we can do that. In this particular module, which is named as data visualization using Python, we are going to talk about how can you visualize your data, right? What are the library we have? Before that, already we have talked about what a library. What are the library will help you to manipulate your data. Now, in this part, we are going to talk about what are the library we have in Python which are going to help you to visualize your data. Now comes why do we need to visualize our data? As I have said, that if you need to have a good understanding about your data and a good way to write your data, you have to know few things about your data, which are not possible all the time to do the data manipulation, or by just giving some or using some statistical techniques while understanding your data. And that's why we needed data visualization. Visualizing our data, we can actually get some hidden treasure or hidden idea about our data. So let's see what are the agenda we have, or what are the objectives we have for this particular part. So first, we are going to talk about what is data visualization. Then we will have a look at what are the libraries in Python for data visualization we have. Then we will see the library as we have talked about, that is introduction to Matplotlib. Then we will jump into the basic demo on Matplotlib and advanced data visualization with Matplotlib. Then we will see intro to Seaborn. Again, Seaborn is nothing but a library from Python to help you on visualizing your data. Then we will see what is the difference between Seaborn and Matplotlib.
While we have Matplotlib, why do we need to have Seaborn? We will talk about that. Then we will see basic demo on Seaborn and also few advanced data visualization with Seaborn. Right? I hope this particular part will be really exciting for all of you guys. And if you really like the video, do not forget to like it and do not forget to subscribe Great Learning. Every time we are going to come up with the new content, you will get notified, right? So do not forget to do that. So let's start with what is data visualization. Data visualization is an important and also one of the most initial steps in the process of data understanding. Now, as I have said, maybe you are using some statistical techniques or few other techniques to understand your data and manipulate your data. But few of the time, all the technique rather than all the technique also, you need a way to see your data, which is nothing but your visualization data. It gives you a more clarity on what you are working on, right? So that's what we need data visualization. Now, data visualization helps in identifying hidden patterns, outliers, and relationship between the variables in the data set. Actually, it makes your life easy as well, right? So this is what about the data visualization and why do we need data visualization? As we are talking about, all the companies are currently working with data and they have a huge data set as well to work on. So while you are working on a huge data set, all the time it's not possible to put a statistical methods or giving some other techniques to understand your data, because that will be costly and time consuming as well. But while it comes to data visualization, it's easily going to give you a visualization about your data and you will get a good hands-on and good idea or grip about your data as well. So you can totally understand why we need data visualization. Now we will see the libraries in Python for data visualization. We have Matplotlib and Seaborn. Right. So guys, quickly let me know in the comment section how many of you actually heard these two library known as Matplotlib and Seaborn. Please give me a quick response on the comment section. For that, we also can understand how many of you have already have the idea about this data visualization libraries. Right. So first we are going to talk about Matplotlib, and from there we will do few demo and then we will come back to the presentation. And yeah, again we'll talk about Seaborn, the difference between Matplotlib and Seaborn, and how this Seaborn you can do the demo using Seaborn library. I think it's actually interesting, right? Please do let me know in the comment as well. So what is the introduction to Matplotlib? Matplotlib is a far-reaching visualization library for creating static, animated, and interactive visuals. Now, Matplotlib is one of the most popular Python packages used for data visualization, and it is a cross-platform library for making 2D plots from data in arrays. So you can see you can really easily make 2D plots using Matplotlib. Now we will talk about the basic demo on Matplotlib. In order to do that, we are going to use Google Colab, and we will do basically two parts: basic demo on Matplotlib and also advanced demo on Matplotlib. So let's go to Google Colab and let's have a look at what are the things we are going to talk about for Matplotlib. So now we are going to talk about the data visualization. So we know what is data visualization, right? So data visualization is an important business tool. It is one of the initial steps in the process of data understanding that we have already talked about. And visualization helps in identifying hidden patterns and also the relationship between the variables in the data set. Now we will start with Matplotlib. Matplotlib is a far-reaching visualization library for creating static, animated, and interactive visuals that we have talked about. Now, how can you import Matplotlib? In order to import Matplotlib, you have to write import Matplotlib. Now, you have to import one more thing, that is import matplotlib.pyplot as PLT. What is that? Matplotlib.pyplot is a collection of functions that allows Matplotlib to work like Matplot. Right?
Now, as we have talked about that, my matplotlib.pyplot is a collection of functions that allow matplotlib to work like MATLAB, and also .pyplot function are what generate the final plot and make it look presentable by adding axis levels and legends, right? So this is what matplotlib stands for. And what's the difference between matplotlib and matplotlib.pyplot is the most common asked question while it comes to matplotlib. Now, if we talk about the types of plots, is a bar plot, make a bar plot. Then we have bar H to make a horizontal bar plot. Then we have box plot. For box plot, we use basically for, finding out the outlier. What are the type of outlier? I mean, what is the outlier you have for what are the columns? We will do it in the next part as well. That time you will get to know how box plots it's gonna use. Now we have histogram. We have histogram 2D and it makes a 2D histogram plot. Then you have pie plot to plot a pie chart. Then you have normal plot will mix the axis and the normal plot lines. Then you have polar. You have scatter plot and stack plot draws a stacked area plot. Then stem you have. Then you have step, make a step plot, and you have quiver plot. It's plot a 2D field of arrows, right? So this is what basically plot we have in Matplotlib. Now we have few function for image. Suppose you want to read an image that we know we are currently working on, something like image processing, object detection, but how they are going to work on that, right? So we have few function in Matplotlib in order to do these things. We have imread, which can read an image in like type of array, right? Into an array. It's converting that image into an array. Then we have save an array as an image file. Then we have show, display an image on the axis, right? So the axis function we have, which is axis, add axis to the figure. Then we have text function, title function, x level, x lim. So that's x lim is basically get or set the x limits of the current axis. Then we have x scale, then x ticks, then y level, y lim, same for y as well. Now we will start with our basic, plotting with Matplotlib. Suppose you have x list, right? So what is this x? X is nothing but the list. We will see how can we do that. All right. Then you have a list of y. Y equals to 3, 6, 9, 12, 15. Right? You have done this. Now, if you just write print type of x, right? And also print type of y, right? So if you just print it, you can see the type of x and y is list. Now comes plotting. So we just try to plot the few numbers we have in x and y axis. In order to do that, what are the thing you need to do? You just need to write plt.plot and then you have to provide x and y. And for the giving the label of the x level name, I have written plt.xlabel, then multiplies of 2. Then plt.ylabel I have given multiplies of 3, right? And then plt.show. So this is how we can plot a normal line plotting. You can see here you get the title and the label for x-axis, right? And for y-axis, and this is for x-axis. This is multiples of 2, this is multiples of 3, and you have this whole total graph, right? So this is how you can plot the basic plots. Now I am going to import Numpy because I am going to use few mathematical idea and mathematical concepts in order to make the plot. So I have written Numpy. So again, a question for you. What is the full form of Numpy? Please do let me know in the comment section. And if you like the video, do not forget to like it. Do not forget to subscribe. Great learning, right? Now I have written x is equals to np dot line space. Then you have -1, 1, 50. Right? What line space does? It will give you total 50 numbers. The range of the number will be from -1 to 1. Within that, it will give you total 50 numbers. Right? It's a random number they will give you. Right? The -1, 1 and 50. Now, what we can do, we have written y1 equals to x to the power 4. To write to the power 4, we write into, right? X to the power 4 plus 1. Then y2 equals to 4 to the power x plus 1. Now, if I just print y1, then you can see this is y1 and then you can see this is y2. Now, if I just want to plot it, the normal plotting, how we can do that? I have written a figure. So this figure will be your figure size. Alright, then I have written plt equals to plt.plot x comma y2. Then p2 equals to plt.plot x comma y1. Right, then I have mentioned the color equals to green for this y1. Line width and line style, if you want, you can give. So yeah, this is how you can do this particular, like, x-axis is same, but in the case of y-axis, we have used y1 once, y have used y2 once. For y2, it's a blue. For y1, it's green. And the line style is changed. Can you see the lines? The way of line came, it's changed. And this is how you can give different type of, visualization to change your, to give some different kind of look for your data visualization to make it understandable more, right? So if you look at this particular plot, you can directly say y1 and y2 is different, but x is same for both of them, right? So line charts are used to compare the relationship between two continuous numeric variables. They are usually used to assess trends over a time and period, like stock prices. Right, then we have again two particular lists where x consists of 11, 22, 33, 44 and 55. This is nothing but multiplies of 11. Then we have 9, 18, 27, 36, 45, again multiplies of 9. Now, if I just want to put scatter plot, you have to write plt dot scatter, right? It's that easy to work with. So you have written plt dot scatter x comma y. Now, if you just write plt.x label and plt.y label and the multiples of 11 and multiples of 9, then plt.show. Can you see what you have? Yes, you have this dots you have over here. All right, and this is how you can start working with the scatter plot. You can start working with the normal plot as well, right? So yeah, this is pretty much about scatter plot. Now, why we use scatter plot? Scatter plots are used to represent the values of two different numeric variables. They are used to observe relationships between two different variables again. They can also provide insights on correlation and outliers. So you can see if you want to go for checking outliers, either you can go for scatter plot or you can go for box plot. Now, what we are going to do, we have written one particular list with apple, banana, chiku, dragon, kiwi, and one particular list we have written 23, 45, 33, 12, and 52. These are fruits name. These are count. So here you will get for X level you have given fruits, the name, Y level you have given count and count of fruits, the total, like the total title of the graphs. So you can see this is the total title you get. Apple, banana is the highest one, right? If I just go and check, yes, banana is the highest one, then chiku, then no, the kiwi is the highest one, the 52, right? So you can plot anything, whatever you want using this particular, technique. Now here we have written bar plot, right? So we have talked about plot, we have talked about scatter plot, and now we are going to talk about bar plot. Yes, this is how we can go for plotting the bar plot, right? This is nothing but the bars you have in the plot. Now, if you just write bar H, it will become horizontally. So it's up to you how you want to look your data, right? Can you see this is the bar plot? So basically, a bar chart is used to represent categorical data using rectangular boxes called bars. So you can understand what is categorical data. So if you want to represent the categorical data, then you have to go for, bar chart. The height of bar is proportional to the value it represents, right? So this is how we can understand bar plot. Now, if I go further and if we talk about few histogram. So here we have written import numpy as np, and we have written mu equals to 200. So that is nothing but mean of distribution if we talk about the formula. Then we have sigma equals to 15, x equals to mu plus sigma into np dot random, then 50,000. Right, so basically this is a particular formula, and from there we are trying to write a histogram, the histogram of the data. Can you see you got the histogram? Yes. And if you just want to ask me what I have written over here, what are the output we are going to get, you can see the total we have 50,000 data, and here you can see the after calculating with the formula. That's nothing but mu plus sigma into np dot random, right? So this is what my x stands for. So histograms are used to represent continuous data. They provide us insights on the skewness of the data and distribution of the data and outliers too. So you can use again histogram to understand your data distribution, mostly for skewness of the data and the data distribution, and you can use them for outlier as well. Now, if you are going to create a sample data set, that will be your data frame. Alright, you have given name Alisha, Chirag, Dhara, Gaurav, Nick and Anushka. For the age you have given 20, 22, 23, 27, 24 and 90. And the gender you have given female, male according to that, and scores you have given. Right, so now if I just write, I'm changing the dictionary to data frame, you have to write pt dot data frame and then d. Right, here if I just show you, print type of d. Right, and here let me print it again. So if you want to print anything in the same text box, you have to write, like more than one thing, you have to write print. So I have written print of d. It's nothing but again what? So it's again the dictionary you have, and now after you write, just remove it. Just now after you just convert the dictionary to data frame, if you just write marks pd dot data frame dot d, then the marks will consist of all the data, that will nothing but your data frame. So you can see you have name, age, gender and scores. Now I want to create a box plot. How can we do that? So creating box plots can be generated only for those columns that had numerical records. Now in this case, we generate box plot for the column age and scores. Right, what I have written plt dot box plot, and then I have written the data frame name, marks, and then only the age. So this is how you will get only one column value. Now I have written plt dot title box plot for age column. Right, let me just execute that. Can you see you got the box plot? So the above box plot shows presence of an outlier in the age column. Such outlier can occur when there is an error in recording the data. So outlier can be anomaly detection, or outlier can be the errors in your data set. So we need to find it out according to after you understood the data. Now I have written marks scores. Then I have just write bxc plt dot box plot, and this is what it's going to generate. Right, so this is how we can understand the box plot. In the next module, we are going to talk about how can you understand the outliers, how can you handle those outliers. We will talk about everything. Now we are going to generate a pie chart. How can we do that? So you have again dictionary where you have keys of dessert. There you have the values like lava cake, hot chocolate fall, lychee ice cream, vanilla ice cream, red velvet cake, and preferences 78665. Right, now you have changed them to data frame. After you change them to data frame, if you just print it, you can see this is what the preference and this is what the dessert name. Now I want to generate a pie chart. How can we do that? We have written plt.pie. Right, then your data set, then you have given the preference, label equals to you have given your dessert name. Then if you just show it, you can see this is what the whole pie you get, pie chart. So lava cake, red velvet, all of have the almost same type of preferences, right? Here and there changes. So the pie chart and donut charts are used to visualize proportional variation categories in the data set. From this chart, we can infer that the hot chocolate fudge is preferred more than any dessert. Hot chocolate fudge, can you see? This one is the most favorite one. So a donut chart is generated by adding a circle in between a pie chart. We are going to show you how this donut chart is going to make. So it's normal, like it's the way we write pi, and this is donut with a circle in between that. So you have to write plt.py, and then you have written preferences and label. Now you have just gonna put a circle, plt.circle, and the circle will be white, right? If you just write red, what will happen? Let's see. Will it get red? Yes, I get a red circle, right? So here I want to make it white. Let me write it white again. Yes, this is how we can write the that's known as the what? This is pi, not pi. This is at the donut chart, right? So I hope you guys have understood about donut chart. You guys have understood about normal plot, scatter plot, box plot, histogram, scatter plot, and also pie chart. Now we will talk about violin plots. What is violin plot? They are similar to box plot, except that they also show the probability density of the data at different values, right? So these plots includes a maker for median of the data and a box plots indicating the interquartile range as in the standard box plots. Now if you write np.random.seed and if you give 15, can you see what you will get? None. Now I am going to do few things. I am going to write np.random normal, and then the the way of creating the collection 1, 2, 3. There's nothing but creating numbers. Now you have total collection of 4. You have written data to list. Okay, you have changed them, combine this different collection into a list. Now if you write plt.figure and plt.add-axis 0011. Now creating the violin plot, not the box plot. You have written ax.violin plot and then you have put down your data. Can you see? This is how you can create the violin plots. Now there is a concept of subplot. So Matplotlib's PyPlot API has convenience function known as subplot, which act as a utility wrapper and also helps in creating common layouts of subplots, including the enclosing figure object in a single call. Now, plt.subplots, like in rows and in columns, you have two integer arguments to this function specify the number of rows and columns of the subplot group. Now, create a subplot of the 2 rows and 2 columns, display 4 different plots in each subplot. Now, if you write plt.subplot 2, 2, so you will have total 4 place. Can you see? Yes, 2 cross 2 matrix, if you can think about, then you have 4 place. So you have written 0, 0, 0, 0, right? 0, 0, 0, 1, 1, 0, 1, 1, right? This is how this subplot concept works. So if you have any doubt, again, please do let me know in the comment section. I will happily help you to solve your doubts, right? So I have written x comma x into x. Then I have written square, that is nothing but square, x to the power 2. Then we have written square root, then we have written exponential. So now if I just execute that, you can see this is the square root, this is exponential, and this is log, right? So this is how we can do the subplotting. Now we will talk about few of that. I know these are the advanced part we are talking about, because as I have said, we are going to talk about the basic of plots we have talked about already, and then also we are talking about the advanced part of it. So let's see how it's gonna work, right? We have subplot to grid. A function gives more flexibility in creating an access object as a specific location of the grid. It also allows the access object to be spanned across multiple rows or column. So plt.subplot to grid, you have shape, location, row span, and column span. Now if you write plt.subplot to grid 3, 3, 0, 0, call span equals to 0, right? So basically 3 cos 3 grid of the figure object is filled with the access objects of verifying sizes in row and column spans, each showing a different plot. Can you see? Yes, this is what a subplot 2 grid stands for, right? So if you do the same thing, the subplot 2 grid with the dataset we have done for exponential, square, and log. Can you see? These are the thing you can do that. The changes of the figure is there, right? Now, if we talk about matplotlib, then we will done with the matplotlib. And if you have any doubt again, please do let us know in the comment section. I would love to help you to solve your doubts. So matplotlib grids as basically again the subplot concepts. Then you are going to write np.arrange to get few points. Then you have written dot plot and dot grid equals to true. So this is nothing but you will get few grid. Here you don't have any grid. Here you will have this box plots grid, right? So yes, this is how you can write grid in Matplotlib. So what are the things we have talked about for Matplotlib tool so far? We have talked about what is Matplotlib, why do we need Matplotlib, what is data visualization, how it's going to help us to make our life easy. Then we have talked about plot function, histograms, scatter plot. Then we have talked about grid function, subplot, and then how can you do the 2D graph, right? How can you find it out, box plot and outliers, right? We have talked about all these things. I hope you do not have any doubt regarding Matplotlib. If you do have any doubt, please do let us know. And if you like the video, do not forget to like it and do not forget to subscribe. Great learning. Now, as we have talked about Matplotlib, we have talked about what are the bar plots, what are the plots rather we can do implementing using Matplotlib. Now we move forwards to Seaborn. So what is Seaborn? Again, it's a library, data visualization library from Python. So Seaborn is a data visualization library in Python based on Matplotlib. So you can understand the base for Seaborn is Matplotlib. It provides high-level interface statistical plots. Alright, minor data points can be visualized using Seaborn. Histograms, scatter plot, correlation, and bar graph. So these are the way of plotting you can do. Now, if I just go and talk about like basic demo on Seaborn and also the advanced demo on Seaborn. So let's go back to the particular, the code file we are working on. Now we are going to work with Seaborn. Right, so we have done till this part, that grid part. Now we will talk about Seaborn. So again, what is Seaborn? We have talked about. But what we didn't talk about, that what's the difference between Matplotlib and Seaborn. So Matplotlib is used for basic plotting. Suppose you have a very basic data, you have to plot it, you can go for Matplotlib. But Seaborn specializes in statistical plotting. But while it's come to a huge number of data and you have to look into the statistical plotting, you have to go for Seaborn. Matplotlib is integrated with Numpy and Pandas. The PyPlot module is based on MATLAB commands. Seaborn is more integrated with Pandas data frame. It is an extension of Matplotlib library and it is used to plot more visually interesting statistical graphs. Right, so you can totally understand the difference between Matplotlib and Seaborn. Right, so Seaborn is more advanced, you can say, in the short, in a one line description, you can say while you have a really long data or huge data, you have to really focus on the statistical part and statistical plotting. That time your choice should be Seaborn. Now note, in most practical cases, Seaborn and Matplotlib are used together to generate visually impressive plots. Right? How can you import Seaborn? You just need to write import Seaborn as SNS. What is SNS? SNS is like basically a alias to Seaborn. I don't want to write Seaborn for so many times. I give an alias, nothing but the a short name to my library. Right? Now you have to load the data set. So in Seaborn, you have an option for, there are lots of preloaded libraries out there. Here you have a flight data set. How can you call those data set? You have to write sns.load dataset, then you have to write flights, right? Then in the data variable, you will have all the data. Now, if you print data, you will get what is loaded from Seaborn. So yeah, you can see you have year, month and passenger for the flight data set. Now, if I just go a little more further, we are going to use dot head function. Already you know why do we need to use dot head. Dot head is used for basically to get first five rows from your data set. Let me do that. Now you are going to say data dot tail. Right, what is data.tail? You will get the last 5 rows from your data set. Now, if you want to see the total columns from your data, how can you do that? You can write data.columns. Right, now if you need to write data.shape, then what you have to write? You have, like, if you need to check the shape of your data, you have to write data.shape, that 144 rows you have and 3 columns you have. Now, if you just put data.describe, data.describe is basically nothing but describing your data. What is the standard deviation for your data set? What is the count? What is the mean value? What is the IQR? That is nothing but interquartile range. We will talk about all the things in the next part, in the module 4 itself, right? And exploratory data analysis, that time you will more understand these parts, right? Now what I'm going to talk about, I am going to talk about color palette. What is color palette? There is a concept in color palette in Seaborn. So color palette, color underscore palette type. So it's a qualitative, sequential and diverging. We have another function Seaborn.palplot, which deals with color palettes. This function plots the color palette as horizontal array .seaborn.palplot. Now, qualitative color palettes, qualitative or categorical palettes are best suitable for to plot the categorical data. Now, how can we do that? I will show you the color palette concepts. This is really interesting when it comes to Seaborn, right? So from Matplotlib, import pyplot as PLT. You can understand we are going to import Matplotlib as well. Now we have written import Seaborn as SNS. Now for the new palette, I have written SNS dot color underscore palette. I have called the function from Seaborn library, and then I have written SNS dot palplot, then new plot. Now from Matplotlib, I have written plt.show. So it's gonna show you the color palette you are going to get. Can you see? This is the color palette. Every time you are going to put, yes, can you see? This is what the color palette. Right. So parameters are not passed in color palette right now. By default, we are seeing 6 colors. You can also see the desired number of colors by, just a second, by passing a value to in colors parameter. Here, plot is used to plot the array of color horizontally. Now, if I write 3, okay, I get an error. Why I get an error? Because you cannot put 3 like this, right? I will show you how can you change the color numbers, what are the more colors you want and how to do that, right? To do that, you have to keep tuned to see how to do that. Now we will talk about sequential color palette. Sequential plots are suitable for express distribution of data ranging from relative lower values to higher values with a range, right? Appending an additional characters to the color passed to the color parameters will plot the sequential plot. Now, if I just do this application, how to do that? Now I am going to put the sequential palette. I will go do for few other colors as well. Now I have written new underscore palette, the variable name. Then I have called sns dot color underscore palette, and then I have put down the name of the color I want to go for sequential. That's nothing but greens. Now I have written sns dot palplot new to underscore palette, and then I said please show it. If I just do that, let's see what we'll get. Yes, this is the like lighter shade to darker shade. You have the sequential plots. Now, if I just write, okay, I am getting an error. Why? Let's see. If I put red, red is not a color palette. Okay. So instead of writing blues, what you can write? You can write light, then blue. As we were getting error for red and yellow. If you want to give some color code, you can do that. Now I will show you the official page for Seaborn as well while it's come to color palette. Right? So I have written light and then like the colon and then B. So basically it's the light blue palette I get. So the lighter shade to darker shade for blue. Now there is a call for diverging color palette. Before that, I just want to show you in the documentation. This is the Seaborn documentation we have for for color palette. So here you can see these are the choosing color palette Seaborn, right? These are their official website. So now if I just write choosing color palettes, you can see these are the color palettes. We have components of color. Because of the way our eyes work, a particular color can be defined using 3 components. We usually program colors in a computer by specifying their RGB values. So this is the concepts behind it when we give colors for our graph. That's one of the most important part while you are going to give the color for your data. Which set of intensity of the red, green and blue channels in a display. But for analyzing the perceptual attributes of a color, it's better to think in terms of hue, saturation and luminance channel. Now, hue is a component that distinguishes different colors. In a non-technical sense, it's property of color that leads to first ordered names like red and blue. This is the saturations, like you can see these are the saturation colors. These are the lightness corresponding to how much light is emitted. So these are the thing, a very thing you have to think while you are going to do this color choosing for your data. That you can see vary luminance to present numbers, right? I'm just going to give you the idea. So after that, if you want to learn more, you can easily refer to this official documentation for C1 color palette. Now we have calling color palette with no arguments will return the current default color palette that we have seen. That Matplotlib will use if colors not otherwise specified. This default palette can be set with the corresponding set underscore palette function which calls color palette internally and accept the same arguments, right? So you can see this is the qualitative palette, sequential palette and diverging palette. While we are going to talk about qualitative palettes, we have given color underscore palette, right? Now this color have the same ordering as the default Matplotlib color tab 10, but they are a bit less intense. Can you see? If you write tab 10, they are really little bright. So these are the things you can actually, if you want to know more, you can do that. So Seaborn in fact has 6 variation of Matplotlib's palette, right? What are that? You have deep, muted. Can you see the color? Yeah, you have deep, muted, pastel, bright, dark and colorblind. If you are making your chart for like someone has already has a colorblind problem, you can go for colorblind colors, which is not a problem for the colorblind, right? So these are the things you have to keep in your mind while you are going to do the data visualization, right? Now you can see the many people use fine moderate hues of default deep. Now you can see using circular color system, if you write SNS.color palette HLS 8, because of the way of human visual system works, color that have the same luminance and saturation in terms of their RGB values won't necessarily look equally intense to remedy this, right? So these are the most of the things. You don't need to go for all of this, but just for your heads up, I have shown you this particular documentation. And another source of visually pleasing categorical palettes from the color viewer tools is basically SNS.color palette set 2. right? These are the actually eye soothing color. So be aware that the qualitative color brewer palette have different lengths, and the default behavior of color palette is to give you the full list. Can you see? These are the thing. Then you have sequential color palettes we have talked about. Can you see? Like perceptually uniform palettes, because they are intend to represent numeric values. The best sequential palette will be perceptually uniform, right? If you write rocket, let me do this, you will get this. Let me copy this and here, okay, I want to show you how it's gonna work as well. If you just write sns.colorPalette rocket, okay, I just need to call this as well. Can you see what it's happening? It's actually going to call this, but it's not gonna be like show it, right? How to do that? Or maybe you can take this off here and you can just put it here. Let's see, it's gonna work. No, it's gonna give us the error. But why it's going to give us the error? Let's see. If I just write this and if I write a is equals to, let's see, it's gonna work or not, or it's gonna give me, okay, list coded color map. Why it's gonna give me this problem? I just don't want to map it. Yes, I don't want to map it. That's why it was giving me error. Now, if I just write color palette rocket in default, you will get sns.palplot.a and plt.show. You will get this particular palette. Right now, if you want to go for macro, because the extreme values of these color maps approach wide, they are not well suited for coloring elements such as line or points. It will be difficult to discriminate important values against a white or gray background. To flare and crisp, color maps are better choice for such plots. So again, it's up to your color choosing, how you can see the data, how you can feel like, talking about the data. So yeah, this was pretty much about it. Now, if I talk about the diverging color palette, so diverging palette use two different colors. Each color represents variation in the value ranging from a common point in either direction, or assume plotting the data ranging from -1 to 1. The values from -1 to 0 takes one color and 0 to +1 takes another color. By default, the values are centered from 0. You can control it with parameters centered by passing a value. Example, now if I write bsns.colorPalette brbg, 7, you will get total 7 value. Now, if you just plot it, you can see this is the diverging color, right? Just to give you a heads up on the color palette, thought of showing you that. Now, what we are going to do, we are going to, as we have already loaded our data set, that data.head. Now, this was our data set. Now, I want to go for line plot. How can I do that? I am going to write Seaborn, that the small name or the nickname I have given, that is SNS dot, you have called the function called line plot. Then you have given the data. Then you have written x equals to year and y equals to passenger, right? So this is what you get. The data you get, the can you see the with 1950 you have passenger 150. There's a direct increment in the passenger with days. From the above line chart, we can infer that the number of passengers choosing to travel by flight is increasing over time. That's really true. Now, if I go for multiple lines in a single plot, how can I do that? I am going to write sns.line plot. Again, we are going to give data x equals to year, y equals to passenger. But here, hue equals to month. It will give you month-wise data. Right? So you can understand why do we use hue and how can we make the multiple lines in a single plot. From the above line chart, we can infer that more number of people travel through flight in the months of June and July. Right? Now, if I go a little more further, you can see we are going to write from Numpy import mean. I hope you guys know why to use mean and why to use median. Now we are going to plot the bar plot the way we have done in Matplotlib. So we have written sns.barplot, then data x equals to month, y equals to passenger, and I have given estimator equals to median this time. So if I just plot it, you can see this is nothing but my box plot. Now the above bar plot is indicates of the average number of people that travel by flight on a different month of a year. The black lines are error bars. Can you see? This is the error bars. Now it's like I can write it as mean as well. Right. For if you want to go for median, you can go for median. If you want to go for mean, you can go for doing that as well. Now we are going to create a dictionary. What dictionary we are going to create? For that, we are going to import pandas as PD. Then we have written D, the dictionary, and the key will be name. Then the list of name again we have Alisha, Chirag, Dhara, Gaurav, Meek and Anushka. Then you have age and gender. Alright, now if I just print type of D and D values will return you all the value you have, and the type of D will be dictionary. Now if I just write keys, it will give you all the keys from the dictionary, name, age, gender, score. Right, now what I'm going to do, I'm going to change it to data frame, pd.dataframe D. Now if I just print marks, you will get all the marks. And if you want to check type of marks, it will nothing but pandas data frame. Now if you want to see the first 5 rows of your data frame, how can you do that? You have to write marks.head. It will return you the first 5 rows of your data frame. Now if I just write 6, it will give me 6. So in the parentheses, you can change the number. In default, it's gonna give you 5 results, like 5 rows as a first 5 rows as a result. Now we are going to do a bar plot. How can we do that? Here we are going to write data equals to marks, x is equals to age and y equals to gender. Here we have written estimator equals to median, right? And we have called sns.barplot. Can you see? You get the gender and you get the age. Right, and now if you write sns.barplot age and gender, can you see? Here our estimator is mean, here our estimator is median. Right, this is the way you can change it and check your data. Now the difference between the above two bar plots is that this is the bar plots. In the first bar plot we have used median as an estimator, and median is the central tendency value that is least affected by outliers. Always remember, median is always least affected by outliers. Suppose you have lots of null value and you want to remove them or you want to replace them. We will not suggest you to remove your data, as this can be the cause of data loss. Instead of that, what we can do, we can replace those field with median value, as it's the least affected by outliers. Right? Please do let me know what you think about the same condition. And if you have any doubt again, please do let me know in the comment section. I will happily help you to solve your doubts. And if you like the video, please do like it and also subscribe. Great learning. Now here it's the data. Right? You can see. Now, if you write data of passenger, you will get all the passenger, right? And if you write A is equals to data passenger sns.displot, right? So you will get this particular plot, right? So this is the displot you can write in SNS, right? And these plots are used to compare the density distribution of the data. It's kind of a histogram. From a single variable, they can give insights of the skewness. Skewness refers to the distortion as a symmetry in a symmetrical bell curve or normal distribution in a set of data. If the curve is shifted to the left or to the right, it is said to be skewed of the data, and outliers too. If the plot shows presence of tails, then we can infer that extreme values are present in the data. Alright, now we are going to load the data set. That's nothing but ID's data set. So how many of you actually worked with Irish dataset? Please do let me know in the comment section. How can we do that? As we have done for flights, the same way we are going to call function called sns.loop dataset, and the dataset name is Irish. Then if I just write d2.head, I will get the data. Right after I do that, I have written the columns. What are the columns I have in the data set? I have sepal length, sepal width, petal length, and petal width and species. Now we have d2.shape. d2.shape will have what is the shape of your data. 150 rows, 5 columns. Now if you want to do the joint plot, yes, you can do that. Here you can write sns.joint plot, then data x equals to sepal length, y equals to petal length. So a joint plot displays the relationship between two variables, bivariate analysis along with the bivariate profile. It also provides a univariate analysis of each of the two variables as well. Can you see? This is what joint plot stands for. It's kind of a scatter plot also, you can say. Now what we can see, the above joint plot shows us the distribution of three classes in the data set. From the above chart, we can infer that versicolor and virginica are slightly similar to each other, and the cetosars are slightly smaller species of flower. Right now, if I just want to go for box plot, right, what you need to do, you have to call sns.boxplot. Can you see? This is how the box plot is gonna look for this. Right now, if you want to again check the columns, you can write d2.columns. Here you have a box plot for sepal length. Here you have few outliers. If you can see, these dots are nothing but the outliers. For know more about outliers, you have to keep tuned in the next part. Anyway, we are going to show how can you handle these outliers to understand how you have outliers in the columns. Now we have seen sns.boxplot. Yeah, you can see for there is no outlier we have. Now we have it for petal length. Again, we do not have any outlier. Petal width doesn't have any outlier. The above box plot indicates presence of outlier in the variable sepal width. Another useful exploratory tool that Seaborn offers is a pair plot. Pair plots can convey important information such as presence of clusters in the dataset, relationship between the variables in the dataset, and some extent the predictive power of a certain variable. Right? How to do that? So it's represent the pairwise relation across the entire data frame and supports an additional argument called hue for categorical separation. What it does basically is create a joint plot between every possible numerical column and take a while if the data frame is really huge. You can see for this, it's not gonna take a lot of time. So yeah, how to do that? You have to call sns.pairplot. You have given the data. Then you can see hue equals to species, right? According to the species you want to check. So this is sepal length, sepal width, petal length, petal width, and this is the same for all of them. Right, and this is for versicolor, setosa, and virginica. The hue set up the categorical separation between the entries in the dataset, and palette is used for designing the plots. Right, the following inference can be made from the pair plot generated above. Variable sepal width is poor predictor of species, since the distribution of the three classes are not significantly different from each other. The data might have two hidden clusters since it has two prominent peaks. And for hexagon plots, hexagonal binding is used in bivariate data analysis when the data is sparse in density. That is when the data is very scattered and difficult to analyze through scatter plots. An additional parameter called kind and value hex plots the hexbeam plot. Now I have written df equals to sns.load dataset Irish. Then I have written sns.joinplot x equals to petal length, y equals to petal width, data equals to df, and kind equals to hex. Now if I just show is plt.show It will take a little time. Yes, this is the hexagon, right? These are the hexagon. That's why it's known as hexabean plot. Now we have strip plot, we have violin plots. So these are the little advanced plot we have because again we said we will do the demo, the basic demo on Seaborn and also the advanced part, like the part of Seaborn and Matplotlib. So strip plot is used when one of the variable under study is categorical. It represents the data in sorted order along any one of the axes. Right? SNS dot strip plot, x equals to species, y equals to petal length. Right? Data equals to df, and this is how you can show this. Can you see? For versicolor, virginica, and setosa. Right? This is what strip plot stands for. The distribution of points can be seen easily. Now we have talked about violin plot in the Matplotlib as well. Here we are going to show you the violin plots are a combination of box plot with kernel density estimates, and these plots are easier to analyze and understand the distribution of the data. Violin plots are used to represent comparison of variable distribution or sample distribution across different categories. For example, temperature distribution compared between day and night, or distribution of car prices compared across different car makers. Now I have written df equals to sns.load dataset. Then you have the dataset called tips. Right? Now you have d8.head. Now according to that, how much tip you actually give according to your bill. Suppose your total bill is 16.99, tip is given 1.01. The gender of that particular person is female, smoker, no, day, sun, time, dinner, size 2. Right? This is what your data sets looks like. Now if you want to check the columns, you have to write df.columns. Right? To check the shape of your data, you have to write df.shape. Now sns.violin plot, okay, I get an error. Why I was getting the error? Because I forgot to execute this part. What is it taking? It was taking the sepal length part. So let me again load the data set. Now the columns is there, for the shape is there. For sns.violin plot, if you write day and total bill, can you see for each and every day you got is Thursday, Friday, Saturday and Sunday. The above plot shows the distribution of total bill on 4 days of the week. But in addition to that, if we want to see how behaves with respect to sex. So in this case, what we can do, again, let me do that. Yes, it's about male and female. You are just dividing the day with male and female based on the tips and based on the total bill and the day. Right? Yes, this is how we can do this particular types of plots in the Seaborn and Matplotlib. Right? So yeah, we have talked about Matplotlib, we have talked about few different libraries, we have talked about like the data visualization and what are the things you need to know, what are the libraries is needed like Matplotlib and Seaborn, what's the difference between both of them, why we need both of them as well, the difference of them, and what are the basic implementations and the advanced implementation we can do using Matplotlib and Seaborn. In this particular part, we are going to talk about anomaly or outlier detection. What is anomaly? What is actually mean by outlier detection? We will talk about everything. So let's see and let's go to objectives and let's see what are the things we are going to talk about in this particular part. So first we will start with what is statistics. Right, so this anomaly detection or outlier detection is nothing but the basic part of statistics you need to know. Then we will talk about what is population. Then from there we will have a look at what is parameter and sample. These are nothing but basics of statistics. Then I know you all have idea about what is mean, median and mode. Again, for your recap, we will talk about that. Then we will see what is normal distribution. Then types of analysis and statistics we have. Then we will start with what is an outlier, what is interquartile range in short, which is known as IQR. Then we will see what are the interquartile range like upper range or lower limits, what it is. We will talk about in depth for interquartile range. Then we will do a demo how to handle outlier in the data set, right? So let's start with our what is statistics. So first question is what is statistics? So what do you think? What is statistics? Right? Let me know in the comment box before we talk about what is statistics. And if you like the video, do not forget to like it. Do not forget to subscribe. Great learning. So statistics is a part of integrated applied mathematics which deals with data, right? It helps to collect data and analyze them properly. Okay, so if we know maths, it's a integrated applied mathematics, right? So basically, it's help us to understand our data in a more better way. It gives us the idea that okay, maybe your data is coming from this. It's like, these are the insights you can actually have a look at. That's why we go for statistics, right? In a very basic part, as a data scientist, you need to have an idea about what is stats, right? How can you understand your data using statistics concepts? So it helps to collect data and analyze them properly. From there, with the help of statistics, we can read the data and organize them in order to get the hidden information from them. The main reason behind it to use statistics, it gives us really some, we cannot even think of by looking at the data, but actually the data has those insights or the information. So they are nothing but our hidden information. So this is what statistics stands for, and that's why we try to use all the concepts from stats. In data science domain, statistics concepts are used to process the complex data to get the insights from them using mathematical computations, right? So it's basically, again, it helps you to process your, it's a complex data, and it give you a really good insights from them just by using stats. So let's start with what are the terms we have in statistics. So this is the slides we talk about. You can see stats, what is stats, why do we need it, and why we say while it comes to data science or artificial intelligence, you need to know the basics of stats, right? I think you got all the idea about why do we need stats. So please let me know in the comment section if you feel like you are not yet convinced that why do we need stats, right? Then we will talk about what is population. The terms population in statistics is used to refer the total set of observation. Okay, let me tell you what actually I mean by total set of observation. So total set of observation is nothing but when you have a data set, right? Or you can think about the example of the whole population of the world. Yes, that's what population stands for. The whole population, the whole total number of human being we have in the world, right? So suppose again we want to study a diabetes data set to understand the symptoms and the other factors in the whole data set is referred to as population, right? Now, if I just go and talk about what is parameter? So parameters are referred to as characteristics which describe the population, right? It's help us to describe our data set, right? So this is what stands for parameter. Parameters are like average or percentage which help you to describe the entire population. Suppose you have a diabetes data set and you want to understand what is the average age of being diabetic. I know, how can you do the average? So this average is going to represent your whole data set, right? So you can understand what is parameter. Mean and standard deviation are two common parameters of population, right? Now, example, I have given you already average age for being diabetic is the parameter for whole diabetic dataset population. Now we will jump into what is sample. So if you have a lot, we have the whole population in the world. Now if you just want to talk about West Bengal, or if you just want to talk about India, right? Then the India will be your sample from the whole population, from whole world population. This is what sample stands for. Sample is basically a small part or the portion of the large population. Now, suppose From the whole diabetes dataset, you picked 100 rows of information to do the analysis. That 100 rows of information will be referred as sample, right? Now let's move further. We will talk about what is mean. The term mean is referred to as an average value of the whole population that we already know. Now if we talk about median, so median is the middle value of the data when your data is sorted in the manner. Yes, to get the median value, you have to make sure that your data is sorted. Now we will talk about mode. Mode stands for the most occurring element in the data set. So mean, median, mode is the very basic things, right? We start like learning those things when we are kid. So still, if you have any doubt regarding what we have talked about, why do we need statistics, what is population, what is sample, then we talked about what is mean, median and mode. Now we will talk about what is normal distribution. The normal distribution is a probability function which describes you how the values of the variable are distributed. Now we will say why do we need it? This basically give you an idea about your data points. Who are your data points? Suppose you are talking about diabetes dataset. All the rows you have about the description or the information about the person, these are your data points. Now this normal distribution is basically comes from probability function, and it helps us to describe how our values of a variable are distributed properly to give us the idea what is the range of our data set, right? This is what normal distribution stands for. Now, properties of normal distribution, the mean, median and mode all are equal, right? The curve is symmetric at the center. Then this is also referred as Gaussian or Gauss distribution, right? The parameters of normal distribution, mean, standard deviation, like we have the parameters of normal distribution, that is mean and standard deviation, right? Now we will talk about the types of analysis in statistics. Basically we have two types of analysis. One is descriptive statistics and second one is inferential statistics. What is descriptive statistics? It helps to describe the data in the mathematical or a graphical way. Now, when it comes to inferential statistics speaks the data into samples and applies probability to arrive the conclusion, right? This is what descriptive statistics and inferential statistics stands for, right? I hope you understand what is actually mean by descriptive statistics and inferential statistics. So as a name suggests, again as a recap, describe the data, you need to have descriptive statistics. Now if you want to use, split to your data to samples, I hope you understand what is sample and how can you apply probability to arrive the conclusion. We use inferential statistics, right? Now let's move further. We will talk about what is an outlier. Outlier in the data set are referred to as the usual values which can distort and violate statistical analysis. Now you will ask me what is outlier? Maybe in the class there will be always an outlier. What is an outlier? Suppose we have students who are mediocre or we have student who is really good, like the first boy or the first girl, right? So they are nothing but the outlier, right? So this is what outlier stands for. Now, outlier are basically experimental errors in the data set, or like in the case of, data, it's an experimental error. But in the case of what example I get, it's not an error, right? Now, some outliers are good for dataset to detect anomaly, like detecting fraud transaction. Now you will ask me, how can we detect a fraud transaction? Let me tell you. So basically detecting fraud transaction is like, suppose you have a dataset where everyone has does the credit card fraud analysis, or everyone has the idea, like, description or the information about their credit card. Suddenly you see there is a sudden spike in the transaction when a person is used to buy something between 10,000 to 20,000. He's going to buy something in 10 lakhs. It's nothing but the outlier, and there is a possibility it's a fraud transaction. I cannot say it's not a fraud transaction. It's So it can be a genuine transaction, but yes, but there is a possibility as the outlier is there, we would need to give a good look on that, what is happening. So this is how we actually use our outliers. Now it affects the mean and the standard deviation of the data, that's obvious, and the data and the most of the machine learning techniques does not perform good with outliers. If you see outliers is not needed, you can just cut it off, because it's gonna affect your model and it's gonna affect your data mean, standard deviation, everything, right? Now we will talk about what is interquartile range. Interquartile range divide the dataset into quartiles to measure the variability and the spread of the dataset, right? So what is that? It's basically help you to divide your dataset with 4 quartiles to measure that how your data is spread, what is the variability, what is your data points, so give you the every possible way information about your data. Splits the dataset into 4 equal parts but in sorted manner, right? So Q1, Q2, Q3, Q4, right? We will have 4 parts. So Q1, Q2, Q3 are called first, second and third quartile. Now, what is Q1? Q1 is the 25th percentile of the dataset. What is Q2? 50th percentile of the dataset, and Q3 is 75th percentile of the dataset. This is what IQR stands for. Now, what is the formula for IQR? That's nothing but third quartile minus first quartile. Now, we will talk about what are upper and lower limits in interquartile range. Yes, you have to have an upper limit and lower limit. Now, let's have a look at what is upper limit and lower limit. Now, we've had upper limit and lower limits in the interquartile are basically the ranges where your data points are lying. Suppose it starts from 0 to 15. So upper limit is 15 and lower limit is 10. Sorry, lower limit is 0, right? So formula to find the lower limit is basically Q1 minus 1.5 into IQR. Now, formula to find the upper limit will be Q3 plus 1.5 into IQR, right? Now we will see how can we handle outlier in the data set and what are the concepts we have learned about what is statistics, what is sample, what is population, what is mean median mode, what is IQR. We will do everything, right? And how can you find outlier as well, right? So let's start with the data set demo, and do let me know if you have any doubt in the comment section. In this case, we are going to use a dataset from Kaggle, which is known as PIMA Indian Diabetes Dataset, right? So this is your dataset link. If you just click over here, you will redirect to the dataset, right? Let me do that. Okay, so again, it's a free dataset from Kaggle where you have the information about diabetes patient. Can you see? This is how you will redirect and you will directly download the dataset from here. It's from Kaggle, right? Can you see? This is what the dataset is. Right. Now we will talk about what is this dataset all about, what are the things we have. The PIMA Indian Diabetes Database is from National Institute of Diabetes and Digestive and Kidney Disease. It consists of 9 variables. We will talk about that. Out of which outcome is the target variable. The objective of this dataset is to aid in pending if a person is likely to have diabetes or not. What are the different types of diabetes we have? The most common type of diabetes are type 1, type 2 and gestational diabetes, right? Now, what is type 1 diabetes? Type 1 diabetes, if you have type 1 diabetes, your body does not make insulin. So we all know about diabetes that it does stop making insulin. Your immune system attacks and destroys the cell in your pancreas that make insulin. Now, type 1 diabetes is usually diagnosed in children and young adults, although it can appear at any age. People with type 1 diabetes need to take insulin every day to stay alive, right? Now it comes to type 2 diabetes. If you have a type 2 diabetes, your body does not make or use insulin well. You can develop type 2 diabetes at any age, even during childhood. However, this type of diabetes occurs most often in middle age or older people. Type 2 is the most common type of diabetes. Now, if we talk about gestational diabetes develops in some women when they are pregnant. Most of the time, this type of diabetes goes away after baby is born. However, you have gestational diabetes, you have a greater chance of developing type 2 diabetes later in life. Sometimes diabetes diagnosed during pregnancy is actually type 2 diabetes. Other types of diabetes less commonly include like monogenic diabetes, or which is an inherited from diabetes, and slightly fibrosis related diabetes. So these are the type of diabetes. Maybe you think why I'm talking about diabetes, just to give you a heads up if you do not know what is diabetes, right? So we have talked about different type of diabetes. Now we will see what is the data description we have in our data set. What are the 9 variable we have? We have pregnancy, the number of time the patient got pregnant. Then we have glucose, that plasma glucose concentration. Then we have the column called blood pressure. It's like, we all know that is BP, right? Then we have skin thickness, that tricep skin folds thickness, right? Then we have insulin, the 2-hour serum insulin. Now we have BMI, that is body in mass index, weight in per kg. A weight in kg per height in like to the power 2. This is how we calculate BMI. Now we talk about diabetes predictory function, which is nothing but again diabetes predictory function. Then we have age and outcome, that will be your class variable, 0 or 1, right? So these are the total column we have. Now you will say, what is this outcome stands for? This outcome is basically if your outcome is 0, this person is diabetic, not diabetic. If the person is diabetic, then the class variable will be 1, right? So this is what the, different type of columns we have. Now, if we go further and if we have a look at what are the, library we need to import, then we have talked about Pandas, Numpy, Matplotlib, and Seaborn. We are going to import this 4 library, right? We have written import Pandas as PD, import Numpy as NP, and if you know why we use as, please do let me know in the comment section. I would love to hear from you, as we have talked about this particular as so many times. So what actually I mean by import Pandas and then as PD, right? Please do let me know. Now, like after you write this comment, then again start the video and let's see what you have written, it's right or wrong. And guys, if you like the video, do not forget to like it. Do not forget to subscribe Great Learning, so you will get updated with the all new content we are going to come up with, right? And please do let me know in the comment section, do you like the video? If you like the video, what are the things you want to learn from us as well, right? So now we will do what? We will load the data set. How we do the loading the data set? We can write data equals to pd.read_csv. What is CSV file? Comma separated value, right? Yes, this is what CSV stands for. And then we have written diabetes.csv, right? So you have your data, and if you just want to read them using Pandas, you just need to use .read_csv. So my data is a comma separated value, right? So CSV stands for comma separated value. Now, if you ask me how can I upload data in Google Colab, I have talked about so many times, but for your reference again, just click on this particular box. Here you will get an option for upload to session storage. It will redirect to your local system and you just need to upload the dataset from there. So this is how I have done. Now here pd.read_csv, you have to give the path. How can I get the path of the dataset? Now, if I just click over here, you get an option for copy path. Let me just copy the path. Now, just copy paste it here, right? This is how this copy path option works. And this is how you can read the dataset using pd.read.csv, and you can upload dataset in Google Colab. Right? I hope you do not have any doubt till so far what we have talked about. Give me a quick confirmation on that as well. Right? Now we will see the basic part of Pandas, and then we will jump into all the all the techniques we have learned, and we will see how can we implement them using Python. Now we have written data.head. Why do we write data.head? I have talked about this again like for so many time, while we were talking about PD like pandas, right? Okay, I have asked you guys question that why do we use as PD? As PD is nothing but giving the alias to your library, right? So if I don't want to use like pandas for all the time, I can easily call them as PD, right? It's a nickname to your library, you can see in a layman term. Now if we just write data.head, it will return you the first 5 rows of your data. Let me just execute that. Right, so in default it will return you the first 5 rows, right? Now if you say no, I want to see the first 10 rows, how can you do that? Just need to do data.head, then you can specify the number, the first 10 rows or the first 15 rows you want to see. You will get total that many of 0 to 14, that many of data set, that many of rows, right? So this is why we use .head. Now comes data.tail. Why do we need to use data.tail? Data.tail will give you the last 5 rows of your data set. I hope you get the difference between head and tail, right? So then, as the name suggests, basically tail will give you the first 5 rows of your data. Now let me just execute that. Yes, this is what you get. The last you have 768 total columns you have, total rows you have. Now I want to see all the 9 columns we have talked about, only the columns. How to do that? You have to write you have to write data.columns. So the columns will return you all the column you have in your data set. You have column called pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetic predictive function, age, outcome. Right? So this is what you get after you write data.columns. Now I just want to talk about what is my data shape. So total columns I said 9. How many rows we have? In order to get that, you have to write data.shape. So after you write data.shape, you will get the total shape of your data. That is 768, 9. So total rows you have 768 and columns you have 9. Alright, so we have already talked about this data.head. Now we will see how can we treat the missing value detection and treatment. In this part, we are going to do the missing value detection and treatment. So how can we do that? So in this case, how can we understand we do have missing value? The following value in the data sets are considered to be missing values. Suppose you have blank values or you have none or null, or some continuous columns might have zeros to indicate missing data. This is where we can understand this particular that it's having a missing value. Now, how can you get that? Let's start by checking the count of the records in each column of the data set. So, if the count of the record is lesser than the total number of records, then suppose 768, we can conclude that there are blank records. Right? I have written data.info. Right? Can you see what I get? The count of the records for all the columns is 768. This indicates there are no blank columns in the data set. Yes, you do not have any blank column. Now, if I just want to understand, do we have any null value? How to understand? We can use a function called isAnyFunction. This isAny function is used to understand, do you have any null value in your data set? Right? Let me just execute that. What it's going to return? It's going to return that true or false, right? If you don't have any null values, then it will give you like false. But if you do have, it will give you true, right? Suppose you have written data dot is in a dot any. For each and every column, it's going to give you, do you have any null value for this particular column? So in the case of pregnancy, you said no. It said basically no. For glucose, it said no. Blood pressure, skin thickness. For any of the column, we do not have any null value. Now, if you just want to get the summation of the null value, right? So there is an option. We have data dot is in a dot sum. So it will give you total number of value, like total number of null value you have in every column. So you can see for all the column you have 0, 0, 0. That means you do not have any null value. Since all the predicted columns are continuous in nature, there might be a chance that zeros in these columns indicates missing values. Let's say, do you have any 0? So if I just write data dot describe, what is describe function? A describe function from the, like, it's going to give you what is total count of the data, what is the mean of your data set, what is standard deviation, then what is minimum value, then your interquartile range and the maximum value. Now, if you look closely, you can see the minimum value for pregnancy is 0. That can happen. The glucose is 0. Will that possible that a person has a 0 glucose? No. A person can have 0 blood pressure. No, it's not gonna happen. Skin thickness 0. Insulin 0. BMI 0. It's not possible even. So you actually have null values, or that is nothing but representing as 0. Let's see what I have written here. From the above description of the data, we can see that columns pregnancy, glucose, blood pressure, skin thickness, insulin and BMI have minimum value of 0. It makes sense to have 0 pregnancy, but it does not make sense for other mentioned variable to minimum value of 0. So we can conclude that glucose, blood pressure, skin thickness, insulin and BMI have missing data. That zeros in the columns should have replaced with the median. We always replace with median since the median is least affected by outliers, as we have already talked about outlier. If you know what is outlier, please do let me know in the in the comment section what is outlier. And if you like the video, do not forget to like it and do not forget to subscribe. Great learning. Now, if I just do data of glucose, so basically I just want the column for glucose. I have written that data of glucose, you will get all the data from the Google, from the glucose column, right? Let me just execute that. Okay. Now, if I just write replacing the zeros with nan, we need to import one particular part from Numpy, that is known as import num. The records that have zeros in the column glucose, blood pressure, and skin thickness and insulin and BMI will be replaced with nan. To understand how many nan values we have, which are hiding behind 0. Right? That's why I have written data of glucose equals to data of glucose dot replace 0, np dot nan. So if you want to replace any value in the data set, you have to use replace function. Now I have 0. I want to replace 0 with nan, right? So this is why we use np dot nan. Now if I write data of blood pressure the same way, I have written replace 0 with np.nan, for skin thickness, for insulin, for BMI. Right? You can see this is how we can do this, is replacing 0 with np.nan. Now if I write data.head. So this data.head will give you like suppose you have 0, you can see in insulin, normally you can see for the first 3 record has nan value. For skin thickness has nan value. So basically these were replaced, like the zeros were replaced with nan. Now if I just write data.describe, you can see there is minimum value for glucose is 44, for blood pressure is 24. So we do not have any 0 values because as they are already replaced with nan. So this is how you can find it out your missing value. But finding out missing value is really problematic, and also you need to keep your mind working. As I said, working with data is easy, but understanding data is not easy. You have to first understand data. You have to make sure what are the information you are getting from data, it's worthy of getting, right? So these are the things you have to keep in mind while you are talking about the exploratory data analysis, which is nothing but again our module name is anomaly detection or outlier detection, right? So I have written data.isNull.sum. So you can see total number of null value we have, we will get the summation of that. So for the case of Google, we have 5 null value. Sorry, for the case of glucose, we have 5 null value. And the case of blood pressure, we have 35 null values. In the case of skin thickness, oh my god, for 227, and for insulin, we have 374. You can see how many mean value, like, how many missing value we had, and which was just hiding behind zeros. For BMI, we have 11. Right? As in for 2 column, glucose, blood pressure, skin thickness, insulin, and BMI have missing data. Glucose, blood pressure, and BMI have less number of missing data, while the case of skin thickness and insulin have the high or very high amount of missing data. Now, removing this missing data from the dataset will result in information loss, and it is not as advisable to remove these records, since we have only 768 records. Hence, we will input this missing value with median of their respective columns, since median is the least affected by outliers. We will replace all the non-value with median. Right? This is how we are going to handle missing values. Right? Please do let me know if you have any doubt about missing value, about outliers, about whatever we are talking about. Right? So I will happily help you and help you to solve your doubts as well. Now, if you just write data.median, this median value, or you know how median works, right? So just by calling the function median, it will give you the median for each and every column you have. So for pregnancy, median is 3, glucose is 117, for blood pressure is 72. For skin thickness, we have 29, for insulin you have 125, for BMI you have 32, and for diabetes predictive function you have 0, and for age you have 29. Right? So this is how your median function is going to work in your whole data set. Now, what we need to do? We need to import, or we need to not import, we need to fill our NaN values with data.median. How can you do that? Inputting missing values with their respective columns, median, and to fill NaN value, we need to use a function called .fillNA. So we have written data.fillNA. What you need to fill? Data.median. So your value will be data.median, and in place equals to true. Right? Let me just print data.head. So can you see your skin thickness is replaced? Your insulin that we got, that NaN value, this 125.0, 125.0, this first 3 columns are replaced with median. So you will not have any data loss. It is actually recommended not to delete the data or not to cut the data. If you have a huge data set, maybe you can go for. While you have just 768 data set, this is not recommended to remove the data with NaN value. Except like this, you can replace NaN values with median. Right? Now we are going to check if the missing value have been imputed or not. How to do that? We just need to again use data.isNull.sum. Why to use .isNull? We use .isNull and sum to check how many null value we have in our data set. Can you see? Now we just have 0 null values. Right? In the next part, we are going to talk about how can we handle outlier detection and how can we treat them. Right? I hope you have all understood about missing value. if you do not know in the normal way that you have missing value, then now you have to go deep and you have to investigate little more to understand, do you really have missing value or you don't. If you have missing value, then go and remove them if you have a big data set. If you do not have big data set, then replace them with median. And after that, you are ready to use your data set, right? So this is what missing value, treatment works for and how can you find it out. Then in the next part, we will talk about how we will find it out, outlier detection, and how can we treat them. Now, in this part, we are going to talk about outlier detection. I know you all have idea about outlier detection, right? Give me a quick confirmation in the comment box. What is outlier? What example I have given about outlier? Please do let me know in the comment section. And if you like the video, do not forget to like this video and do not forget to subscribe Great Learning. Now we will talk about outlier. Outliers are extreme values that deviate from the other observation on data. They may indicate a variability in the measurement or experimental error or novelty. Box plots are a great way of detecting outliers. We already talked about box plot, right? So yes, it will help you to find it out the outliers. Once the outlier have been detected, they can be imputed with the 5th or 95th percentile. We will talk about that, how to do that. So how can I do that using box plot? You have to write plt.figure to make your figure size. Now you will go for plt.subplot. In one plot, there will be subplot you want, right? So you have written 441. Now we are going to use Seaborn and I have given Seaborn as SNS. So SNS dot box plot and data of pregnancy. So for the pregnancy column, you just want to plot the box plot. Now in the case of glucose, you will again write plt dot subplot 442. Can you see the number changing that where you want to place this particular box plot? Now I have written is dot box plot then data of glucose. Then move further, we have plt dot subplot 443 and SNS dot box plot data of blood pressure, right? So for again we will going to write plt dot subplot 444 your data place where you want to put your box plot, and I have written data of skin thickness. The same way we have done for data insulin, we have done for BMI, diabetes palliative function, and age, right? So it's going to give us the box plot. Now, if you don't know box plot, then I should suggest please check the previous part of the video where we have talked about box plot. Now, in the case of pregnancy, can you see there is a 3 dots? So basically, it's showing there is outlier. In the case of glucose, you do not have any outlier. In the case of blood pressure, you again have outlier. In the case of skin thickness, obviously you have outlier. Age has outlier. Diabetes pedigree function has outlier. Insulin has lots of outlier, and BMI also have the outlier. Now, if I go for the observation apart from glucose, all the other attributes shows the presence of outliers. This lower level and upper level outliers will be replaced by the 5th and 95th percentiles respectively. Right? Now we have talked about IQR. What is interquartile range, guys? Let me know in the comment section. Again, for your WhatsApp, for your heads up that the interquartile range, that IQR is a measure of variability. Based on dividing a data set into quartiles, quartiles divides a rank order data set into 4 equal parts that we have talked about, which the parts are known as quartiles. So the value that divide each part are called as first, second, third quartile, and they are denoted by Q1, Q2, Q3 respectively. Now what we are going to do, we are going to, that we have talked about interquartile range. Now what we are going to do, we are going to write numpy dot clip function. So the numpy dot clip function will help you to clip our data as we have outlier, right? So what is how to use clip function? So if this clip function, you need to give the limit. The values in an array. Syntax numpy dot clip And the parameters you have, the array containing elements to clip, you want to clip. Then minimum value, if none clipping is not performed, like on lower interval age, not more than 1 of a underscore mean and a underscore max may be none. And a max is nothing but your maximum value, right? Now, if I just need to clip, what I need to write? I have written data of pregnancy. You want to work on the pregnancy column, then I have written data of pregnancies dot clip. I want to clip my data. Now, what I need to do for the lower limit, I am going to give data of pregnancy dot quartile 0.05. Then we have written that upper will be data of pregnancy quartile 0.95, as we have talked about here, right? That the values divide each and okay, that not. So yeah, this lower and upper level will be replaced by 5th and 95th percentile respectively. So your 5th quartile, like 5th percentile and 95th percentile, while it comes to upper, and then while it comes to lower, right? kaha gaya? Haan, this is lower, right? So this is how we can do that. Now let me do that. Okay, now I have written data of blood pressure and data of blood pressure dot clip. Again, you are going to clip the blood pressure column data. For skin thickness, yes, you are going to again clip skin thickness. For insulin, you will clip insulin. You will clip BMI, diabetes pregnant function, and age, right? Wherever we have seen this particular, outlier. Then what we need to do? We again need to plot our box plot to understand, do we have again any outlier in our data set? If we have, how can we, replace them again with the clip function to clip our data to remove outliers, right? So we are going to write plt.subplot the same way 441, then SNS dot box plot, and then for pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes predictive function, and age. Right? Can you see? For the case of pregnancy, again, you do not have any outlier. Glucose, blood pressure, skin thickness, okay, age, diabetes predictive function, and BMI are fine. For skin thickness also, you have a little outlier, right? So skin thickness and insulin is not worked out, right? As we can see, there are still outliers in the column called skin thickness and insulin. Let's try manipulating them with the percentile value. Now we will try to do heat and trial. Now we have written that, again, we are going to clip, and quartile will be 0.07 to 0.93. Let's see how it's going to work. And for insulin also, we have written 0.21, the lower one, and the upper one we have written 0.80. Now if I just plot both of them, okay, insulin has worked, insulin didn't work, but skin thickness has worked on. Now let's manipulate insulin little more. I have right quartile equals to 25% for the lower, and the upper will be 0.75%. Now if I just plot it, can you see your insulin is also worked and there is no outlier for your insulin. So this is how we can actually help to remove outliers from the data. The outliers of data skin thickness were treated by minor changes in the percentile, but the outer layers of insulin require a major changes in the percentile. This might result in too much data manipulation, which might again, it's not good for your model. Attribute insulin might have to be removed from the data set. It will give you good value, because as you have to manipulate your insulin for so many times. So this is what missing value and outlier analysis stands for. Now after this part, we will talk about data visualization. How can you visualize our data using Matplotlib and Seaborn? Now we are going to see how can we do the data visualization. But what are the things we have done so far? We have talked about how can you understand data using Pandas. Then we will jump into how can I see that my data is already uploaded. Then we have used pd.readcsv. Then we go for understanding missing value and basic terms to understand your data like describe, info, and all. Then we have talked about missing value. How can I find it out? Missing value. Maybe in the simple case, you will not get any missing value. You have to go and deep dive and need to see, do you really have any missing value or not? If you don't have any missing value, then it's fine. If you have missing value, you have to make sure that you are like those missing value are treated. Then we go for outlier analysis. So it's basically trying to understand, do we have any error in our data set or any anomaly? If we have outlier, we will try to replace them using interquartile range, right? Now we will do the data visualization. Now we are going to use sns.countplot. So we just try to understand what is the data set we have, where how many people are diabetic, how many people are non-diabetic. Right, in that case we are going to use outcome column. As I said, outcome is 0 means the person is not diabetic, where your outcome is 1, then it's showing that your person, like the person is actually diabetic. So you have written data sns.countplot. This sns.countplot is basically give you the total count of your data for 0 and 1, the different class we have. Now in the case of like count, you can see 0 is high, 1 is low. So 0 means the more person you have is non-diabetic and 50% of the person you have diabetic, right? So this is where the sns.countplot stands for. We have already talked about count plot, right? Why don't you guys see what are the things we can do using this particular data set where we can use count plot, right? Now we will see the observation again. From the above plot, we can infer that the majority of the data consists of non-diabetic patient. Let's try to understand the percentage distribution of diabetic versus non-diabetic in the data set. Now what you have written? You have written total equals to float and then length of your data. A little bit of programming we have done here. Now you have written ax equals to sns.countplot and your x equals to outcome and data equals to data set you have. For p in ax.patches, height equals to p.get height. ax.text p.get underscore x plus p.get underscore width divided by 2. Height plus 3, right? Why do we have done those things? To get the percentage of the data. You can see the 65% of the data contains records belonging to non-diabetic patient, and the 35% of the data is saying you have a diabetic patient. The data set has a class imbalance and might have to be treated in future during the model building stages. While you try to build a model, maybe logistic regression, we will talk about linear regression analysis. We will talk about machine learning as well. But yes, if you want to model, you have to make sure you are going to use the class imbalance technique. Not now, you need to don't know about it. But yeah, these are the things. It's as suggested. Now we will see if we will do a correlation. What is correlation? So let's now plot a correlation plot. That is like this plot will help us understand if there is a multicollinearity in the data set or not. So what I have written f comma ax. Again, we are going to understand this figure size, that plt.fixsize equals to 20 comma 10. Then for correlation, you have to just write data.correlation, what type? Pearson. Now you have written sns.heatmap and then your correlation, right? So you will get what? You will get this correlation 1. Can you see correlation with pregnancy? And pregnancy, it will be always 1. That's why diagonally, all the index you have, that is 1. Right. This is something like the, read part is the morely highly correlated. Right. Now, from the above correlation, it can be inferred that there is no high multicollinearity in the data set. The correlation plot shows the relation between the parameters. Glucose, age, BMI, and pregnancies are the most correlated parameters with the outcome. Insulin and diabetes predictive function have little correlation with outcome. Blood pressure and skin thickness have tiny correlation with the outcome. There is a little correlation between age and pregnancies, insulin and skin thickness, BMI and skin thickness, insulin and glucose.
right? Now we are going to work on pair plot, right? And this is what we are going to do, and that's all for our data visualization. What is pair plot? Pair plot is a pairwise relationship in the dataset. If you want to see pairwise relationship, the pair plot function creates a grid of axes such that each variable in the data will be shared in the y-axis across the single row, in the x-axis across a single column. Now to get the pair plot, I have written sns.pairplot data u equals to outcome, and like this, how we are going to do a pair plot. But working on pair plot, it takes time. Why? Because pair plot is making pair plot each and every columns you have, right? Let's see how it's going to work. We will see about pair plot. Let's see how it's going to work on pair plot. So I hope you guys have understood all the technique we have done so far. If you have any doubt, do not forget to let me know in the comment. I will happily help you to solve your doubts. And if you like the video, do not forget to like it and subscribe. Great learning. So can you see, this is what the pair plot we get. Now what I want to understand from the pair plot, what are the things we can conclude? We can infer that the most of the predictor variables are weak predictors of outcome. The kernel density plots, the diagonal suggest that the distribution for diabetic and non-diabetic are very similar and are overlapping each other significantly. Hence, they won't be able to differentiate between a diabetic patient and a non-diabetic patient. The scatter plot also suggests very poorly correlated data with not hidden patterns or relationship. Hence, model built on this data might not be able to find out any hidden patterns or might identify nonsense patterns that do not make sense. The plot shows that there is some relationship between parameters. Outcome is added as hue, that variable. What is hue? The variable in data to map the plot aspects to different colors. We see that blue and orange dots are overlap. Pregnancies and age have some kind of a linear line, and blood pressure and age have the little relation. Most of the aged people have blood pressure. Insulin and glucose have some relation. This is what we can actually conclude from the pair plot we have done. Right? I hope you understand how to do a anomaly and outlier detection. How can you make sure that you are making sure that whatever the exploratory data analysis you are doing in your data, it's giving you enough insights to work with your data. Right? This is what we have done about this particular diabetes data set.
Now, in this part, we are going to do one more exploratory data analysis on different data set. We have done exploratory data analysis, outlier detection in diabetes data set. Now, we are going to use automobile data set. Where you will get the data set? You will get the data set on www.kaggle.com. Just click on the link, you will redirect to this particular data set. It's a free data set and you will get this data set on Kaggle. Now, if you want to download this particular data set, just click on download and it will automatically start downloading, right? So this is pretty much about the data set where you will get the data. Now, let's talk about the dataset description, right? So, in 1985, model import car and truck specifications, and 1985, words automate your book. So, personal auto manuals, insurance service office, 160 Water Street, New York, NY, 10038. Insurance collision report, Insurance Institute of Highway Safety, Watergate 600, Washington, DC 20037. Right? So this data set consists of three types of entities, right? What are those entities? So basically entities is nothing but the columns we have. And the specification of an auto in terms of various characteristics. B, it's assigned insurance risk rating. It's normalized losses in use as compared to other cars. The second rating corresponds to the degree to which the auto is more risky than its price indicates. So cars are initially assigned a risk factor symbol associated with its price. Then if it's more risky or less, this symbol is adjusted by moving it up or down the scale. Okay, actuarians call the process symboling. A value of +3 indicates that the auto is risky and -3 that is probably pretty safe. The third factor is the relative average loss payment per insured vehicle year. This value is normalized for all autos within a particular size classification: two-door small, station wagons, sports or specialty, etc., and represents the average, represent the average loss per car per year. Right? So I know this is little complicated while we are talking about the dataset description. So let's talk about more in depth in the dataset. So if you do not know how to, upload the data, you have to just click on this particular button, and from there is an option for upload the station storage. We have talked about before as well. Just click over here, it will redirect you to your local system, right? And this is how you can upload your data in the station storage. My dataset is automobile_data.csv. Now I have imported few packages. I have imported Pandas, Numpy, Seaborn, and Matplotlib. So a quick, a question for all of you. Why do we use Seaborn and Matplotlib? Please let me know in the comment section. And if you like the video, do not forget to like it. And if you want to get updated with the new content, then do not forget to subscribe. Great learning. Right? So how can you load the data set? You have to use a function called .read_csv. We have talked about that before as well. But as a recap, just to remind you, so we use .read_csv function to read CSV file. So I have written automobile_data.csv. Right? Now, okay, I forgot to install this. Importing these libraries. Okay, now if I just write it, yes, it gets executed. Now if you want to see the first 5 rows of the data, how can we do that? We just need to write data.head, right? Let me do that. Now if you want to see the columns in your data set, how can you do that? You have to write data.columns, right? I have written data.columns. Now, if you want to see the shape of your data set, how can you do that? You have to write data.shape. So it will give you the total shape of your data, how many rows you have, how many columns you have. Let me do that. Right. Now, I want to see the first 10 rows of my data. What I need to do? I have to write data.head. And under the parentheses, you have to write 10. Otherwise, in default, it will give you 5 rows. So here it gives me 10 rows, right? Now, if I want to see the last of the data, from the last, if I want to see the rows, I have to write data.tail. What it will return? It will again return the 5 rows from the last from your data set, right? So total data, how much you have? 205 data. So as it counts from 0 to till 2043,210. You got the last 5 rows of your data. Now, if you want to check, do you have any null value or not? What we need to do? We have to use a function called .isNull. And why we are using any? Please let me know in the comment section, because I have already explained that. Right? I have written data.isNull.any. So basically, it's going to return, yeah. So if you have any null value in your data set, it will show here. So for all the cases, it's false. So you do not have any null value. Now, why do we use data.describe? It's basically describe few things about your data set. So total count of your data, what is the mean value for each and every column you have, then what is the standard deviation, then minimum value you have in the data set. Then if you just want to part your data that IQ or range, right? First part, second part, third part, fourth part. So first quartile, second quartile, and so on, right? So 25%, 50%, 75%. And then you have max value in your data, right? So this is what a data.describe function describe us about the data. Okay, now you can see from the above snapshot of the data, we can see that some columns have missing values. What are the missing values? No, I cannot see here. Okay, right. So yeah, can you see here? This is the like maybe you did not get any null value, but you have the question marks, right? Can you see? Okay, if you can see, please do let me know in the comment section. So yeah, can you see we have this? We have to remove this. Okay. So for is null, maybe it's not taking as null value, but we do have few values that's inappropriate while we are going to do this data analysis. Now we have to what we have to remove them as a missing value detection and treatment, right? So let's start by checking the info, right? The count of the records in each columns of the data. If the count of the records is lesser than the total number of records, so that we can conclude there are blank records. So no, we do not have any blank records, right? But the records are representing this. These are the actually blank records, right? Now, since some of the predictor columns are continuous in nature, there might be a chance that zeros in the columns indicates the missing value that we have done earlier as well. Now, if I just try to write data.describe.t, then you can see here the same thing, right? So here we are saying none of the continuous seem to have a missing value represented by 0. We can also see there are a total of 11 continuous variables, but the describe table has only 10 continuous variable. This is because of column normalized losses has missing values, right? So here, how can we do that? So here we can see we are going to use Numpy. So we have written from Numpy import nan, and data of normalized losses equals to data of normalized losses dot replace that question mark comma. I want to replace the question mark with np dot nan value. If I just do that, and then if I just do the data dot head, you can see we do have nan values. These are the different way you can understand you do have missing value and you have to handle them with care, right? Now you have to write data dot head if you want to see again. Now I want to see something that data dot is null dot sum. Now I will get the actual sum of the null values. So for normalized losses, we have 41 null values, right? So normalized has 41 missing data points, and we will replace this missing values with the median of normalized losses because median is least affected by outliers, right? So if I just write data dot fill any data dot median comma in place equals to true, right? So I want to fill my nan values with the data of median. Now if you want to see what is median differently, let me show you. I have shown it in the previous project as well. Let me just show that. Okay, data dot median, it will give all the median value for each and every column you have. So for normalized losses is 115, it will automatically replace those with the 115. Let me show you. Yes, can you see all the nan values are replaced with median? This is how you can actually replace your nan values, and how can you treat these missing values. Now if I try to see data dot is null dot sum, then it will give me 0 that we do not have actually any nan values. Now if I just don't want to go for data dot info, right? So now what we need to do, so you can see over here that notice that the data type of normalized losses is object. We have to change its data type to numeric float. Yes, because we don't want to have a data type of object. We want to make it a numeric value. How can you do that? You have to write data of normalized losses equals to pd dot, right, to underscore numeric if you want to change something to numeric. And then I have given data down normalized losses comma down class equals to float, right? Now if I just write data dot info, it will show that normalized losses is float 34.2, right? It's not numeric value. We have done it, right? Okay, what is this? Okay, Right. So now if I just do the info, it's done, right? Now that we have treated the missing value, let's move to the outlier detection and treatment. Now we will see how can we do the outlier detection. So outlier detection is basically we can find it out by using box plot, are a great way to detecting outliers. Once the outliers have been detected, they can be inputted with the 5th and 95th percentiles. Right, so I have written data dot columns, right, and then we have just done the outlier detection using box plot, right. We have written plt dot figure fixed size 20, 15. Then we have written plt dot subplot 3, 4, 1. So what subplot you want? Like, this is the like portion you are giving while you have a plot, and then you have the subplots, right? And your figure size will be 20, 15. Then you have given the normalized losses, symboling, wheelbase, length, width, all the columns you have given to see what are the columns has the outlier. You can see this at the outlier for highway mpg. You have compression ratio, you have engine size, with the otg mpg, you have the outlier. Okay, few of the columns have the outlier, right? So you can see how the outliers, this dotted are nothing but the outliers you have. Now, like from the above box plot, we can infer that out of 11 continuous variable, 8 of them have outliers. These outliers will be imputed with the, right? Imputed with the 5th and the 95 percentile. How we did? We have used a cliff function. So again, for your like a sweet question to all of you guys, what is cliff function? Why do we need to use cliff? Please do let me know in the comment section, for that we can understand you are actually listening to us. If you like the video, do not forget to like it and do not forget to subscribe. Great learning. Now we have written data of normalized data equals to data dot normalized losses. Okay, clip lower data dot quantile 0005 upper is equals to quantile 0.95. Let me just do the for all the columns we have, and then we are going to again plot the box plot. Can you see? All the columns have no outliers. So you have successfully handled the outlier we have in the data set. Now you can see you can go forward with the data. Now we will do few data visualization. What are those data visualization? We try to understand the pair plot. How can we do that? We have written SNS dot pair plot. What is SNS dot pair plot data, and then it will give you the pair plot. Pair plot is nothing but giving the relation between different columns you have, right? So let it get printed. Let's see. Let's wait for a few minutes, and in the meanwhile, if you have any doubt, please do let me know in the comment section. For that, I can help you out to solve your doubts as well, right? Let's see. Okay, it's coming. Seaborn. And pair plot we are using from Seaborn. So that's why it's SNS dot pair plot. As the data set is little bit, big, that's why doing the pair plot, it's taking little much of time. Okay, so it takes a little bit of time, but you can see this is what it's showing, that you get the pair plot, right? Okay, so some of the kernel density estimate plots show more than one peak and indicating the presence of clusters in the data set. So basically, maybe you have clusters in the data set, right? Now, if I just want to go for correlating data, like understanding the correlationship between different columns we have, we use data dot code, that's Pearson, and then we have used the SNS dot heat map. So this heat map is nothing but your correlation between different columns you have. So with symboling it's one, you can see, and this is the it's more of a rate. This is the more of like your columns are correlated, right? So the above correlated plot shows presence of multicollinearity in the data set. You can see there are multicollinearity we have in the data set, right? And if you just want to go for few understanding few visualization, how to do that? So I just write data.symboling.histogram. I want to understand the histogram. Then I have given the title as insurance risk rating of vehicle. Number of vehicles, risk rating. This is the risk rating according to the vehicles, right? From the above histogram, we can infer that a major part of distribution lies between the range of 0.5 to 1.5. We can also infer that a large number of cars in this dataset are safe. Obviously, cars are mostly safe. Now, if I just want to understand the frequency chart, then fuel type, that data of fuel type dot value counts dot plot that kind equals to bar, right? And we have written plt dot title, frequency chart, and fuel type, number of vehicles and fuel type, right? Let's see, number of vehicles and fuel type. Yes, you can see this is the number of vehicles and this is the, like we have gas is more, diesel is less, right? So the above bar chart, we can infer that the majority of the car recorded in these data sets run on gas, right? Now we will do few things about the data set, the data pre-processing. This data set has 15 categories variable and most of them have more than 2 categories. We cannot run a regression model on the text data. So we actually are going to talk about regression model. You have to keep tuned to know about regression model. And in the meantime, let's see how can you do the data processing. So in the order to deal with this challenge, let's learn about level encoding. Level encoding is the process of converting categorical data into numerical data. Let's see how this is done. In the example, we will be working with the variable body style, which has 5 categories, namely convertible, hatchback, sedan, wagon, and hardtop. Now what we have done, we have just done data of body style, head 20. So I just want to see the 20 data from this particular column. Now we are going to do a label encoding. How to do a label encoding? So basically for each and every vehicle, you will get an idea, you will get a numeric value. Suppose you have the person is diabetic or not, you have 0 and 1. So you have 5 different parts, like 5 different types. So you will have 0, 2, 0, 1, 2, 3, 4. This is what stands for label encoding. So I have written sklearn, that is scikit-learn import pre-processing, and from scikit-learn pre-processing import label encoder. Then I have just called the label encoder and just I have given my label encoder dot feed transform data of body style. Then if you just write dot head20, you can get that what are the thing you have for a particular, suppose you have for convertible, it's converted to 0. Then hatchback converted to 1. So for all the hatchback, you will get 1. For all the convertible, you will get 0. For all the sedan, you will get 2. This is how we did the label encoding, right? So after running the label encoding code, we can see the variable body style has numeric values ranging from 0 to 4. The problem with the table encoding is that it introduces an order between the categories, that 0 greater than 1, 1 greater than 2, 2 greater than 3, and 4. This might confuse the model into thinking that convertible is greater than hatchback. So to deal with this problem, let's understand the concepts of one-hot encoder. In one-hot encoding, categorical columns have been labeled encoded are split into multiple columns and the values are replaced with zeros and 1. 1 marks the presence of value and 0 its absence, right? Let's look at the example. So I have done this particular label encoding, and then now I want to go for one-hot encoding. So again, to import one-hot encoding, I am going to import it from scikit-learn. And then I have called one-hot encoder handle unknown equals to ignore. And then I have given my dataset to transform. Now, if I just want to show you what's happened, can you see you get 1, 0, 0, 0. So you have total 4 class, right? Total 5 class, 0, 1, 2, 3, 4. So if your class comes under 0, it will be 1. If your class comes under 2, it will give 1, and other than everything will be 0. So there will be no like 0 greater than 1, 1 greater than 2. These concepts will not be there. That's why we went for one-hot encoding. Right, so this was pretty much about the data pre-processing. We have done the data visualization. How can you handle outlier? How can you handle like different multicollinearity, and also like how can you find it out multicollinearity in the data set, and how to do the outlier analysis as well using box plot. right? So we have talked about everything in the both of the dataset. I hope you will like it. In this part, we are going to talk about the unsupervised learning, which is also a part of machine learning. So let's have a look at what is unsupervised learning and how this is different from other types of machine learning. So let's have a look at the agenda. So in this part, we are going to talk about why do we need machine learning? What is machine learning? Then we will have a look at what is the life cycle you need to follow to build a machine learning model. So now we will have a look at what is unsupervised learning and how it is different from supervised learning. Then we will look at into the concepts of clustering, which is the main concepts in unsupervised learning. Then we will see what are the types of clustering we have in unsupervised learning. Also, we will have a look at what is k-means clustering in detail. And lastly, we will do a demo on k-means clustering. So let's get start with why do we need machine learning? So if there is a question in our mind, why machine learning are getting popular these days? What are the special thing, what are the special feature we have in machine learning? So let's have a look at why do we need machine learning with these days? Why it's getting boomed and why they are actually getting the popularity, right? So let me give you a scenario for that. So in the past, what we used to have, in the past we used to have a data in a structured format. So when we talk about data, what is data? Data is nothing but the information, right? So as we know, data is nothing but the information. So when we used to have information about a company or about some particular products, that time we have human to actually enter those data, to make those data, right? But now what's happening right now, with time we are going towards online world. So as we are going towards online world and we're actually dependent upon all the things like booking your cab, or if you go for booking your food, then ordering your like clothes, everything we prefer to go for online because it saves our time, it saves our efforts and energy both, right? So in this case, when actually we went for all these things, that time, did you ever notice the respective companies are currently using those data? They are storing those data. They try to use those data to focus their business. With time, if you can see, like for me, almost every second, right, I cannot stay without my phone. So I am just I'm searching something, or I'm just going for shopping, or I'm doing something in my phone, right? So in this case, what we are actually doing, we are giving the data to those respective companies. They actually try to understand our likings, our dislikes, right? So in this case, can you imagine per second how many users they have? A human being cannot store those data manually. That time what they are doing, they are storing those data in a automatical way, right? They have done some code and this code is basically storing those data. But when it's not manually, when it's automatically they are doing it, there are lots of errors. Those data with lots of noises, with lots of errors. So those data are not in, you cannot use those data directly. That time you need to do something with those data to in order to use them to purpose yours, like if you want to do something with this data, you cannot use those error data, right? That time machine learning comes into the picture. What tools you used to have in past to handle those structured data which is entered by the human, those tools are not at all useful for handling this huge number of unstructured or semi-structured data. So when we talked about this unstructured or semi-structured data, these data are nothing but with errors, with so many faults. So if you want to use those huge number of data in order to make your customers maybe you can say that I just want to focus my business, or you can say I just want to try to understand my business in a more concise way, or I want to make my customers more happy with my services. So in this case you need to have you need to have some information. So in order to have those information, you need to use those data, but your data are in a very bad structure, it's very bad manner. And if you just use those data, that's not possible. In order to use those data, we need to use some techniques. where data science comes into the picture. We use lots of tools to, remove those noises, remove those errors, and then when your data is ready, when your data is actually in a position to work with, we use machine learning. So why we use machine learning? Again, we make a model out of it, and we try to, reduce the human effort again. So machine learning basically helps us to reduce the human effort, production cost, right? There are lots of features also we will talk in the later in the section, but for time being, you can understand machine learning help us to use those data in order to have like achieve our goals, right? So this is why we need machine learning. The basic needs you need to understand whenever you try to learn something new. So this is the main part. Why do we need machine learning? Now we will have a look at, we understand that what is machine, like why do we need machine learning, but we need to also understand what is machine learning. So machine learning is a subset of artificial intelligence. We are quite familiar with this particular word artificial intelligence, but for time being you can understand it's an umbrella under which we have lots of fields, we have lots of subcategories, right, which allows the system to automatically learn and improve from experience without being explicitly programmed. But what actually want to mean by that? So we have few algorithms, we will talk about that. We have different type of machine learning, right? So according to those algorithms, using those algorithms, we use the data. From there, we make a model out of it. And from that model, we'll start working like a human being, right? And it will have errors. It, like human being also is not also perfect, right? But in this case, what will happen being a, you don't need to use the human effort all the time. Your model will work for you. This is something machine learning you can understand for this time being now, right? So now we will have a look at the types of machine learning we have. But before that, let me tell you what is the difference between traditional programming versus machine learning. So when we talk about the traditional programming, what we used to get, we actually give the data, we do programming, and then we actually get the output. But in the case of machine learning, we give the data. We write program, your model is made, we will get the output. But for the second time, when if you give your data, you don't need to write the programming because your model is already ready. So you will directly get the output. So in this case, it's actually saving the human efforts, reducing the cost, and many more other things. So this is the main difference between traditional versus machine learning. Now we will have a look at what is machine learning, the process of machine learning. You can see there are lots of raw input we have like apple, banana, mango. Then we will use some algorithm, right? We will try to understand our data interpretation, and then we have exploratory data analysis. We will try to understand our data. Then we will use an algorithm. From there, we will process, we will make a model, and then we will see the output, right? What is apple, what is banana, what is mango, right? Your model will give you the answer. So this is how machine learning works. Now, if we look at the life cycle of machine learning, how machine learning is basically, if you want to go for making a machine learning model, how to do that. So let me start with a scenario. For that, it will not be a boring part for you. I know this is little theoretical, but trust me, before start with any concepts, you need to have a good understanding of their theory. So in this case, if we talk about the life cycle of machine learning, let me give you an example of maybe you joined Swiggy, Zomato, or any of the startup company for time being, which actually you know well. So for that company, you joined as a data scientist. When you join them as a data scientist, they know you have a good understanding about data. But what data you will do? So they will give you an objective. What objective? Maybe they just give you, hey, I just want to focus my sales. Or they can say, hey, I just want to increase the customer satisfaction. How to do that, right? So they can give you multiple scenarios. I gave two. So this is something you need to understand first. If you need to do self-forecasting, you need to use some different technique. If you want to, increase the satisfaction of the customers, you need to use some other techniques to understand what is the customer actually, what are the things customer liking, right? So those two processes are totally different. So the basic part of doing, like starting with any project, you need to understand the business problem. After you understand the business problem, you need to go for data collection. Yes, if you don't have data, how can you start with, right? So you need to go for data collection, which is known as data acquisition. Your company will give their own data obviously, but there are lots of repositories are present where you will get the similar type of data. Now we will ask me, why do I need to go for us finding the data when my company is going to give you? So when your company is going to give you, it will be a limited data. There is, I cannot say this is very less or this is like minimum, but the more data you have, the more pattern you will get, the more you will have a good understanding about the particular problem. In this case, we suggest as much as data you can collect for your particular project, your project will be that strong, right? So the second part is data acquisition. After that comes the third part, that is known as data cleaning. Now as we are talking about the unstructured or semi-structured data, samely you will get these things in the after data acquisition. Anyway, you are you are using those semi-structured or some unstructured data, right? So when we go for data cleaning, we need to give a lot of time, almost 50% time to make your project it takes. So basically your 50% time will go for data cleaning, right? There can be misspelled attributes, there can be lots of errors you can see in your data, there can be different columns, different type of outputs, different type of inputs, right? You will get lots of problem. In this case, you will get null values, you will get there is no value but still there is some string is there, right? There are lots of things can be happen in data cleaning with time, with it time consuming basically. With time, what you need to do, you have to clean those data. You just need to try to clean those unwanted part from your data. After you clean your data, trust me, you have done a great job. After that, you need to go for exploratory data analysis. Now you will ask me, why do we need to go for exploratory data analysis, which is in short known as EDA? Because this exploratory data analysis will help you to understand your data in a more concise way. Let me give you an example that for a data scientist, what you need to know, you have to have a good idea of linear algebra. You have to have idea of basics of statistics and also one programming language, R or Python. So in this case, you can see that exploratory data analysis help you to actually do some statistical concepts evaluation. Maybe what is the standard deviation of your data? What is the density for a particular column? What is the outlier? Do you have any outlier in your data? Do you have any missing value in your data? If you have, you will get to know in this particular phase. This is known as exploratory data analysis to understand your data in a more good way. After that, when your data, you know your data, there are two types of data we have, categorical data, continuous type data. So when you know what type of data you have, and one more thing we have in data, that is labeled and unlabeled, we will talk about that. So when you know a good understanding of your data, so you can say, hey, I know what type of algorithm I need to use for my this particular data. It will be supervised, it will be unsupervised learning, or it will be reinforcement type of learning, right? So you will understand by yourself. After you make your model using the algorithm, you will give the new data. So your data set will be divided into three part. Test, train, and validation, or test or train. So train part is used for train the model, test part is used for testing the model. So testing the model is one thing, your computer or your model will not see this data. This test data will be new data for your model. So when you give a new data after the train of your model, you will understand how your model is reacting with the new data. If you see your data with the data, your model is react perfectly fine. You can say, hey, my model is ready and my model is giving a good accuracy with the new data. But there are lots of things happen, like you need to use lots of things, optimizers and all. We will talk about that. But yeah, this is the basics parts to learn, for a machine learning to build. And then when you know your data is working perfectly, you just need to deploy your model, right? So this is the whole life cycle of machine learning. In this part, we are going to talk about the types of machine learning. Basically, we know we have three types of machine learning. One is supervised learning, one is unsupervised learning, and one is reinforcement learning. But how they are different from each other? What is the difference between them? How can we actually segregate our problem according to the these types of machine learning? Where to use these types of machine learning? We will talk about that. So for supervised learning, one thing we can say, it has supervisor. what is a supervisor? Is there will be a actual supervisor? No. You will have a data set where you will have label. So when you have label in your data set, that will basically work as a supervisor for your model, which will help your model to get trained. So let's have a look at what is actually level data I am talking about. So here you can see this is nothing but a data set for fake news detection. Right? So here what we have few columns. So in this case, we have the URL from where this news is taken, the headline, the 4 ways Bob Cocker something is there, and the body, the image copyright getting. And the level is 1. So level is 1 and 0. Right? So basically this label is notifying you which news are fake news, which news are actual news. Right? So this is something called about label. And if we take one more example of label, so there is a diabetes data set we have. There we have pregnancy column, we have glucose column, blood pressure column, skin thickness column, insulin, BMI, diabetes pedigree function, age and outcome. In this case, you can see this pregnancy, glucose, whatever the column we have, these are all independent column. So basically a person, how many times that person was pregnant, and what is the glucose of that person, what is the blood pressure of that person, what is the skin thickness, right? Insulin, right? BMI, diabetes, right? So according to all these things, we are going to say, okay, this person is diabetic. Right? So when the outcome is 1, so we can say, okay, this person is diabetic when this person have these particular things, right? So in this case, you can see the 0 and 1 again, it's as a label which is notifying that this person is diabetic or not. But this particular column, which is outcome column, and we said actually it's a label, it depends on the other columns. Right? So when you have a data set like this, when you have the classes, these classes are nothing but your supervisor. That time we are going to use the algorithms of supervised learning. Now, if we talked about the unsupervised learning, that time in the data set, you will not have those labels. You will have the information, all the independent columns, but not the labels. When you don't have label, who will supervise your model, right? That time your machine learning algorithm will try to make its own label. So basically they try to make clusters from your data. Maybe you will have 2-3 clusters. From those clusters will work as your class. In this time, machine will learn by itself. From the image you can see that the machine is learning by itself. Now comes reinforcement learning. So in this case, I can give you an example of a real-time application, that is Tesla self-driving car. So in this case, what's happened, when your model is working fine, that time you will give a reward to your model. But when your model is not working properly, it gives an error and not, understanding your command, that time you will give an penalty to your model. So this is pretty much about these 3 types of machine learning. Like the supervised learning is there is a supervisor. Unsupervised learning, there will not be any supervisor. So in this part, we are basically talking about unsupervised learning. What is unsupervised learning? How this work and how we can actually use those clustering. What are the types of clusterings we have? And then we will actually work with the k-means clustering. Now we are going to talk about unsupervised learning, right? So what is unsupervised learning? So let's look at the problem. The classifying unstructured and unlabeled data into different categories and predicting the class of unlabeled data and unstructured data. So as we were talking about, when your data set does not have those label, that time how can you actually cluster your data? How can you actually go for doing the prediction? This is our problem, and the solution comes into the picture, that is unsupervised learning. This is where supervised learning fails and supervised learning algorithms comes into the picture. The unsupervised learning algorithm clusters the input. The same type of input you have, they will be in the same cluster. Example, cluster different bike based upon their speed limit, acceleration and average. So basically you have cycle and you have bikes. So when you have cycle, the speed limit and acceleration, or there will be no acceleration, right? These things will be same. But when we talk about the bike or the scooty, that time we will have speed limit, this near called the same speed limit. We will have the acceleration, right? And the average of other things, right? So these things will be same. So machine can cluster those things and they can take into all those things into note and they can make their own clusters. So data into different classes on the basis of their statistical properties. So this is something the way unsupervised learning works when you don't have any supervisor to work with. Now we will have a look at one more thing, that is unsupervised learning. But what is unsupervised learning? That we know. So training data for unsupervised learning is a collection of information without any label. In one word, you can explain unsupervised learning like that. When you have a data set, when you have information, but you don't have any label or class, that time you have to go for unsupervised learning. Now we will have a look more example of unsupervised learning. A set of relevant information is fed into the M system. The system identifies different type of bike using features like color, size, speed limit, average, etc. and categorize them. When a new bike is shown, it analyzes its features and puts it into the new category or the category having similar featured item. So when we are talking about a bike, right? In that time, the bike limits, right? Not all the bike, all the bike speed limits are not same. But there is something like if you work with a cycle, right? There should be difference between cycle and the bikes, right? So in this time, it can automatically categorize what is cycle, what is bike, when this label is not there. You are not saying, okay, if the speed limit is this, if the color or the size is this, then this is cycle. When this color and side and speed limit, right? The speed limits are this will be bike. So you are not giving any label to it. It automatically making the label by itself. So this is what unsupervised learning means. And I can give one more example of that. Suppose you are working with banana and apple. When you said this, like this fruit particularly will be red or orange, right? And the shape of the food will be oval or circle, right? That time you can say in the case of banana you will have yellow or green, right? And when the length of this will be obviously big and the like shape of it is like little length, like this shape is not same, right? So in this case you can say, okay, your machine will take all those things in count and it can automatically make the level out of it. It doesn't know that what particularly it is, but it can say, okay, these are the things can come into same category, these are the things can come into the same another category, right? So this is how this unsupervised learning works. Now we will see how this clustering works and what is clustering. So process of dividing a data set into groups and consist of similar data points is known as clustering. So you can understand these are the information is nothing but our data points. So basically for the machine or for the model, it's actually clustering the same data points with one cluster and the different data points with the other clusters. So this is how this clustering works. As a note, points within the same clusters are similar to each other but are different when compared to other clusters. So you can see in the image itself we have same type of human being who are in blue. Some of them are in red. Some of them in yellow, but they are different from each other. But when we talk about the same cluster, we will have the same thing. Right? So do not confuse about the different clusters. So clusters basically make with the same kind of data points. So if we talk about the same kind of a choice of movies or same choice of clothes, someone like Western, someone like Indian, right? So in this case, they will try to cluster all customers together who are actually liking Indian most, and they will try to give some recommendation. So we all know the recommendation about Amazon, Flipkart, Myntra, right? So whenever you go for doing any shopping, they will show you that maybe you will also like this. How they do that? Basically, it's nothing but the clustering, the recommendation system, right? So they do the clusters the same type of a customer and give the same recommendation for them, right? So this is where also unsupervised learning works. So now if we talk about the example of clustering, so cluster different colors of fruit, maybe mango, banana, I can see some, blueberries are there, right? So they will cluster the same type of fruits together. Now, if we talk about the different type of garbage, so maybe there is a paper, glass, organic, plastic. So you have garbage all together and your machine will try to find it out the same type of a garbage and actually cluster them together. So this is the example of clusterings. So now if we ask why clustering is needed, in that case we can say determine intrinsic grouping in a set of unlabeled data, right? Organize the data into clusters. thereby showing internal structure of the data. Yes, it will show what is the internal structure of your data, how your data is structured, what is the cluster, what are the number of cluster you have in your data, what is the data distribution, everything you can understand if you go for using clustering. Then create partition in the data set. It's also create partition. Obviously, when you have 2-3 cluster in one particular data set, before that your data set is a whole is a whole data set, but when you actually cluster them, it will have the partitions, the different clusters. So this is why we need clustering to understand our data set in a more precise way and also do the machine learning algorithms. Now, if we talk about the types of clustering, what are the types of clustering we have? We have clustering three types of. One is exclusive clustering, one is overlapping clustering, one is hierarchical clustering. So let's have a look at one by one in a short way what this clustering stands for. So first, if we talk about exclusive clustering, that time you can say item exclusively belongs to one cluster, not several. So when you have clusters 0, 1, 2, 3, that time these clusters are not going to overlap to each other. You will have a proper cluster for each and every data points, right? For maybe your data points 1, 3, 4 and 7, it's coming to one cluster, and for your 3, 4, 7, 6, it's coming to another cluster, but there will be no overlapping. So the example of exclusive clustering is K-means clustering, what we are going to do in the later in the section, right? Now if we talk about the overlapping clustering, what is overlapping clustering? Set of item belonging to multiple cluster. So one particular data point can comes to two different cluster. So you can see the rate dots, you can see it's belonging cluster 1 and cluster 2 both. So this is known as the belonging to multiple clusters is known as overlapping clustering. So the example of overlapping clustering is fuzzy or C-means is type of clustering, right? Where actually this this data points are going to can be the part of two different cluster or three different cluster, right? So now if we talk about the hierarchical clustering, but before start with the hierarchical clustering, maybe you can ask me, hey, how can it be even possible that one data point will belongs to two different data or two different clusters? But yes, that's possible because we don't give any type of a label over there. Maybe the characteristics they both have that something common, something similar, that time they can overlap with each other as well. Now comes the hierarchical clustering. Cluster having a parent-child relationship, which is actually like nothing like something like tree-like structure. It's known as hierarchical clustering. From the name itself, we can understand there is a hierarchy. So basically, hierarchical clustering itself is the example of that. So you can see C2 is the parent, where you have C1 and C0, which is the nothing but your child, right? So cluster 0 and cluster 1 will be your child, whereas cluster 2 will be your parent. So there is a structure of tree-like structure, which is parent and child's relationship, right? So yeah, we have talked about the pretty much about why do we need clustering, and then what is the reason we are actually going for clustering, and we have the partition in the data set. We try to understand our data in a more precise way. We can do the prediction using this clustering, and when your model is going to see the same type of a data points, is going to cluster the same thing with together, right? So this is pretty much about the clustering we have learned so far, and maybe after that we will start talking about the K-means clustering. In this part, we are going to talk about what is K-mean clustering. K-mean is a clustering algorithm that we know that it's exclusively, if we go back to the presentation, you can see the exclusive clustering is one of the example of K-means clustering. So from this, what we know that items exclusively belong to one cluster, not several, right? So always keep this basic part in your mind. So now if we'll talk about the K-means clustering, K-means is a clustering algorithm which focuses on grouping similar elements or data points into a cluster, right? So basically what we have actually do, so basically K-means clustering algorithm is focuses on grouping similar items, right, in a particular cluster. So K means represent the number of cluster. What are the numbers, total number of cluster you will have in your data set, which is known as the K-means clustering, and the K is basically defining the number of cluster, right? I hope you understand why this is known as k-means clustering. Now, if we just go deep into k-means clustering, before that, you need to have an idea about business applications we have in k-means. So, behavioral segmentation, inventory categorization, sorting sensor measurements, and detecting bots or anomalies. For that, we use k-means. Now, if we talk about the understanding k-means algorithm, in that case, maybe we are going to take an example. You can see here there is number of cluster equals to 3. We have data points over here in the straight line. So in this case, what you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see in the visually we can say this, and this. This tree will be 3 clusters. But how to do this with k-means? So let's have a look at how we'll start with the k-means. So firstly, we need to maintain some, we need to maintain some steps. Before that, if you want to see our final output, you can see this will be our final output. The first 4 will be belongs to the orange group. The second blue one will be the 4 will be belongs to the blue group. And the third cluster, it's a green cluster, the last 4 data points will belong to the third cluster, right? Which is the green cluster. Now, if we start doing this one by one, it's just something we can see. But there is something we also need to do. So first, identify the number of clusters, that k equals to 3 in this case. So already we know that identify the number of cluster. Now, randomly select 3 distinct data points. Okay. Now, you know nothing. There is the white cluster, white data points you have. Now, I have just chosen this particular orange, blue and green one. So basically you have to choose randomly 3 distinct data point. After that, measure the distance between the first point and the selected 3 clusters. So now what you need to do, maybe I have taken this particular part, right? I have taken this orange, then blue, then green. So I am going to take the distance between the first one, the first data point with the first data point I have selected, from the second, from the third. You can see measure the distance from the point 1 to the orange cluster. You can see this is the arrow is showing that. Then distance the point 1 to the blue clusters. This is one we are using for the blue clusters, and for the last one, the distance from the point 1 to the green cluster, right? So these are the 3 steps you need to follow when we go for using this particular k-means algorithm. Now, if we just look at the second step, what we need to do, in this case, assign the first point to the nearest cluster. So you can see for the first one, orange in this case, right? So what we are going to do, you can see when we actually calculate the distance, this distance will be the less, this will be more, this will be pretty much more, right? So that time, this will be the first cluster we can assume that comes under orange, right? So this is the repeating the process. Then we again going to repeat the particular process, right? After that, calculate the mean value including the new point for the orange cluster, right? Then we are going to calculate the mean value, right? That is which is going to including the new point for the cluster, orange cluster. All right, we will try to find it out the mean over there. Then what we need to do, see after this when we actually did this, so that time we are going to do what? So find the which cluster does point 2 belongs to how, right? Repeat the same procedure, measure the distance to the orange mean. Again we are going to measure the distance. Here you can see we have taken the mean over here, right? So distance from point to the orange cluster, right? You can see. Then distance from the 2 to blue clusters, we have done this, and then distance from the 2 to the green cluster, and we will keep on repeating this particular stage, right? After that, point 2 belongs to the orange cluster. Calculate the new cluster mean including the new point. Again we need to calculate the new cluster mean, and again we are going to include the new point. So we are going to repeat the process like this only, right? This is just for we are trying to elaborate this just to your understanding, right? Find to which cluster does point 3 belongs to and how, right? Repeat the same procedure, but measure the distance to the red mean, right? So distance from the point 3 to the new orange mean, and distance from the point 3 to blue cluster, and distance from the point 3 to the green cluster. So this is how we will try to find it out the cluster for each and every data point we have in our data set. Now we will keep on repeating the process, and you can see point 3 also belongs to the orange cluster. Measure the distance and add the third point to the cluster having the minimum distance and calculate the new cluster mean including the new point. Right? So now as we have done this, so you can see find which cluster data point 5 belongs to and how. We are going to do the same process. Repeat the same process and we will find the result out of it like that. Now, what we are going to do, since the raised points lies closest to the green cluster, so all the point you can see from here, so as we have taken this point, right, from here to here, and these all comes into the green cluster, right? But this is not right, right? We can see this is not right. So in this case, what we are going to do, the result we got, that is the blue, we have the orange is fine, but the blue one, that the two blue should come under blue, which already comes under green. So in this case, we need to do, again, we need to repeat the same thing. But when we actually do the same thing for the second time, for the second iteration, before that, you have to understand the total variation within the cluster. You can see this is the variation over here. It's not symmetrical at all, because in the blue one, you can see the variation is very less, right? So this is how we can understand our clustering is not perfect. When we try to do the iteration 2, we will try to change, not we will try to change, we will actually change the random data points, right? And start from the first with different initial random points. Always remember, we cannot use the same initial point, so as compared to the first iteration. Then again, step 1, select the number of clusters that we know equals to 3. Randomly select 3 distinct data points. The same thing we have done. Then measures the distance between the points and the selected 3 cluster. And keep on doing this. And then again for the iteration 3. Right, for iteration 2, iteration 3. After that, what we will do, you can see the iteration and the variation. Right, finally the iteration with the minimum variation is selected. So we always try to find it out a clustering where the variation is very limited. So you can see in the iteration 3 we got our result. So this is how our k-means clustering works, and this is how we can actually work with k-means. But after this we will have a talk about how to decide the value of k. What is the funda behind it? How actually the k value, for this case we know the k equals to 3. But how to decide the k value? In this part where we left off, that how to decide the k value, we will do it over here. So for our case, for the example, we know this time k equals to 3 was known. But what if the exact value of k is unknown? Right? So the idea behind partitioning is to define clusters such that total intra-cluster variation or total within sum of square, which is known as WSS, for each cluster is minimized. So always try to have a intercluster variation should be very minimized, and also within sum of square, which is known as WSS, will be also very minimized. The note you can understand the total WSS measures the compactness of the clusters. Right, so if you want to check the compactness of the clusters, you need to measure the WSS, which is nothing but within sum of square. Now we will understand how to decide the value of k. So this time we use a method called elbow method. The elbow method looks at the total WSS as a function of the number of clusters. The number of clusters should be chosen so that on adding another clusters does not improve the total WSS. Right? So from there, when you actually, this elbow method is going to help you the compute. How to do that? Compute different values of k, varying with k from 1 to 10 cluster. For each k, calculate the total within cluster sum of square, which is known as WSS. Plot the curve of WSS according to the number of clusters k. The location of a bend that is known as knee in the plot gives the appropriate number of clusters. If we go back to the presentation, you can see there is a graph is given. In this graph, you can see there is a elbow. Elbow type structure is there. Right? So this elbow is basically nothing but going to help you to how many cluster you will have in your data set. So the location of bend knee in the plot, which gives the appropriate number of cluster. So this is how we actually need to decide the value of k. And to decide the value of k, we need to understand the elbow method. Now, after this, we are going to do the demo on k-means clustering. So we will do a basics demo on k-means clustering, and after that, we will do a project on k-means clustering. So let's get started on that. In this part, we are going to talk about k-means algorithm implementation in Python. How to do that? how we'll actually implement k-means in Python. So let's have a look at how we will start with k-means algorithm. So let's have a recap of how k-means works. So the first step, as we all know, need to specify the number of clusters, that is k, need to be generated by this algorithm. Then the step 2, next randomly select k data points and assign each data points to a cluster. In simple words, classify the data based on the number of data points, right? What is number 3? So number 3 will compute the cluster centroids. We need to understand what is the centroid of our cluster. Then the fourth step is keep iterating the following until we find the optimal centroid that we have seen in our presentation, which is the assignment of data points to the cluster that are not changing anymore, right? And there are few subpoints if we want to look into. Then the first sum of the square distance between data points and the centroids would be computed. Then now we have to assign each data point to the cluster that is closer than the other clusters, right? That we have done. That is basically we are trying to calculate the centroids. At last, compute the centroids for the clusters by taking the average of all data points of that cluster, right? So these are the steps we have followed when we have done this particular process in presentation, right? So k-means follows expectation maximization approach to solve the problem. The expectation step is used for assigning the data points to the closest cluster, and the maximization step is used for computing the centroids of each cluster, right? So we know all these things before as well. It's just to recap to understand k-means in a more concise way. So now we will have a look at what are the libraries we are going to use over there. So we are going to use Matplotlib, Seaborn, Numpy and sklearn. Now you will ask me, what are these libraries used for? Let me give you a quick heads up on that. So basically Matplotlib and Seaborn are used for data visualization. There is one more question. If Matplotlib can do the data visualization, then why do I need to go for Seaborn? Because Matplotlib is a very basic library. So in this case, if you want to do some kind of a advanced data visualization, you have to go for Seaborn. And Seaborn is basically based on Matplotlib, right? So you can understand for this time being that Matplotlib and Seaborn both are required for a proper data visualization, presentation. Okay. Now we will have a look at Numpy. So what is Numpy? Numpy is nothing but numerical Python. We used for numerical purpose. Then comes sklearn. What is sklearn? This library is known as scikit-learn, basically for machine learning techniques. In this library, all the algorithms are implemented, and also we can use them by calling them their name, right? So basically you don't need to do anything and you don't need to write an algorithm from the scratch. The scikit-learn library makes our life easy. Now we will going to do few things. First, we are going to generate a 2D data set which will contain 5 different clusters. How to do that? For that, we are going to import make blobs from scikit-learn. So we have written that from sklearn.dataset.samples generator import make blobs, right? So this is how we have imported our library. Now we are going to making our data set. But wait, we need to talk about what is make blobs. So if we go up, the make blobs is basically generate isotropic Gaussian blobs for clustering, right? So in sample, we have few parameters on this particular function. The in samples, this basically it is the total number of points equally divided among clusters, right? Then we have in features, the number of features for each sample, right? Then we have centers. So basically centers are nothing but the number of centers to generate or the fixed center location. If in sample is an int and center is none, 3 centers are generated. If in samples is an array, like centers must be either none or any other length of equal to length of in samples, right? So this is how we actually decide our centers. Then we have cluster std. Why do we use cluster std? Because this is a standard deviation of the clusters, right? Then we have shuffle, we have center box, random state, reproducible output, return centers, all these parameters. So we can look into it and you can start using according to your uses. Now what we are going to do, we are going to do a very basic make blobs. So in this case we have written that x and y equals to make blobs in samples equals to 400, centers equals to 5, cluster standard deviation which is known as cluster STD equals to 0.60, and random state equals to 0. But what is random state? Random state is basically determines random generation for dataset creation, right? If we do that, and then we are going to see what actually dataset we have made. For that, we are going to use a data visualization tool, which is Matplotlib. We are going to use for this particular purpose, and we are going to use a graph, data visualization for dot scatter. So we have written plt dot scatter, and then we have provided our data. If you just look into it, you can see this make blob is total 5 clusters we have, the different data points you have. Now using k-means, you need to understand how you can actually make them in 5 particular clusters. Now what we need to do, as we have seen, we have 5 different clusters. By looking at the dataset, we can say next make an object of k-means along with the providing number of clusters, train the model and do the prediction. How to do that? We are going to call k-means function, which is basically where our k-means algorithm is implemented. So in this case, you can see we have used a variable called k-means, and we have written k-means and the cluster equals to 5. So we have 5 cluster. Now we have written k-means dot fit x. So whenever we are going to use dot fit function, it's nothing but it's actually you are going to train your model. Then what we are going to write, we have written y k-means equals to k-means dot predict s. So in this part, we will try to predict our k-means, the x. If we do that, the plot and visualize the cluster center peak by k-means Python estimator. Now if we just try to understand the what actually our model has done, in this case what we need to do, we are going to use that plt dot scatter plot again. Here, if you can look over here, you can see that we have written centers equals to k-means dot cluster centers, right? So in this case, you can see what we have got. We get all the centers of the cluster, and total cluster we have total 5 cluster. So this is a very basic example of k-means clustering, how you can start up with by starting with make blobs, and then try to give centers and feed your model with k-means, and then try to find it out all the different cluster in your data set. We are going to do one more example of k-means using a data set. But that dataset we will actually load from the scikit-learn library itself, right? So here also we are going to use Matplotlib, Seaborn, Numpy, and scikit-learn. So here what we have done, we have load the digit dataset from sklearn and make an object of it. Dataset is having basically 1797 samples with 64 features, right? So let's have a look at how can you load the dataset from the library itself. So for that, we are going to import from sklearn .datasets import load digits, right? And digit equals to load digits, right? So if you do that, then you can see your dataset will be already imported. Not even imported, it's already loaded, right? So now if we just try to understand digit.data.shape, what is your shape of the data, that time you can understand your data.shape is 1797 rows you have and 64 columns you have, right? So we use .shape function to understand our data. In this case, there are few columns will be there, the images will be there to understand our data. What actually we want to do with this? We just try to understand what are the digit it is. So basically, we will try to segregate the digit 1 to 10, right? Using this data set. Now, if you want to check this, if you want to check this out, you can see this is nothing but numpy.ndarray. Right, the data is type of numpy.ndarray. Now what we need to do, we are going to do the same thing. We are going to call k-means clustering. Here, how many clusters we will have? We will have 10 clusters, 0 to 10. So total number will be 10 clusters, right? So the number of cluster will be 10 and random state equals to again 0 we have used. Now what we need to do, we need to train our model. How to do that? Clusters equals to k-means dot fit predict then digit dot data. So why we are using dot data? Basically, it's going to give you all the data itself. right? And after that, if we just try to understand the shape cluster centers dot shape, that time it will show you that 10 clusters with 64 features. If we do that, you can see this is 10 clusters with 64 features. As we have said that our total cluster will be 10 and the feature will be 64, right? As we have 64 columns. Now, if you just look over here, what we have done, we have used few data visualization technique to understand our data. In this case, we use fig and ax plt.subplot. It's basically we will have different plots in one plot, right? And after that, we have written k-means dot cluster centers dot reshape, and we have reshaped the cluster centers to 10, 8, 8, right? Then what we have done, we have just used dot imshow. This imshow basically we used from Matplotlib to actually see the images, right? You can see these are the images we got. We have 4, 3, 1, 1, 9, 0, 7, 6, 5, 1. This is your data set, right? With the match the learned clusters labels with the true levels found in them. Okay. Now what we need to do, we are trying to do a stats. We will try to do some statistical visualization. So in this case, we have imported scipy.stats import mode. Right now, what we have done, we have just written np.zeros like clusters. Then we have just used a for loop to check like what is the mass, what is the label, what is the data set, right? After that, what we have done, we try to understand the accuracy of our model, how our model is going to work, right? So in this case, we have used accuracy score from scikit-learn. So we have written accuracy score and then digit.target and your label. So basically what we are doing, we will try to give our data, not the label, right? So as we don't give the label, so when we try to predict, that time we understand what label our model is going to predict for this information. If it's correct, then obviously it will be counted as a correct one. Then the accuracy score will be high. So in this case, we did the same thing. You can understand our accuracy score is 0.795. So basically it's nothing but 79.5%. So near about we can say it's 80%, right? So our model is working pretty fine, but you can use this particular concepts with different data sets as well. It's a very basic data set to start with for k-means clustering. In this part, we are going to use a mall customer data set to do the k-means clustering, right? So we will try to cluster the same type of a customers according to their maybe income and spending score, right? So before starting with the project, let's have a look at the data set, what we have in the data set. If we just go to the data set, you can see this is our data set, right? I have taken this data set from Kaggle itself. So it's a free open source data set. Basically, anyone can use it. Okay. So here you can see we have customer ID, the genre, that is the male or female, age group, right? We have annual income, total in dollar, right? You can see the total annual income and the spending score that we have. Right? So if we look at the data, basically we talked about the data set without label and with label. So in this case, you can see in this data, there is no label. So basically our k-means clustering is trying to cluster the customers according to these informations, right? So this is pretty much about the data set we are going to use for this project. And let's have a look at how we are going to do this in k-means clustering. So we are going to again use Numpy, Pandas and Matplotlib and Seaborn. Right? So we are going to use pd.readcsv function. As we know, we use this function for reading the comma separated value, that is your .readcsv. And if you are new to the Google Colab, you can see here is an option to upload, right? From uploading session storage. But be sure the session storage will stay for 12 hours. After that, everything will be deleted, right? So whenever you are going to use Google Colab, try to save your data in your or mount your data, right, with Google storage itself. Now comes this uploading data. If you click over there, it will directly automatically take you to the uploading part from your local system, and from there you can directly upload your .csv file. Now you need to have the copy path. So where will I get the path for this particular data set I have uploaded? If you can look at this sign, if you click over here, you will get the option of copy path. Right? So for after that, pd.readcsv, and you need to give your path, right? Your path is content / mall customers.csv. right? So now you can see if I just do this, the data set will be already stored in the data set. The variable called name is data set. Now if you want to check is your data set is stored or from the .csv file or not, you can go for using .head function and .tail function. So what is .head function? So .head function is basically going to return you first 5 rows of your data set, right? So data.head. So if you look at here, you will get the customer ID, genre, age, annual income and spending score, and your data is already uploaded, right? Your data is stored in dataset variable, which is a type of data frame. Now we are talking about the tail as well. So basically if you just write dataset.tail, right? So if you just do that, in this case, what you will get the last 5 rows of your data set, right? You can see 199, 198 like this. Now if you want to check the shape of your data, how many columns you have, how many rows you have, you just need to write dataset.shape function, right? If you just write dataset.shape function, it will return you the total number of rows and columns in your dataset. So for my case, 200 rows I have and 5 columns I have, right? So now we are going to do the dataset.info. So what is dataset.info? It's going to give you the information about your dataset. What type of information it's going to give me? So basically, what is the data type of your each column? Do you have any null value or not, right? So these are the things you can understand by using .info function. Yeah. After that, we have one more function called .describe function. But why do we need .describe function? We need .describe function to understand the few statistical terms in our dataset, like the count, what is the mean of your data, like for each and every column, what is the standard deviation, what is the IQR interquartile range, right? We basically divide our dataset into 4 parts, right? 25 percentile, 50 percentile and 75 percentile, right? So IQR is basically taking the third part of the leg, that is known as third quintile, and the first quartile, right? So basically we use these two to calculate IQR, right? So basically these are the basic statistical term you need to know when we talked about like our data set. So that's why we use .describe function. After that, if we need to check is there any missing value we have in our data set, but why do we need to check it? We need to check it because if we have missing value and if we do the prediction with this missing value, our data is not at all perfect to go for a analysis, and if we do that, we will get a very bad result. We will end up with a very bad prediction that we don't want, right? So that's why for the precaution, we always try to check what is the outlier. Do you have any outlier in the data set? Do you have any missing value in the data set or not? So in this case, we are going to use a function called .isNull function, and then we have written .sum. So basically we are going to check if is there any null value we have in our data set. Is if we have that, what is the number of that? Then you can see the sum of the null values is 0. So we can see we don't have any null value in our data set. Now if you want to check what are the columns you have in your data set, how to do that? In this case, you need to use .columns function. If you just write dataset.columns, you will get all the column you have in your data set, right? So now we are going to do the clustering based on the annual income and spending score. So we will try to use annual income and spending score, right? Not the age and the customer ID is not needed anyway. The genre and the age, maybe we can do. Let's see, maybe in the first let's try with the annual income and spending score. What is the annual income and what is the spending score, right? So in this case, how to take it? We just use this, like if you want to take 2 particular column from your data set, you need to do this like this, like not the 2. If you want to take many, so that time also you just need to use this particular technique, right? So in the data, what we have now, if we just look at the data, we will have 2 columns. One is annual income, one is spending score. So if you just try to understand your data shape, in this case, again, you will get the same thing, right? So 200 columns with, just let me do that, data.shape. Okay, so if we do that, you can see we have 200 rows and 2 columns. Now I just want to only the values, not the column name. That time you just need to call .values. You will get all the values, not the column, right? You can say this is your value. Now, we always assume the max number of cluster. Now we will do the clustering. So we always assume that the max number of cluster will be 10. You can judge the number of cluster by doing averaging. But in this case, we will try to find it out what is our K for this particular data set, because we don't want to take any random assumption for that. Maybe you can do that, but in this case, if we just use this particular elbow method to understand the K value, let's have a look at now. So in this case, we are going to import K-means. We will going to calculate the WCSS, and for I in range 1 to 11, we are going to say, like from 1 to 11, why we basically try to take 0 to 10, the 10 clusters, right? So we have written K-means underscore clue equals to K-means in cluster equals to I, right? So your I will go 1 to 11, okay? And this part maybe you can skip as well. So random state equals to 42 for 56, and then we will feed our data. So if we do that, and if we just try to plot our elbow method, you can see it's actually showing it's the elbow is the 5, right? So 2, 3, 4, it's not there, the 5 one. So in this case, this curve is telling you that the elbow comes at K equals to 5. So that matter the range we select, that's why 1 to 21 also will say the same behavior, right? So basically we try to understand this particular elbow in the curve to understand our K value. So in this case, the curve it comes from 5. Now what we need to do, we are trying to do the K-means clustering that we have done so far. So we know our K value. So we actually prefer to like finding out the K value. Otherwise, maybe you need to start from 1 to 10 to understand which one is working for you. We don't want it, right? So in this case, we are going to use elbow method. So this elbow method is basically helping us to start with K value. Now, as we see, the K-means, we are going to call the function called K-means and cluster equals to 4. Here we are going to write 5, right? So as we can see, its cluster equals to 5. Now the random state equals to 42. Maybe you can change it accordingly. It's just randomly changing your data. All right. And then we are going to use k-means dot feed predict x. Right. Now, as we have done this part, right? So now we try to visualize our data. How to visualize our data? We are going to use a scatter plot, and there we are going to use this. We have actually give some different colors to show our data. Right, we have pink, yellow, red, orange, magenta, right? Maybe something else, maybe you can give green as well. Maybe we are going to give green. So you have total 5 cluster, right? And the centroids we have given, that is yellow. No, which will not work. So in this case, maybe we can give the centroids will be orange or violet. Maybe it will highlight it. Yeah, you can see, right? So in this case, what we have done, we have used 5 clusters. We have 5 cluster that we have talked, and their K-means dot clusters, and we have used the centroids. We try to find it out as centroids as well, and we give the centroid color is violet. So if you look at this, you can see there is a 1, 2, 3, 4, 5 clusters, and they try to separate the data points as well. This is the cluster 1, 2, 3, 4, 5. So cluster 1 is pink, cluster 2 is this one, this yellow one, 3 is red, 4 is again yellow, and 5 is green, right? And these violets are the centroids, right? So this is how our clustering, K-means clustering works when we don't have the label in our data sets, right? I hope you like this particular demo, and we have covered all the things like we have talked about what is supervised, unsupervised learning, what is machine learning, and then what is like clustering, the types of clusterings we have, and also we talked about the in-depth in K-means clustering, and we have done almost 3 demo, like the basics of K-means, then using a very basic data sets of K-means data, like like the digit data set to do the K-means demo, and lastly we did, right, let me just change the name of it, so small customer clustering. Okay, so basically what we have done, so lastly we have used a small customer data set to do the clustering, right? So yeah, this is pretty much about the K-means clustering we have learned so far.
In this part, we are going to talk about regression analysis in data mining. As we already know, regression is nothing but the part of machine learning. We have talked about what is machine learning, why we need machine learning, and also we have talked about how can you build a model in machine learning. Now we are going to look into one particular topic in machine learning, that is regression analysis. In this particular part, we are going to talk about so many things, right? Like what is regression, what are the types of regression we have, and we will see in the agenda. So basically, this is one type of a data mining technique by which you can actually understand your data in a much better way. So you can totally understand data mining is nothing but how can you mine your data? How can you get lots of information from your unstructured data? How can you make those unstructured data in a structured manner, right? So let's go and let's have a look at the objective we have. First, we are going to talk about what is regression. Yes, what this term stands for, how it's going to help us in order to do the data mining. Then we will see some of the use cases of regression, how regression is actually making the meaning to mine the data. Then we will see the types of regression we have. Then what is simple regression? Yes, now under comes of types of regression. We have simple regression and multiple linear regression. We will talk about both of the type of the regression. Then we will see how regression works. So there is a whole understanding or end-to-end understanding of how regression works. Then we will see how can you implement regression using Python, and then we will do a salary prediction using Python and Uber data analysis to predict the cab fare. Yes, we will do a total demo to actually understand regression. How can you implement them in Python and using two different data set which can actually help you to again understand this particular concepts called regression, right? So let's start with what is regression. So first we are going to talk about what is regression. So regression is basically nothing but a technique that predicts the value of variable y based on the values of variable x. I can understand it's basically nothing but it's confusing, right? What type of variable x and y we are talking about. I will explain you everything, the maths behind regression as well. And this is very simple, trust me. And if you really like the video, do not forget to like it, and do not forget to like and subscribe Great Learning. And if you feel this is going to help you to your peers, your classmates, please do share this video with them as well. Alright, so let me tell you what is regression. So in the case of this, you can understand we do have two types of variable. One is dependent variable, one is independent variable. We will talk about variable later. But before that, let me give you a use case example for that you understand what actually I want to mean by regression. So regression is nothing but who can help you to find the relationship between two different things. Suppose we have an example of as the winter comes, we try to put on jackets, right? So in that case, what we can say, as the winter comes, we used to buy more jackets. So yes, there is a direct relationship between sale of the jacket with the weather. Yes, finding out this type of relation is nothing but your regression. So we can see here as the temperature drops, sale of the jacket increases, and we are getting a relationship between them. Right, now we will have a look at one more thing. So you can totally see that regression is nothing but if you think there is a relationship between two things, then the regression will help you to confirm it, right? Now let's go and move forward to the another example. Suppose as the temperature increases, right, as the summer comes, what we do, we used to buy lots of ice creams, right? Because we love to have ice cream and it's cold, right? So yes, you can totally again understand there is a relationship between summer and the ice cream van. So as the temperature increases, number of cones sold at the ice cream stores also increases. So there is a direct relation between both of them, and regression will help you to confirm that, will help you to find that yes, there is a relationship between these two variables, right? Yes, this is pretty much about regression and how regression help us to find out the information from the data. You can totally understand how regression is helping us to get the idea, okay, there is a relationship between these two particular variables using regression technique. Now we will talk about what are the type of regression we have, and then we will see how we are going to do this particular regression technique on the data set, using the data set, and how it actually help you to do the regression analysis as well, right? So what are the type of regression we have? There are various types of regression we have, like linear regression, logistic regression. We talk about multiple linear regression, right? So there are types of linear regressions we have. So in this particular case, we are going to talk about linear regression, right? So linear regression is a type of supervised learning. So we talked about type of machine learning. What are the type of machine learning we have? Basically, we have three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So we know what is supervised learning, right? So supervised learning is nothing but where you have the labeled data set. So I will show you again what labeled data set I want to mean by, right? So linear regression is a type of supervised learning. Now we are going to talk about used for finding linear relationship between the dependent and independent variable. Now let me give you one example. We have y equals to mx plus c, right? That is nothing but, again, this is a straight line formula. While we have y equals to your dependent variable. So when we are going to write in x plus c equals to y, so you can understand x is nothing but your independent variable. We will see the elaboration of this particular formula later, but yes, I can just give you a heads up on this. So linear regression works on y equals to mx plus 3. Right? Now, this help you to find the relationship between two or more continuous variable. Yes, if you have a continuous type variable, right? Suppose your salary is a continuous type variable. Suppose is your Uber care, like Uber cab prediction is again cab fare prediction. Fare is a continuous variable. But when you have a discrete variable, that time you cannot use linear regression. Right? Yes. So this help you to find the relationship between two or more variables. That variables will be or should be continuous type variable. Right? So yes, this is pretty much about what is linear regression. Now we will have a look at what is multilinear regression. So guys, if you have any doubt, do not forget to let me know in the let me know in the comment box. For that, I can give you the proper or I can just solve your doubts. We will happy to do that, right? Now we will see what is multiple linear regression. So multiple linear regression is nothing but an extension of linear regression. Yes, so if you have simple linear regression, from there we have multilinear regression. It helps to find the relationship between more than two variables. When you have more than two variables, suppose you have y equals to mx1 plus mx2 plus mx3 plus c, right? So in that case, this comes under multiple linear regression when you have more than two variables. As we know, in simple linear regression and was actually has one predictor and one response variable, but have a good look over here what I am saying, and it's actually a very good point or the main essential point or the difference between simple and multiple linear regression. So in the case of multiple regression, you have more than one predictor, but response variable will be one.
right? So this is what stands for multiple linear regression. Now we are going to talk about the two type of linear regression we have talked, right? So you can see here the single predictor we have for simple linear regression, and for multiple linear regression we have multiple predictor, right? Can you see over here? And what I have said over here, this will be more than one predictor variable but one response. You can see the y will be one, but the predictor will be multiple in the case of multiple linear regression. Now, if we talk about the formula, then for simple linear regression, we write y equals to mx plus c. That is nothing but our simple straight line formula. I hope you have already idea about what is this y equals to mx plus c. Y is the dependent variable, x is the independent variable. So these things you have to keep in mind very carefully, and you have to have a very good idea about it. Right, as we already said, as a data scientist or a data mining engineer or a data architect, the basic pillars you need to have, that is statistics, you need to know the basics of linear algebra, and you have to have an understanding of one programming language, and then you have to know, how to read the data, how to understand the data. So yes, this particular mathematical part, little bit of mathematical part comes into the picture when we do this type of concepts, right? So now we are going to talk about y equals to m1 x1 plus m2 x2 plus m3 x3. So while we have multiple linear regression, right? So in this case, what we need to do, we have different type of different independent variable, like your predictors, that x1, x2, x3, but your end reach will be y, that is your dependent variable, right? So I hope you do not have any doubt regarding this particular two equation we have for two different linear regression, but this multiple linear regression obviously comes from simple linear regression. All right, now we are going to talk about how can you understand simple linear regression. So we have dependent variable, we have independent variable, right? Can you see over here? And from there, we try to conclude a relationship between them, right? Now, if I just move forward, we have two observation, right? So your x1, x2, x3 will be your observation. From there, you will try to find it out a relationship between these observations, right? Now you have multiple observation, right? Can you see? Yes. From there, you will try to find the regression line using that particular formula y equals to mx plus c. So from this particular, using y equals to mx plus c or y equals to mx1 plus mx2 plus mx3 dot plus c. So basically it's from simple linear regression or multiple linear regression. Using the formula, you will try to find a line, right? Which is nothing but a relationship between the two different variable or more than that, right? And using that, you will find a regression line which will predict the future values, right? So here you can see we will try to find the regression line, and we will try to find the minimize the error between the predictor, predicted value and the actual value, right? So in the red you can see this is your estimated value, and you have in the blue you have the actual value, right? So this is the line we have. We will try to find it out that okay, this line will be as less as you can, because the error will be that less, right? So you can see the actual value and the predicted value is really different from each other, and the goal is basically minimize the error. The distance between the actual and the estimate value should be less, right? So yes, by using the formula, we try to find out the relationship, and we try to find it out that this particular regression line which will predict the future value points, right? So yeah, this is what about simple linear regression, and with the observation we have done. As we have understood this particular concepts in a mathematical way,
Then we will try to do these things in Python using different data set, trying to understand different way of doing that. And also we will do a simple linear regression in Python without any data set in order to understand how linear regression works, right? So, okay, let's see what we have next. Yes, we have the demo. How can you implement linear regression using Python? In this particular part, we are going to talk about simple linear regression, right? What is simple linear regression? We have talked about that. Now we are going to implement simple linear regression using Python and using Python library in our Google Colab, right? So if you do not know about Google Colab, please do check out the video on Google Colab. So this is nothing but an IDE we have in Python. I mean, for just to do code in Python. So this is provided by Google, right? So now we are going to talk about how can you import packages and classes. So here hardly we can import classes, so we can focus on the packages. So we have talked about Numpy. Yes, so we have talked about Numpy and we have worked with Numpy a lot in our previous modules, right? So in this particular case, again, we are going to import Numpy as NP. So again, guys, there's a quick question for all of you. If you have actually watched the previous part, you know why we use as NP. So a quick confirmation from all of you why we use as NP, right? Please do let me know in the comment section. For that, we can understand you guys are properly following us, right? And we will like to see all the comments from all of you that you are actually getting, getting to know new things from us. It's always inspiring for us to make new content for you. Okay, so we have two types of variable here. You can see we have independent variable and dependent variable. So dependent variable is dependent on the independent variable, right? That the name suggests and we all know. Now we are going to use a particular formula that we have said y equals to mx plus c. But we don't need to use or we don't need to do it from the scratch because we have scikit-learn in Python. So what is scikit-learn? Scikit-learn is nothing but a machine learning library we have in Python where we have all the algorithm implemented previously, right? You don't need to write a program to, implement a particular algo in machine learning. What you need to do, you just need to, call the particular function and you can just make your work done, right? So the first, first variable x, we are going to initialize that using np array. So we have written np.array and then we have given 25, 35, 45, 55, 65 and 65. And we given for y viewpoints, that is 5, 20, 14, 32, 22 and 38, right? Now I have just printed. So printing x is 25, 35, 45 and y is as follows. Now the input is x and output is y, right? What I have done over here, but we have used dot reshape function. Why we have used dot reshape? Why do I need to reshape my x? So on x, because of this array is required to be two-dimensional, or to be more precise, to have one column and as many rows as necessary. So what we have done, we have reshaped our array -1, 1. Right? So if you just print x, you can see this is what we have changed the dimension for x. Now, if I just write x dot shape, it's 0 and 1. You can see, yes, this is how we have changed it. Now we are going to create a model to have an understanding of linear regression. So we know linear regression follows what formula? I have said so many times. Again, a quick question from all of you. What formula or what basic algebra or, you need to know, to do the linear regression? A quick understanding from all of you again in the comment section. What is the okay, let me tell you what is the straight line formula we have talked about so far, right? How can we do that? what is that formula? Let me know in the comment section, and then again pause the video and then again start it, because I want you to be more attentive in this particular while you are doing these things, and you have to understand what you are doing. Right? So yes, for your answer, we use y equals to mx plus c. For all the data points you have, we try to understand y, right? So you have x, we try to find it out y. So we have done x and y. Okay. So now in the case of model equals to linear regression, we have done. So you don't need to write it from the scratch. So already linear regression is implemented in scikit-learn. I have written linear regression. So basically I am calling that particular function. So I have created an object of model, and model.feed is while we are going to train your model. We talked about in machine learning, we first need to train our model, then we try to find that how our model is working with the new set of data set. But here, as we are doing the very basic things, first we will try to find it out. First we will do the training, and then we will try to find it out how our model is working. Right? So we have written model.feed x comma y. Right? So you have just said, please get trained my model with the data points I have in x and y. Right? So let me execute that. Yes, you can see the training is really done because the data set you have, it's really less, right? So once you have the model fitted, you get the result to check whether the model works satisfactorily and interpret it, right? Now I have done the R square. So if I just go back to the presentation and I will just show you how to find it out, how your model is working. So we have came to the presentation. Now you can see we have done this particular regression line. Now we want to check, okay, our model is working perfectly fine or our model are giving some error. In order to check that, we use R square method. So R square is basically like used to understand how your model working and how much error you are getting, right? So yes, so in that case, we will try to understand our R square in order to see how our model is going to work. So let's go back to Google Colab and let's see how it's going to work. So to do that, we called a function called score. So we have used model.score and we have given our data points, that's x and y. So while we are going to give that model.score x and y, we get the output that 0.7158. So in precisely, we can say our model is working 71% accurately, right? So yes, there is a lots of scope we have where we can increase this particular number. But again, as we have a small data set here, it's a very basic demo. This we can say the model is working with the 71% accuracy. Now we have intercept. How can you understand the intercept? So in order to get the intercept, you have to call the again dot intercept underscore, right? You will get your intercept for the model. Then you have slope or coefficient. Again, to understand that, you can write model dot coefficient, that's COEF underscore, you will get the coefficient. These are the, the basic, and you can say these are the core part to understand. That's why we have talked about. Now, if we try to predict the values from, predict the values of y, you have to call model.predict and you just need to give x, right? So you can see what you have get over here. So if you write, let me show you, this is really interesting to work with. Okay. Now, if I just write print here actual values, right? And if I just write y, okay, so you will have the actual value, you will have the predicted value. Okay, so as we have written that y predict equals to model.predict x, so for the y prediction you get 8.3, but the actual is 5. Then you get 13.733 while the actual is 20. Then you get 19.13 while the actual is 14.
right? So yes, there is a few changes here and there you have. That's why the accuracy is 71%. The more data points you will have, the more your data will try to, or your data will understand, or your model will understand more precisely, right? So yes, this is the basics of linear regression we have done. Now we will see one demo of multiple linear regression, and then we will jump into the project, and there I will show you how you can understand your data, the thing we have done, the visualization of data, how can you do that, everything we will talk about that. I think you are also excited like me to work on these particular projects. Please do let me know in the comment section, and I will happy to answer all of your doubts, right? And if you like the video, do not forget to like it, and if you feel like to get updated with the new content we are going to release, do not forget to subscribe Great Learning, right? So yes, if you feel again this video is going to help you to understand the basics of data mining, basics of machine learning, please do share this video with your friends as well, right? So let's see how can we do the multiple linear regression using Python, and also obviously using the libraries, right? So let's see how we are going to do that.
Now we are going to do demo on multiple linear regression, right? So we have already talked about what is multiple linear regression. When we have like data points, like the independent data points, more predictors, right? That time we go for the understanding of multiple linear regression. If you have any doubt, do let me know in the comment section for understanding of multiple linear regression. Now we will actually implement this multiple linear regression concepts in Python. So the first and foremost things we need to do that importing packages, because we are really pretty much dependent about the packages. So we have talked about Numpy, and I have already given the introduction to scikit-learn. Scikit-learn is basically nothing but we have this particular library for implementing already implemented algorithms for machine learning, and we just need to call them, and we just need to call the function basically, and we can ready to use, right? Yes, so this is pretty much about why do we need scikit-learn. Now we are going to just declare our variables, and from there we will try to use this particular concepts of multiple linear regression. So we have x and y, right? I have just zoomed it for your understanding. If you feel like you are not able to see, that's why. I know this letters are really small. I don't have any option to increase the fonts. So here we actually write x equals to 10, 21, 5, 18, 15, 24, 25, 26, right? We have do 1. We have just declared the list of list. So total one list we have, and then we have multiple small lists. So here y is our what? It's like nothing but our independent, not independent, it's a dependent variable, and x is our independent variable. Now if I just want to print x and y, you can see x is nothing but the list of list, and y is okay, let me just do that. Okay, so x is nothing but our list of list, right? And y is our again the list. So suppose if you just want to print the type of x, so how to check the type of any variable? We need to use type function for that. Yes, so yes, this is nothing but class list. Now if I do the same thing for y as well, type of y, this will be again your list. Now in multiple linear regression, x is a two-dimensional array with the list 2 columns, while y is usually a one-dimensional array. This is a simple example of multiple linear regression, and x has exactly 2 columns, right? Yes, so that's why what we have done, we have just used x and y to np.array. Now if I just print x and y, after we converted them to array, this will look like, right, x and y. Now we are going to do the last, not the last, first then we have done we will call our model, then we will train our model. After training our model, what we will do, we will try to find out the result, how our model is going to work, right? I don't want to do this at a time. I just want to show you how we are going to do that. So again, we are we have written the variable name model equals to linear regression. So we have called our algorithm, that is linear regression, from scikit-learn, right? Then what we are going to do, we are going to write model, right, dot fit. So why we use fit function? You can see over here, fit linear model, and we have few parameters like array like sparse matrix of shape, like for x and y, right? So if you want to know more about these particular functions, this, just click over, like write it and just click over here, it will show everything about that function from the documentation. Right now, if I just write x comma y, so I have given my data to get trained and to get train my model, right? So let me do that. Yes, can you see it's already trained? So why it's taking less time? While we are going to use a data set, it's obviously going to take more time. The more data you have, the more it will take the time, because the compiler also needs to understand the data points, and they also need to understand how these data points are uh, connected with each other, and trying to find it out the relationship between them, right? So we actually just calling the function and that's all, but that's not all at all. In the background, we are doing lots of things, like the library itself, it's doing a lots of things to understand these data points, to get a relationship between them, and also predict the future as well, right? So yes, using machine learning, we know we can predict the future, but that's not that easy, right? You have the data, understanding the data, from those data finding out the relationship, and then find out the future. It's really time taking, when and like while we will have a lots of data, right? For this basic purpose, maybe we are just using an array for your betterment of understanding. But yes, after that we will do few projects like salary expectations based on the experience, and also we will do the Uber cab fare prediction, right? I hope you all are actually excited to do that, and please do let us know what else you want to learn from us. And if you like the video, do not forget to like it. And if you feel like you want to get updated with the new content we have from Great Learning, do not forget to subscribe Great Learning, right? So now how we are going to create the model, that we have done. Now we have already trained our model using the data set. Now the most awaited part, the getting results and trying to understand how our model is working, right? So I have written R square, right? R square we use to understand what is the error percentage we have, and also what is how your model is working. Okay, so in order to do that, you have to call the function called dot score, and you have to provide your data set x comma y. So your model is working with the 79% accuracy. That's pretty good, right? Yes, so this is how your model is working. Now if you want to see the intercept, you have to call dot intercept, and then underscore. You will give the intercept for your this particular y equals to m1x1 plus y plus m2x2 plus m3x plus m3xt plus c, right? So here we will get the intercept. Now if you want to get the slope, again you have to call dot coefficient function, right? Now last but not the least, we will see the predict response, how your model is going to predict the y while you are giving x, right? So we will call the function called model.predict, and we will give x. Okay, so here you can see this is what we have given, and we will do a really interesting thing after that. So you can see y prediction will have all the predicted value according to x. Now what I'm going to do, I'm going to print actual value, right? And also I am going to write y. Then I'm going to write print predicted value, and we will write what y print. Okay, let's see how actually it works. Okay, So your actual value is 4. For the case of first one, it's showing 10.87. So yeah, you can see this is pretty much near to them, but there are few different numbers we can see over here. That's why your accuracy is 79%, right? So yes, this is pretty much about this multiple linear regression. I hope you understood this, how to implement simple linear regression, how to implement multiple linear regression, and the most awaited part. For this next part, we are going to do a salary expectation based on the experience. I will show you the particular, uh, data set as well, and how you can understand what is a continuous value data set, how you can understand what is how to like use linear regression based on the data set. We will talk about that, and for that you have to keep tuned to the last till the last of the video, and please do let us know your comment on this particular part, right? So let's see how can we do the most awaited project of salary expectation based on the experience. So now in this particular part, we are going to do the most, wanted part, that salary expectation based on experience. That's nothing but a project we are going to do. The first, before doing that, I will show you how to understand the data set, and from there, how can you start your project building. So guys, what are things I have said while we are going to say it, okay? We are going to make a project. So first thing that comes into our mind, we have to understand our data set. After you understand your data set, you have to go for cleaning your data. But no, there is one more step that we have just forget. That's not acceptable. That your problem statement. You have to understand what is your problem statement. To understand, after you understand your objective, you can proceed with understanding the data. First, you need to collect the data, and from there, you have to go for clean your data. After you clean your data, you will go for exploratory data analysis. That is nothing but few statistical terms. From there, you will understand your data more, and we will use few mathematical understanding and also machine learning algorithms understanding, which will actually go with your data in order to make a model out of it. After you do that, you will train your model, and after you train your model, you will give a new data set to understand how your model is working. If your model is working fine, you will go and deploy it. But in this part, maybe we are not going to talk about the deploying part, but yes, till before that, understanding the data to predicting your data set, like predicting your model, how it's working, we will do everything, right? So I hope it's quite interesting for all of you, and you guys are really excited to do that. Okay, so in this case, first we need to understand our data. So I have taken this data from Kaggle to do this particular project. So yes, this is the dataset. We have taken salary.csv. So let me show you what is this dataset and how you can understand that what type of dataset you are going to use while working with regression. So as I have said, regression works with only the continuous values. Now I will show you this particular dataset, salary.csv. Here we have only two columns, right? Let me make it big. Okay. So we have a year of experience and salary, right? Maybe you can work with more complicated data, but here we have get the basic data from Kaggle. So here we have seen that if your experience is 1.1, then your salary near about 239343, right? Or if your experience is 1.3, then 46,205. Okay, these are based on your experience. So you can see the salary column we see the label data set, right? What is label data set? So in order to say the label data set, your data can be continuous data, or your data can be distinct data. So now we are not going to talk about the discrete data in order to talk with logistic regression. Maybe we will talk about that. But in the case of linear regression, we use continuous value data. So you can see we have 39343, or you can say 37731 or 43525. All of them are nothing but your continuous value. From there itself, you can understand you need to go for regression analysis, right? So regression always work with continuous value data set. So guys, if you have any doubt in order to understand what is continuous value data set, please do let me know in the comment section. But I tried my level best to make you understand what is continuous value data set. Well, we are going to do the Uber cap fare prediction. Again, I will show you what is continuous value, right? So yes, continuous value, the name itself saying there will be a continuous type value, right? Yes. So while you are having this, you can say, okay, I can go for using this particular data set for regression. Now let's go back to the code file and let's see what we have done. Right. So here what we have done, we have actually imported the packages. So we have imported pandas and numpy. So we know why do we need numpy, why do we need pandas. Then we have matplotlib and seaborn for the data visualization, as we already knew. So here I just want to show you one thing. If you want to upload the data set in Google Colab, you have to click over this particular button, and from there you will get option of upload to session storage. You can directly, if you click over there, it will redirect to your local system, and you can actually upload the data set you want to. So in this case, I just upload this particular data set, right? So that is salary. Okay, so you can do that. I hope you don't have any doubt on Google Colab. If you do have, please do check out our video on Google Colab, right? So I have imported pandas numpy, I have imported matplotlib seaborn, and now we are going to read CSV file. How can you read a CSV file? We have called .read underscore CSV from pandas. Yes, we can read lots of type of data set or data description, whatever it is. If you want to read using pandas, you can do that. There are a lot more function they have for that. Now I have written pd.read CSV, then I have given the path. How can I get the path for the data set? Let me show you. Don't be panic for that. Everything is super easy with Google Colab and also while you are working with Python. So you can see that salary.csv you have. If you click on this three dots, if you click over there, you will get an option of copy path. You just need to copy the path, and here you just need to paste it. It's that easy, guys, right? There is no such thing you have to do like so many ways to understand the path. No. Right, so we have written pd.read CSV and we have given the path, and our data will be stored in a data variable. Now if you just want to see your data is loaded or not, what we use one function called .head. What .head does, as the name suggests, it's going to give you the head portion of your data. So what is the head portion of your data? In default, it is going to return you the first 5 rows from your data. So data.head. Okay. Right, you can see this is particularly data.head, and your data is uploaded to, or you can say loaded to data variable. Now if you want to see the last 5 variable, like last 5 rows from your data, you can write data.tail. Right, it will show you the last 5 rows from your data. So total maybe data you have 34 records you have, and yes, this is the last 5 rows. Now we will see few things. Now if you want to see what are the columns I have in my data set, a sudden question pop up in your mind. So yes, it's not a sudden question. Again, to understand your data more precisely, we need to understand what are the columns we have, what are the continuous value we have, and what is the data type of all the columns. We will see how we can do that. Also, we will have a look at the cleaning data in order to clean the data, the null value. Oh my god, there are a lot of things. So yes, to understand all of the things one by one, you have to keep tuned to the last of the video, right? And if you like it, again, do not forget to like the video. Do not forget to subscribe. Great learning. So we have used dot columns. So data dot columns is going to return you all the columns you have in your data set. If I just do that, What are the columns we have? Just two columns we have for this particular data set. We have years of experience and salary. Now let's check the dimension of that data set. What is the dimension we have for the data set? So in order to get that, what will be my answer? We have to use data dot shape, that 35 comma 2. So you have total 35 rows, right, and 2 columns. Okay, yes, this is how your shape is going to return you. So dot head already we have done, and now we are going to use data dot describe. What describe does? So describe is going to give you the total count of your data. Then what is the mean value, right? Maybe in the case of year of experience or in the case of salary, what is the mean value you have? Then we go for standard deviation. That is in statistics one of the most used term. Then we have interquartile range. Maybe it's a 25%, maybe it's 50%. We have talked about IQR, right? Yes. Then it comes to 75% and max value you have in your data set. Right, so we use dataset in order to understand our data more precisely. Now we will go for missing value detection and treatment. If you have missing value, then you have to go for understanding the where you have, and you have to remove them, or you just need to replace them with mean or median, right? So the following values in the dataset are considered to be missing value. What are those values? Blank values, or if you have nan value, or if you have null value, right? Or one more type of value, that is some continuous columns, right, have zeros to indicate missing data. Let's see, do we have something like that? If we have something like that, then we have to have a good treatment for that for our data set, right? So in this case, we have written data.info. It's going to give you the info about your data set. So my year of experience, and there is no null value, and the data type for this row 64. And for the salary, we have 35, no null value, and the data type is integer 64. Now, if we want to check again to make sure that do we have any null value, we have to use one function called data.isNull. If you write data.isNull, you can see that for each and every rows it's giving you false, false, and true, right? But I don't want to see like that. I want to see, do I have any null value? Please show that, right? So in this case, what we have written data dot is null dot any. If you have any null value, it will return you true. Otherwise, it will return you false. So now we do not have any null value. That's why it's returning you false. Now, if you just want to see the summation of the null value, how you can do that? In order to do that, you have to write data.isNull.sum. Right? So summation will give you, do you have any null value? It will only give you the summation. So you can see the year of experience, the null value is 0. The salary is 0. So basically what we can say, we can easily say it, we don't have any null value in our data set. Now, if I want to visualize my data based on salary and year of experience, as we have only 2 columns, but most of the cases you will have lots of columns to again understand your data more. So what we have done, we have written plt.plot, and we have given x and y, that data of salary and data of year of experience. So you can see this is what we get as a year of experience and the salary, right? So you can say for 2, this is near about to 40,000. While you are having a more experience, you are going to get a good salary again, right? Now what we are going to do, we are trying to find it out the expectations, but before that we will try to understand the correlation. So this plot will help us to understand if there is any multicollinearity in the data set, right? How we can do that? We have written PLT is basically Matplotlib, plt.subplot, and we have given the figure size 20,10. Now we have given the data dot correlation to understand the correlation between different columns you have. right? Can you see, is it correlated or not? So we have used again heat map from Seaborn, and if we just execute that, you will get us beautiful looking, metrics like this, right? This is nothing but your correlation tricks in order to understand is your data correlated or not. So obviously total experience and total experience will be 1 1, and this will be 0.98 0.98, obviously, right? So this is something you can totally understand how it's going to work. Experience, so year of experience to year of experience 1, salary to salary will be 1. So obviously this will be the high correlation, but in the case of this 0.98 0.98. All right, so this is what and how we are going to do the correlation. Now, after we have done the correlation, we have to go for making a model in linear regression. But before that, we want to just, divided our data set into 4 parts. One is training, one is testing. So basically, you have two particular, okay, I will show you how can we actually make it 4 parts. For now, we just understand we have to break our dataset or divide our dataset into 2 parts. One is for training, one is for testing. Now, while it comes to training, we will give our data in the training part to see how our model is working. In the case of testing, our model will not see the data. While we are going to do this particular testing with the new dataset, that time only our model will see that. Okay. Now what I have written from sklearn.model selection, I have imported train test feed. Okay. Just don't look at here right now. Okay. Let me do that. Now what I want to do, I want to split my data set. Okay, how we can do that? So before splitting our data set, I want to do one thing. So I have written data.drop. So as we were saying, while we have data and we will have a, yes. So as we are going to have the salary and the year of expectation, year of experience. So in that case, what's happening? Our data of salary, right, is your like label column. Okay, so we try to predict that only. So we will drop that particular column from our data. So we are going to write data.drop. Then we have dropped salary and we have stored it to X. And now Y will have your salary column, right? So you have understood X and Y. Now if you just write X, after doing this, if you just write X and Y, let me just print X and Y. Print X dot height. So you can see what is X and Y. So your X is year of experience and your Y is nothing but the salary. Let me just do that. So this is year of experience, right? And your Y will be your salary. Yes, so your Y is salary and X is experience. Now we are going to make it 4 parts. As we have 2 parts already. Now we are making X of train. Matlab X train is basically your experience. X X test your experience for testing part. Y train is again for salary for the training part. Y test is salary for testing part. So we have called train test split function and we have given xy. Now we have written t size equals to 0.2. What does that mean? Because you can say that training part you are going to use the 80% of your data set and the training purpose you are going to use 20% of your data set. And while we are writing random state equals to 42, it will take randomly data. There is no such rule. The first 80% will go for the training and 20% will go for testing. No, it will take any data from anywhere and it will basically just mix the data, right? So that's why we have written a random state equals to 42. Now, if I just write from sklearn.linear model and if I just import linear regression, then we have called our regression model. That is linear regression. Right, after we called our model, we have written L.fit. So basically, we are going to fit the model with the data set, that is X train and Y train. Okay, And then we have the prediction. Then we have written ypred equals to L dot predict and then xtest, right? So you have given your testing data. Now I will show you what is your, predicted value and what is your actual value, right? So your ypred will have all the predicted value. Now if you want to get the score, what is the score for your predicted value? You just need to write L dot score. It will give you how your model is working, and you can say 89%. With the 89% of accuracy, your model is working. Now if I just do one thing, print actual salary, then comma, we have written y. Y, right? Okay. Or we can write y test. Okay. Now here we can write print predicted value, salary. Then we can write y print, right? Let's see. Okay. So your actual and predicted is okay. Y test. Okay. Let me check why it's showing that. Okay. Okay. So let me write y over here. I'm not sure this is okay, right. So here why it's taking this. Okay, fine. Right. So we have done this over here. Can you see this is your predicted value? And if I just write the actual salary here, so these are your predicted value while it's talking about that. Yes, can you see? Yes, so this is your actual value and that was your predicted value, right? So this is how we can do the salary expectations based on the experience, right? And this is how we can make a model out of it, and we can do say, okay, if you have experience like this, then my model is saying your predicted value or your expected salary will be this, right? I hope you like the project. Please do let me know on that, what you feel about it. And also do not forget to like this particular video and do not forget to subscribe. Great learning. Then we will again do a mind-blowing project on Uber data analysis and also the cab fare prediction. Right? So please let me know your thoughts about this particular project and then we will move forward to the next project. In this part, as we have already talked about regression, what is linear regression, how can we actually use linear regression technique, and where are the data set you can go for, we have talked about everything. We have done one project on linear regression as well. Now in this part we are going to do the Uber data analysis and we will try to predict the fare price, right? So what are the library we are going to import for that? Numpy, Pandas, Matplotlib, Seaborn, and also we will import linear regression from scikit-learn, right? And what are the dataset we have? We have dataset of cabrides.csv and we have dataset for weather.csv, right? So these are the dataset we have. Now if you just want to talk about cab data head, right, what it will give? It will give you your cab data, right? And we have weather data. So here you can see we have distance, cab type, timestamp, destination, all these things. Now if you want to see the columns for that, okay, we will do this later. So now if you want to see the columns for that, what do you need to do? You just need to write cab_data dot columns. So it will give you all the columns you have in the cab data set. Now if you want to check the shape of the data set, what do you need to do? You just need to write cab_data dot shape, right? So you will get total how many columns you have, total how many rows you have. So you have column of rows of 693071 and you have 11 columns, right? This is pretty much big data set, you can see from here. Now if you want to check the weather data set that we have read as well, so in this case you can see let me just show you the weather data set. So in this case we need to write weather underscore data dot height, right? Okay, so you can see this is the weather data set. Now, if you want to see more things about the data set, not the text one, I want to have the code one, right? If you want to see the shape of the data set, let me do that. Weather dot shape, right? So the so sorry, weather data underscore data dot shape, right? So yeah, what you will get? You will get 6276 data. I mean, total rows you have, and 9 columns you have, right? Now, what I'm going to do here, you can see we have done this column shape, all the basic things is done. Now, I just want to change my date time, right? So before doing that, let me describe my data as well. Cap data dot describe, right? What you will get? Okay, let me put the parenthesis. Okay, can you see? For distance, timestamp, price, search multiplier, everything you get about the describe one. And I know you guys have idea about why do we need to use describe. Please do let me know in the in the comment section. For that I can understand you guys are how much you guys are reminding that why do we use describe, right? And if you like the video, do not forget to like it and do not forget to subscribe. Great learning. And what one more thing I just want to update you guys that if you feel like you have any doubt, please do let us know in the comment section. We are happy to help you, right? So yeah, this is about the describe, this is about the info you get. Now I just want to change my cap data date time to actual date time. For that, what I need to do, I have to import date time, and then I have written cap data. From there, the column name date time equals to pd dot to underscore date time. So anything you want to change, you need to use to underscore date time, and then in the parenthesis your name, like which name and the data you have given. Now for the weather also we did the same thing, right? We have changed our date time column into actual date time, right? Now we have done the shape, we have done this. Now what we want to do, we want to go for again description. Here description, you can see this is the timestamp you get, right? The distance, price, search multiplier you get over here, right? And this is the describe for this. Now if I want to just concat the two data set, right? We just want to concatenate two data sets like cap data and weather data. How to do that? We have just used pd dot concat, and we have given the two data set, cap data and weather data. And now A will consist of all the concatenation of two data set. Now I have written, now I just want to see my data set. After I concat them, I'm going to write a dot hit. Let's see. Yes, this is my data set. Here I have distance, cap type, timestamp, destination, source, price, search multiplier. Here I have ID, product ID, name, date time, pressure, rain, humidity, right? So this is what we have done. Now if I just write want to get the day and the hour, how to do that? In this case, time.dt.day, right? And a of hour equals to, basically we have changed, do this data pre-processing to make our data more perfect. Now if I just want to okay, no, I don't want to fill nan values. Okay, here first I want to show you what are the nan values I had. Okay, it's taking time. Right, cool. Let me just do this again because I want to do this one more time, because I want to show you what are the how many nan values we have, right? Let me show that. Okay, after that I just don't want to fill my nan values with 0. I just want to show you a dot is null dot any, right? If I have, then I'm going to use the dot sum function. Yes, I do have lots of null values, then I just want to use dot sum, total summation of the null values. Okay, we have a pretty good number of null values. We can just need to fill that it with 0. Let me fill that with 0. Okay, so we just cannot go for so many null values. What we can do, we can fill them with the median, or we can fill them with the 0, anything you want to go for. Now I just want to group by the cap type, and I want to get the count of that. So total type of cap type, so cap type is Lyft, Uber, you get, can you see, this is your cap type. Now if you want to group by cap type and count, and then if you want to plot the bar plot, yes, this is how you can do that, dot count plot dot bar. So this is the color code you have for distance, timestamps and all, and this is the cap type you have, right? This is Lyft, this is Uber, right? So you can see this, all the parameters you get for different cap type, right? Now if you want to see the price, how can you do that? What I have written price dot value counts dot plot, then bar, and this is like what color I want. Can you see, this is the price plot, right? The value counts right here. Okay, now if you want to see the hour, like this is nothing but the data visualization we have done. For hour you can do the bar plot, and then here we want to do the plot, like what, hour basis price. So this is what we get, like this is the hour, this is the price, and then we have plot them, right? And this is for rain and price. Suppose it's raining, and if you want to change, like see the what is the price difference and what is the plot, it's for the data set you have the data points, this is what you get, right? And these are the columns again, you know. Now for making the linear regression model, what are the things I want to take? I want to take distance, temperature, cloud, pressure, humidity, wind, rain, day, hour, surge multiplier, and clouds. And for the prediction, we are going to take the price. Now from scikit-learn model.selection import 10 state split, we are going to split our dataset into two parts, training part and testing part. We have 4 things like X train, Y train, X test and Y test. So 25% of the dataset will be test size, and 75% of the dataset will be train size for that. Now I have just written linear.fit, and I have given my X train and X train and X test, right? So this is how we have done the linear regression, train the model. Now if I just want to predict, so linear.predict, then you have to provide Y train. Now if you want to check the actual price versus the predicted price, so your actual price is 42, it's showing 32.54. Here it's 32, it's 16. Okay, so there are here and there, like it's here 7.5, it's showing 10. So these are pretty much near, right? You can see 9, 11, 8, 11, 27. This is again some here and there is there, right? So this is what we get for, like, after putting the linear regression. Okay, and yeah, so here you can see we have written the df.head, and you can see here, like, can you see, this is what we have done the data visualization, and this is what the actual versus predicted value you get, right? And if you just want to print the prediction for this, let me do that, right? So we have done, yeah, these are your prediction values. So we have done our linear regression concepts. We have talked about diabetes prediction using linear regression, not diabetes prediction. We have done the outlier detection using PIMA diabetes 1, right? And for salary prediction, we have done the linear regression one, right? So we have done 2 projects on linear regression. One is salary prediction using based on your experience, and one is Uber data, right? So I hope you like it, and if you like the video, do not forget to like it and do not forget to subscribe. Great learning.
In this part, we are going to talk about the logistic regression. That is also comes under one of the supervised learning technique in machine learning, which used for classification algorithm. Now let's have a look at what is logistic regression. Logistic regression is also a part of supervised learning classification algorithm.
That we already know. It is used to predict the probability of a target variable. Yes, it's basically used to predict the probability of a target variable, and the nature of a target or a dependent variable is discrete. So for the output, there will be only two classes will be present. As we have talked about the dataset of diabetes dataset, so we need to try to find it out the particular person is diabetic or not, depending upon the other dependent variable. The dependent variable is binary in nature, so that can be either 1 or 0, yes or no, true or negative. Right? So this is how you can understand that this will be only two classes we will have. The logistic regression is also known as sigmoid function. We have a function called sigmoid function, and we use this particular concepts in logistic regression. The formula for the sigmoid function we know, that is 1 by 1 plus to the power minus value. Now, if we talk about how actually logistic regressions comes into the picture, and if we just go back a little bit and we just try to understand the linear regression. So in the case of linear regression, as it's a regression and it's a continuous value we use for that, we use a one particular formula that for that y equals to mx plus c, the straight line formula. So in this case, if we just put that particular formula for this, the case of the finding out the size of the cat, so we know the size of the cat is 2.1 into weight plus 4. So maybe if I just write weight equals to 0, then also the predicted size for that cat equals to 4. Is it really possible the particular cat has a 0 weight but the size is 4 inches? No, right? How even it's possible that there where actually linear regression fails and the logistic regressions comes into the picture. So we can see the logistic regression is similar to linear regression, except it predicts whether something is true or false instead of predicting something continuous like size of cat, right? So here you can see the probability of cat is obese here, and the probability of that the cat is not obese is there, right? So there you can see this is the probability of cat is obese and this is the probability of cat is not obese, right? So here we are just going to predict yes or no, true or false, and this is where logistic regressions comes into the picture. So if you can see, if you get your point and probability near to 1, we can see there is a high probability of the new cat of being obese, and if you get the probability near to 0, you can say there is a high probability that the particular cat is not being obese, right? The curve tells the probability of the cat being an obese based on its weight. So this is the S curve. This is known as the S curve basically we use in logistic regression, right? So this is like little bit about logistic regression. So if you get your point near to not 0.5 and 0.5.5, there is a 50% chance that the cat is obese and that cat is not obese. The curve tells the probability of the cat of being obese and based on its weight, right? So this is how this logistic regression work. So if you get the point is near about to 0, the very low probability of the light cat being an obese. So it's generally used for classification. For example, if the probability of a cat being obese is greater than 50%, we use a threshold value. So if we see the probability of the like you get the probability which is greater than 50%, then it is classified as obese. And if it is less than 50%, then it will be classified as not obese, right? So this is how our the logistic regression works. Now if we just look at the mathematical explanation of logistic regression, from where this logistic regression comes. So logistic regression is a special case of linear regression, we can say. So we know for linear regression we use a formula that is y equals to mx plus c, and in the more data points we use y equals to m1 x1 plus m2 x2 plus ... and so on, where we are going to use a function in logistic regression that is p equals to 1 by 1 plus to the power minus y. This is nothing but your sigmoid function. Now if you just replace your m1, just p, what we have basically here, if you can look over here. So if you just have e to the power minus y, so if you just replace your minus y equals to m1 x1 plus m2 x2 ... and so on, you can see you will get the formula of logistic regression. So this is nothing but related to linear regression, but here we use classification. So we do yes or no, true or false, obese or not obese, and so on. So this is something about logistic regression we learned. right? So if you just want to check the real-time use cases that come under logistic regression problem, maybe you just need to, will that property have a good neighborhood? Maybe that property have a good neighborhood, maybe not. Is this mail is a spam mail or not, right? So these are the things you can understand by using logistic regression algorithm. Now we will talk about the few key points we have in logistic regression. That is, it's a categorical variable, solve classification issues, not the continuous value problems. It has a S curve, and it is like the example of it is the mail is particularly spam or not. So yes, this is all about logistic regression we have learned so far, the mathematical explanation of logistic regression, why logistic regression comes into the picture, and what are the key points we have in logistic regression. Now we are going to do a project on logistic regression, that is credit card fraud analysis using this particular algorithm. And we will see that particular transaction is a fraud transaction or is a genuine transaction. In this part, we are going to talk about credit card fraud analysis using logistic regression. In this part, we are going to do an end-to-end project using logistic regression to find a transaction is a fraud transaction or not, right? So in this case, we are going to use a data set from Kaggle itself, and we have actually uploaded this data set to Dropbox. Now, if I just want to show you the data set, so in this case, let me just show you what we have in the data set. But before start with the data set, we just need to understand that what are the things we have in the data set. So always look into the raw data to have a good understanding of your data, right? It's too big. Let me just download it. Okay. Right. So here it's not getting downloaded, but it's already there in my local system itself. So if I go here and let me just write credit card. Right here. Let me just open the data set to make you understand what we have in the data set itself, because we have talked about we have few types of data sets. One is continuous type data set. Your dependent variable will be continuous type. One will be your data set will be categorical data set. So you have classes. So here we will have two classes. One is the transaction is a fraud transaction or the transaction is a normal transaction. So it's a big file. It's a big CSV file, that is comma separated file. So it is taking little time. So when it's going to be open, and I will show you what are the columns we have in our data set. Basically in the data set we need to check few parts, that is dependent variable, independent variables, and what is the type of your data set. So this your dependent variable is a continuous type or your dependent variable is a categorical type, right? So in this case our data will be categorical as we will have two class, right? So it's almost 92%, yes. So if you just look at the data set, you can see we have time column, then we have V1, V2 and so on, and lastly we will have amount column, and then we will have class column. So the amount is nothing but the what is the amount of the transaction you have done, and class is 0. Basically this is a genuine transaction. If the class is 1, do we have anything 1? If we have 1, then the transaction is a fraud transaction, right? Let me just check. Do we have, did we just missed one? Okay. So if we have 1, so that means that transaction is nothing but the fraud transaction. Let me just check more. So it's a big data set itself. So if I just scroll it down a little bit more, did I get any transaction with 1? No, I don't get it right away, but it's fine. So let's go to Anaconda and not Anaconda, let's go to Google Colab and let's have a look at how to go with the data set, right? So I have just uploaded the dataset to Dropbox, and there you will get this shareable link, and in the shareable link you can use in the Google Colab itself. Now if you just look at what are the libraries we have imported Numpy, Pandas, Matplotlib, then matplotlib.pyplot. This is .pyplot is nothing but it's a MATLAB, right? You can directly use the MATLAB function, so this is why we use .pyplot. Then we have model selection, that train trace split from scikit-learn to split your dataset. Then we have classification report just to check what is the report accuracy. Then you have confusion matrix. We will talk about what is confusion matrix. Then we have import the logistic regression, as we are going to use logistic regression. And from there we have matrix and Seaborn, right? Seaborn is also a data visualization library, right? So this is the dataset link, right, from the Kaggle itself. If you just click on here, you will just redirect it to Kaggle website itself. It's a open source data, anyone can use it, right? So this is all about the data, right? You can see this is the data set, right? So you can directly download it from Kaggle itself. Just click on download, your dataset will be downloaded. Now if you don't want to upload your dataset into Dropbox, then how to upload directly? Here is a box sign, you can see. Click over here. Here you will get an upload option. Just click over here. It will redirect to your local system wherever you will have the the dataset. Just suppose technical support data I have, just click over here and then open. It will automatically upload the dataset, right? Let me just do that. Right, so you can see your data is already here, but be sure this data, whatever the data you have uploading in Google Colab, it will stay for only 12 hours. After that it will be recycled, right? So whatever the work you are going to do in Google Colab, make sure that you have downloaded. Right, now we need to use the .read CSV function from Pandas. So .read CSV function, how it works, it's nothing but it's going to read the comma separated values, right? So in this case, you have to give the path for your data set. But wait, from where we will get the path? We have just uploaded the data set. So here you can do one thing. If you just hover over this data set you have, and you will get a 3 points over here. Just click over here, you will get the option for download. If you want to delete the file, delete. Then rename if you want to rename the file, and copy path. So if you just copy the path and if you just put the path over here, it will automatically read the .csv file. Right? It's automatically reads. Right now, if we talk about the dataset, it contains 285000 rows and of the data and 31 columns we have. The most important columns are time, amount, and the class, that is fraud or not fraud, right? And if your class is equals to 0, it's not a fraud transaction, it's a genuine transaction. If your class equals to 1, it's a fraud transaction. Now, if we just want to see the first 5 rows of our data set, how to do that? You just need to use data df, where we have actually, if you can look at the variable, we have stored our CSV file, that is data df, and if you just write data df dot head, you will get the first 5 rows of your data, right? Can you see time, v1, v2, v3, v4, and so on, and amount and class, right? You have. Now, if you want to check the shape of your data, how to do that? You just need to write data df dot shape function. It's going to return you how many rows you have, how many columns you have. So we have total 284807 rows and 31 columns. Right, now if you want to check the describe, so where to use describe? And one more thing I want to show you, if you want to check the columns, so data dot column. So basically it will return you what are the columns name you have in your data set. Sorry, it will be data df, right? So what are the columns you have in your data set? So these are the 31 columns I have in my data set, right? Now if you want to check the describe, so describe is nothing but it's going to return you some statistical information about your data set. So particularly for these 3 columns, I want to check the statistical information of my data set. So in this case, I have written amount, time, and class, right? Can you see the list I am providing here? And then we have using dot describe function. So if I just click over here and just execute it, you can see we have total count of the data, you have the rows, then you have the mean value, right? What is the mean of your total column? Then you have standard deviation, then you have minimum amount you have in your data. Then we have IQR, that is interquartile range. So interquartile range, if you want, if you just divide your data set in 4 different parts, first quantile, second quantile, and third quantile, and so on. So this is 25%, 50%, 70%, and max. So this is all you will get about if you just use dot describe function, right? Now it's just columns is already done. Now we are going to check, is there any missing value do we have in our data set? as we have talked in that as well, this missing value, if you have missing value in your data set, it's not going to provide a good prediction for your data. It's always give you some arbitrary predictions, and it's also not perform well, right? So in this case, make sure that your data does not have the type of the missing value. The missing value will be really less, right? So in that case, to check with missing value, what we need to do, we need to use one function that is called isAny function. Let me just cut this part. Right, if I just use datadf.isAny, that time you can see it's going to provide me for each and every rows and columns, right? Maybe for each and every index itself, it's going to give you is there any null value is there or not. But looking at this like this, it's not possible to, you can see the most of the cases is false, but maybe there is a true, maybe you will not able to find it out. That time we are going to use a function called .any. So .any function, what does this .any function? It's going to check for each and every column, is there any null value is there or not. Is there any null value, it's going to return you true, otherwise it's going to return you false. Normally it returns the boolean values. For time there is false, for all the cases you can see there is false, so we can say there is no missing value. Now if you want to again reconfirm it, we have done a manual job, right? So what we have done, we have used the columns, and we have actually making a data frame here. Here we have columns, that datadf.isAny dot sum. Is there any isAny, that what is the sum of the dot, null functions we have, or not the null function, not the null value basically we have. Then we have if you have then dot index, then number of null values, right? So what is the number of null values you have, then values, then percentage. So basically we want to check what is the percentage of the null value we have. Now if we just print it, so what we will get, columns, the column name, we have the number of null values, that is 0, and lastly we have percentage. What is the percentage of null value we have? So here you can see this is all as 0, right? So we can say the null value percentage is 0 for this particular data set. But normally for the real time cases, you will not get a data which has 0 null values. So always you have to try to understand how to find it out, the null values and the missing values as well. So now if you want to check the last 10 rows of your data from the class itself, you just need to use .tail function. Can you see? We got it. Now we are going to check the percentage of total number of fraud transaction. So I want to see what is the total number of fraud transaction we have. So in this case, we are going to use one particular variable called nf count, right? That is equals to 0. Now what I have done, not fraud, right? Or maybe you can make it genuine transaction. I have written not fraud equals to datadf, and we have taken only the column, that is class column, right? Now we have used one for loop for I in range, and then it will go till length of the not fraud, right? So it's basically doing what? It's taking the length of the, let me just show you what we are doing here. So this is something not fraud transaction. We were taking the class itself, right? So here if I just write not fraud, right? So it will give you what? The total length of your data. So your for loop will run or execute till this 284807, right? Now what we are going to do, if I have written not fraud, this particular variable equals to 0, then we are going to count the nf count equals to nf count plus 1, right? So basically we are trying to find it out, the total number of genuine transaction we have in our data set. So in this case you can see, yeah, let me just print it here, right? So firstly we will try to find out the total number of not fraud transaction, and then we will do the percentage of that, right? So here if I just print it over here, can you see the total not fraud transaction, that is 284315. The total number of length of data we have 284807. Here we are getting not fraud, that is genuine transaction, that is 284315. So we can conclude one thing from here that the fraud transaction is really less in our data set. Now if you want to check the percentage of it, the normal percentage formula, we have just taken NF count divided by length of not fraud transaction into 100, right? So not fraud transaction is nothing but the total length of the column, and NF count is basically the total genuine transaction into 100. If I just print it, the percentage of not fraud transaction or the percentage of total genuine transaction in the data set is nothing but, you can see, 99.82%, right? So there is very few transaction we have as a fraud transaction. Now we will do the same thing to find it out the fraud transaction. So we are going to take f count equals to 0, one more variable, and from there we have fraud equals to data df and class. Again we are taking the column of class. Now we have written for I in range the same thing, the length of fraud. Then if we have written here, look at this if statement, the conditional statement, we have written if fraud of I equals to 1, then only f count equals to f count plus 1. It's nothing but the small logic, right? From here, if I just write, okay, different cell for like the different one. So here, if I just write the f count, you can say the total fraud transaction in our data set, that is 492. Now, if I just print out the percentage of the fraud transaction, that is 0.172. But yes, we do have fraud transaction. We cannot ignore it, right? From here, we are trying to find it out the visualization, the data visualization for genuine transaction and the fraud transaction. So here for data, plotting the data, right? So here we are taking one data frame. First, we have created our empty data frame here, plot data, that pd.data frame. So this is how you can create a empty data frame. From there, the plot data equals to fraud transaction. So fraud transaction, the column name will be fraud transaction, and we have written the fraud.
So what we were doing, we were actually trying to figure it out, what is the percentage of fraud transaction you have in your data set and what is the percentage of genuine transaction you have in your data set. So for that, what we have done, we take a variable called NF count, and this is equals to 0 because it will work as a counter, right? Now what we have done, we have written not fraud equals to data df, and then you want the class, okay? So whenever, let me just add one cell over here. So whenever we try to get like particular cell, like a particular column from your data set, that time what we have done, so we try to take the particular column name, right? So for my case, I'm going to take class, right? So you can see what it actually have. This class is nothing but your outcome, and it is a dependent variable on other columns you have. And in here you can see it's not fraud equals to, we take the whole class, right? So now what we are actually trying to do, we will try to count all the one, right? It's not fraud. So basically we will try to count all the zero, like how much zero you have in the particular column, and divided by the total number of records you have into 100. So that's how we can actually understand the percentage of genuine transaction in your data set. So in this case, what we have done, you can see not fraud equals to data df class. Now we have used a for loop, and we have written that for I in range length of not fraud. So it will go the length of not fraud. Like for this, you can, if you want to see what is that, let me just write it over here. So not fraud, right? If we can do this two particular place over here, and if we just write one more code cell, let me just execute that. Now what we are going to do, we are going to say not fraud, okay? And here we have used length function, right? So you will get nothing but the length of the not fraud. So total number of rows you have in your data set. So you can see this is 284807. Right? So now what we have done over here, we actually, your for loop will walk till this part, right? And if said, if not fraud of I, not fraud of I is basically the value you have, not the index number, 0 or 1. So not fraud of I equals to 0. If it's equals to 0, then please increase the counter. My counter is NF count over here 0. It will count 1 plus 1 plus 1, right? Then what we have done that the percentage. So you got that NF count, right? Here you got the NF count. So now you know how much, like if I just write here after this, if I just, okay, let me just break it in few parts for that you can understand what actually we are trying to do. So here, right. So in this NF count will have all the count of 0 you have in your data set. So you can see 284315 records you have, they are 0. Basically, they are the genuine transaction. Now, what I have done, I just want to understand the percentage. So NF count divided by total number of records you have into 100. So for that, you will get the percentage of total not fraud transaction or the genuine transaction. So 99.82% of data set you have, that is a genuine transaction. Now we will count the fraud transaction in the same way. Again, we will take a counter over here. From there, you can see the fraud equals to, we take the class again, and what we are doing, we are writing fraud of I equals to 1. So we will try to understand how much like data or rows we have with class 1, right? So that basically nothing but your fraud transaction. Okay, so let me just do this as well. Right, so in this case you will get the F count 492, right? It's a very negligible, but yeah, there are fraud transaction you have in your data set. So now if we just try to find it out the percentage, so it's nothing but 0.1%, right? So this is how we have understood that what is the percentage of genuine transaction you have in your data set and what is the percentage of fraud transaction you have in your data set. Now if you just need to plot it, right? How to do that? In this case, you have written plot data equals to pd.data frame. You have created a empty data frame over here. Now you have written plot data fraud transaction equals to fraud. So the fraud you had, right? Now you just give plot data genuine transaction, right? Genuine transaction equals to not fraud. Then plot the data. So here what we have done, if you can look over here, right? So not fraud, it will become your F count. And this will be less, I think, right? And it will be in F count if I'm not wrong, but it's, yeah, right. So here you can see one thing, your fraud transaction will be, so you basically try to understand your fraud transaction and your genuine transaction, right? So in this case, what you have done, if we just remove this two part, right? Let me just do that. And let me just write plot.head. So basically you can do it, otherwise you can skip it as well. That's not the problem. Plot data. No, it's not coming. Why? Acha, okay. Fine. Why it's not coming? Because this F count is nothing but your total number, right? And this is how basically you can skip this part. There is no point of using, but yeah, if you want to make a data frame out of it, or if you just write the transactions, maybe you can write the transactions and you can use the data df. Now if you just try to print it, you can see only the transaction, only the class column you will have in this particular data frame. Now what we need to do, we try to understand and visualize our data. How to visualize our data? We try to understand that what are the data are actually going to help us to understand what is the bar plot. We actually do bar plot to understand visually that what we have done, the calculation that is right or wrong. So in this case, what we are going to do, we are going to write plt dot, you can say plt dot title bar plot for fraud versus genuine transaction, right? So you can use bar plot or you can use count plot as well, right? So you can see what we have done. We have written x equals to fraud transaction, y equals to genuine transactions, right? And what we need to do, we basically try to give the data set over here. So here you can see what we have done. We were working with the bar plot, but now I want to have a count plot, right? So count plot over here will work as like, it will automatically count. Otherwise, you need to do all the count by yourself. So in this case, what we have done, we have written plt.title count plot for fraud versus genuine transaction, right? So now you know for 0 is genuine and 1 is fraud transaction. So if you just write SNS from Seaborn, basically if you write sns.countplot, you can see this is the all about count plot, show the count of observation in each categorical bin using bars. So you have two bin over here, 0 and 1, and a count plot can be thought of as a histogram across the categorical instead of quantitative variable. The basic API and options are identical to those for bar plot, so you can compare counts across nested variables. Input data can be passed in variety of formats and including the vectors data represented. At least there is no point of understanding this, but now you can understand. It will automatically count how many 0 you have in your data set, how many 1 you have in your data set. So what I have I have written that x equals to class, then data equals to data df, your data set, then palette equals to blues, I want the blue, and then age color equals to w, right? So you can see for in this case, whenever I try to execute it, for that you can see the 0 is the high, 1 is almost negligible, right? So you can see and you can say, okay, whatever the percentage we have, find it out, it's quite right, because in the bar graph in the count plot itself is showing the same, right? So as for the graph, we can see the ratio of genuine transactions and higher than the fraud transaction, right? So now if you want to check the plot, normal plot, how to do, you just need to write maybe for the x and the y, I just want to check between amount and time. So in this case, I have written data df amount and y equals to data df time, and then I have written plt.plot xy, and the title will be plt.title time versus amount, right? So in this case, you can see this is the relation between amount and time, and this graph we try to plot the relationship between time and amount. You can see this is the time and this is the amount, right? X equals to, we did, okay, x equals to amount. So these are the 5,000, 10,000 to 15,000 is your amount, and this is your time, right? How much time it takes to do the transaction. Now if we just try to understand the amount distribution, where the amount is high, where the amount is like, what is the distribution of your amount you have in your data set, that time again we are going to use this plot, right? So this plot is kind of a histogram type of a thing, you can say. So here we are going to try to do the amount distribution. So in the amount distribution, what we need to do, we try to understand the distribution of the amount in our data set. So here we are going to use Seaborn displot. So you can see we have taken only the amount column. Now what we have done, color equals to red. I just want the distribution should be looks in red. So in this case, if you look over this, you can check, you can see from the amount distribution curve, it's shown that the number of higher transactions are very low. Obviously, so you can see this is the high transaction are really low. Most of them are in between 5,000, right? And so there is a high probability for huge transaction to be fraud, right? So this is the high. If you see there is a 25,000 and more like amount is high, so at that time there is a chance that your transaction is a fraud transaction, right? So now we will talk about the outlier. So for outlier, we can use box plot and we can use scatter plot as well. So we try to understand, because of this problem, we need outliers, because those transactions in a high, high amount, that time there is a chance that these are the outliers, and these are the cases where we need to find it out that, okay, these are the cases for my transaction can be fraud, right? So in this case, we try to use scatter plot. So that dot scatter, if you just call dot scatter and if you just give it your your scatter plot will be plotted using your data set. You can see this 25,000 only one dot here. So these are your data points. Most of the data points are from 0 to 5,000, and after 10,000 also you have, but after 10,000 all of our is your actually outlier, right? So in this case, we need outlier to understand the the fraud transactions behavior. And now if we talk about the correlation matrix, yes, there is a concept of correlation to understand the correlation between two different variable you have in your data set. So in this case, correlation matrix equals to data df dot core if you write, and if you just plot it With the figure size, I have given 14,9. And if you just write a Seaborn.heatmap, it's nothing but it's going to give you the, the correlation between two different variable for time and time. You can see it's you can say this is quite white. So this is the color range is also here. When it's quite white type of a thing, it's the high correlated. When it's near to black or blue and something like that, it's the correlation is low, right? So this is how you can understand the correlation between two different variable you have in your data set. So correlation matrix helps us to understand the correlation between two attributes, right? So now, yeah, it's pretty much about the data set. We have done the outlier analysis. We try to understand our data. We try to understand the fraud transactions. Now what we need to do, we just need to split our data for machine learning. So splitting our data is nothing but you can split your data at 80 and 20% or maybe 70-30%. It's up to you. So 80% for training, 20% for testing. So when you do the model training, that time your model will not see your testing data. So it will be a new data for your model, right? So for that, you can see for x equals to df data df dot drop. So we try to have all the features in x, and the outcome column, the class column, the dependent column for others will be stored in y, right? After that, what we have done, we use scikit-learn to split our data. We have used we actually split our data in 4 different parts: x train, x test, where you will have all the features; y train, y test will have the class, right? And train test split function you have to call, and then you need to pass your x and y. Then you have written test size equals to 0.2, that is nothing but 80 and 20%. If you write 0.3, it's nothing but 70% and 30%, right? And random state equals to 42, because we try to say that there is no hard and fast rule that first 80% will be for testing, will be for training, and 20% for training testing, right? So it's like randomly it will take the data and it will just make your testing and training data set, right? So yeah, it's pretty much about the x train, y train. Now if you just want to check the shape of x train, you can write x train dot shape. Right, what you get this 2 2 7 8 4 5 30, right? And if you just do the x test, you can check your shape like this. I will get an error. Okay, right, for testing you can see 5 6 9 6 2, and this is 30, right? So this is how your x train, x test, y train, y test works. Now if we are going to use logistic regression, we talked about logistic regression. For scikit-learn, what you need to do, you just need to call the function, right? Because there are a lot of all the you can say all the machine learning algorithm are already implemented in scikit-learn. So what we need to do, we just need to call logistic regression function, and you can see this is the logistic regression function we have called. Now if you want to train your model, you just need to call dot fit function, and you will provide x train and y train, right? Let me do that. Now if you want to check what is the prediction for your model, that time what you need to do, you have to use dot predict function, and this time you are going to give your only the features, and we will try to find it out what the class, right? So whenever you try to use ypred, and we are going to give the logistic regression dot predict x test, and if we just go here ypred, right? So here we will get all the cars 1 0 0 0 0 0. So now if we try to understand the accuracy, we need to call one more function, that is logistic regression dot score, and you have to pass x test and y test, right? So now if we just try to understand what is the accuracy, let me just, so accuracy is 99.85%. So yeah, your model is working pretty cool and pretty fine. And if you want to add few other things, you can, right? And one more thing, I just want to explain that what is confusion matrix. So whatever the accuracy we have done over here, there is one more concept from those matrix as well, you can find it out. So in this case, we called confusion matrix. In confusion matrix, we have few parameters. There's positive, negative, true positive, false positive, true negative, false negative, right? So what is positive? Observation is positive. For example, the transaction is true. Then observation is not positive. For example, the transaction is not genuine, Then we have term called true positive. What is true positive? The observation is positive and is predicted to be positive. That is true positive. So both the cases is positive. Now comes false positive. So here you can see observation is basically negative. The predicted value is positive. Then your model is not perfect, like working well. Now comes false negative. So observation is positive, but your predicted is negative. Again, your model is not working fine. Then comes true negative, when the observation is also negative and the predicted is also negative. So when you're have more true positive and true negative, your model is actually working quite fine, because what your model is quite understanding with the new data that whatever it needs to be done, right? So yeah, right. So the formula for accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Right. So this is known as confusion matrix. And if you want to do this confusion matrix, if you want to check the confusion matrix, you need to write, and you also again need to import matrix, and after importing matrix, you need to call dot confusion matrix function, and you have to give y test, that actual class, and then y pred, that is actually predicted by your model. Now if you can look over here, this is your confusion matrix, and if you want to do the calculation of accuracy the same way, and you will get that 99.85% accuracy. With this percent of accuracy, your model is saying whatever you have done, it's right. So this is how we can actually start working with logistic regression, and I hope you understand that how can you start working with your new project on logistic regression. In this particular video, we have talked about what is data mining, what is Python, and how can you get started with Python. What are the libraries we need to actually do our data mining in our huge number of data. We talked about regression analysis, classification analysis, and also cluster analysis. We hope you actually like this video. If you like it, do not forget to subscribe Great Learning and do not forget to like it. And please do let us know in the comment section what you feel about this video. Thank you so much. I want to introduce you to Great Learning Academy, a free initiative by Great Learning, where you can access over 200 plus courses with 1000 hours of free content on trending high demand domains such as data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps, management, and many more. That is also for absolutely free. Award-winning academicians and leading industry experts design these courses. You can also get a free certificate of completion when you enroll and complete these free courses. You also get access to the presentation, code, notebook, dataset, and quiz. You have courses in English and Hindi to give you the best learning experience in the language you are comfortable with. Check out the description of this video to access the relevant courses on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out our any new update or video release from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video any queries or suggestion, and I will respond to your comments.